네, 잠시 후 10시 30분부터 2021 강원 그린바이오 국제 심포지엄 행사가 진행될 예정이니 참석자 여러분께서는 자리를 정돈해 주시기 바랍니다. 코로나19 확산 방지를 위하여 객석 간격을 유지하여 앉아주시기 바라며 행사 중 마스크를 반드시 착용해 주시고 행사장 내 손소독제가 배치되어 있사오니 수시로 이용해 주시기 바랍니다. 아울러 행사장 내부에서는 음식물 섭취가 제한되오니 이 점 양해 부탁드립니다. 오늘 행사는 한국어와 영어로 유튜브를 통해 생중계되고 중국과 베트남을 온라인으로 연결하여 진행하고 있습니다. 원활한 행사 진행을 위해 소지하고 계신 휴대폰을 진동 또는 무음 모드로 전환해 주시기 바라며 행사장 내 원활한 인터넷 상황을 위해 와이파이도 비활성 모드로 전환해 주시면 감사하겠습니다. 네, 다시 한번 안내 말씀드리겠습니다. 잠시 후 10시 30분부터 진행되는 2021 강원 그린바이오 국제 심포지엄 행사가 진행될 예정입니다. 모두 자리에 착석하여 정돈해 주시기 바랍니다. 코로나19 확산 방지를 위해서 객석 간격을 유지해 앉아주시기 바라며 행사 중 마스크를 반드시 착용해 주시고 손소독제가 비치되어 있사오니 수시로 이용해 주시기 바랍니다. 아울러 회사장 내부에서는 음식물 섭취가 제한되고 있는 점 양해 부탁드립니다. 오늘 행사는 한국어와 영어로 유튜브를 통해 생중계되고 있고 중국과 베트남을 온라인으로 연결하여 진행됩니다. 원활한 행사 진행을 위해 소지하고 계신 휴대폰을 진동 또는 무음 모드로 전환해 주시기 바라며 행사장 내 원활한 인터넷 상황을 고려하여 와이파이도 비활성 모드로 전환하여 주시면 감사하겠습니다. 네, 지금부터 2021 강원 그린바이오 국제 심포지엄을 시작하도록
Good morning, ladies and gentlemen. Now I'm honored to announce the start of the 2021 Gangwon Green Bio International Symposium. My name is Han-seok Kim from Chuncheon Bio Industry Foundation, or CBF.
오늘 행사는 강원 그린바이오 산업화 국제 협력 연구 활성화라는 주제를 가지고 진행되고 있습니다.
Today's theme is revitalizing international cooperative research within the industrialization of green bio. Let me go through today's agenda briefly. We'll start with the welcome speeches by CBF President Jiu Yu. We have participants joining in from Vietnam and China. We will have those sessions in the afternoon. Each session will be facilitated by chairs, and each presentation will be done in 20 minutes, followed by 10-minute Q&A. The presentations will be delivered in the presenter's own language with Korean subtitles at the bottom of the screen. After each presentation, we'll have Q&A with consecutive interpretation. We have a small number of participants in person, but it is being live streamed via YouTube, and we are also been honored with the presence of participants joining from China and Vietnam. And now we have the video that we're going to watch.
네, 바쁘신 가운데도 오늘 참석해주신 주요 참석자 여러분을 소개해드리도록 하겠습니다.
Now let me introduce our distinguished guests today. Please give them a big round of applause as I welcome each of them. We have Chuncheon City Mayor Jae-soo Lee,
춘천바이오산업진흥원 유지욱
CEO of Chuncheon Bioindustry Foundation, Ji-wook Yoo.
네, 오늘 자장을 맡아주신 강원대학교 정현호 교수님
One of the chairs, Professor Yeonho Jung of Gangwon National University.
오늘 기자회견을 맡아주신 분들입니다. 조선대학교 최철호
Now keynote lecturers, Professor Il-jun Kang of Hanyang University.
한국지식재산연구원 전정화 부위원님
Dr. Jeonghwa Jeon of the Korea Institute of Intellectual Property.
BSI 그룹 코리아 이봉우 선임 심사원님 참석.
BSI Group Korea Lead Assessor Bong-woo Lee.
네, 에코비즈넷 조정섭 대표님 참석하셨습니다.
EcoBusiness CEO Dr. Jung-sup
네, 현재 이곳 행사장에는 참여하고 계시지 않지만 해외 연사분들도 현재
We also have presenters overseas joining in online.
농업대학교 통타
Professor Tao Tong of China Agriculture University, Professor Chie Yan-jin of Yangon University, Professor Song-lan Lee of Yangzhou University, Professor Nguyen Ban Bin of Dalat University of Vietnam.
길림성 녹색식품 공정
We have more distinguished guests
길림
from Guilin
식품과학
University,
민위용 학장님, 길림 공정기술 사범대학 식품공학
with three more distinguished from Guilin area of China.
길림 화공대학 바이오식품공학대학 쉬승 학장님, 길림 공정기술 사범대학교
These people are joining in online.
부학장님과 길림성 녹색식품 공정연구원의 류청 부원장님도 중국에서 온라인으로 함께 참여하고 계십니다.
We have more distinguished from Guilin province of China joining in via online.
온라인으로 접속하신 모든 분들을 위해서 박수 한번 부탁드리겠습니다.
So please give them a big round of welcome applause.
네, 감사합니다.
Thank you.
이어서 춘천바이오산업진흥원 유지욱 원장님의 개회사
Now we're going to have CBF CEO Ji-wook Yoo for his welcome speech to kick off our journey today.
네, 안녕하십니까. 춘천바이오산업진흥원.
Good morning, ladies and gentlemen. I'm Chuncheon Bioindustry Foundation, or CBF President Ji-wook Yoo.
이 모임을 비록 오늘 온 오프라인이지만
It's been a while since we had a bioindustry related session like this today.
온 오프라인으로 참석해 계신 모든 국내외
So I would like to thank all the distinguished guests for joining us in the Gangwon Green Bio International Symposium today.
유튜브로 이렇게 참석을 하고
Like Han-seok said earlier, we have many participants joining in online,
비롯해가지고 많은 분들께
especially the distinguished guests from the Guilin province of China.
취임 이후 지금까지 계속 저희
My honor to welcome
아주 적극적인 후원자이신
Chuncheon City Mayor Jae-soo Lee, who has been an amazing sponsor of this event. And I would also like to extend my gratitude to the Chuncheon City government. We have three sessions today. In the afternoon, we have two sessions focused on China and Vietnam. So I would like to thank Yeonho Jung of Gangwon National University and Il-jun Kang of Hanyang University for organizing and moderating the afternoon sessions. Also like to thank Professor Cheolung Choi of Joseon University for traveling from all the way from his area. Also have lead assessor of BSI Group Korea, Mr. Bong-woo Lee, and Dr. Jeonghwa Jeon of KIIP. In the afternoon, we have the session focused on China and Vietnam. Would like to thank Professor Tao Tong of China Agricultural University and Professor Tian Yan-jin of Yangon University, Professor Song-lan Lee of Yangzhou University for sharing Chinese green bioindustry status. would also like to thank the presenters for Vietnam, Professor Nguyen Van Dean of Dalit University and CEO of Ecobusiness Chung Cho. Especially an honor to have the former KIST President and current VKIST President Dong Hwa for joining us in Chuncheon during his trip to Korea all the way from Vietnam. So the global community has been suffering from COVID-19 since early last year, and the travel restrictions proved to be a major barrier to international cooperation. So if it weren't for COVID-19, we could have invited institutes and organizations from all over the world and had in-person discussions on what we can cooperate on and how to enhance our research capabilities. Still, we are connected with each other online today. Feels like we are resuming our journey together. So it is my sincere hope that the symposium serves as a springboard for international partner institutions for enhancing green bio research capabilities. I hope that this green bio industry, I hope that the symposium accelerates this trend of green bio industry by highlighting utilization of local agricultural products and development of medicine using undertapped natural resources and so on. So this year's symposium is streamlined version with online and offline participation. But the lectures and presentations today will help us share research plans and inspire future cooperation. I hope to see the partnerships today grow into international R&D projects. Let me once again thank all of the distinguished guests for participating in today's symposium, and I wish good health and luck for all of you and your loved ones. Thank you very much.
네, 말씀 감사합니다.
Thank you.
Thank you.
네, 다음은 춘천시 이재수 시장님의 축사가 있겠습니다.
Next, we will
박수 부탁드리겠습니다.
have His Honorable Jae-soo Lee, the Mayor of Chuncheon, to give his congratulatory remarks.
네, 반갑습니다. 춘천시장 이재수입니다.
A pleasure to meet you. Nice to meet you. I am Jae-soo Lee, Mayor of Chuncheon.
하고 있는 모습 보니까 또 새로운 느낌이에요.
It's refreshing to see this room with so many spaces in between people.
자칫 달랏과
We may seem like we're gathered in a small group in this room, but I want to remind you that we're joined online by many colleagues and partners joining online from Dalat and Jilin and from Vietnam and China. I heard that we see a lot of collaboration happening.
서로 날짜 조정하고
Now, if you have these events or functions offline, in person, sometimes you have logistics hurdles. Scheduling and setting up meetings can be troublesome at times, but I think having this online could help us garner more efforts in one place and assist making it a little bit more convenient for our participants to join in. So I would just like to see it in a brighter light, and I appreciate that we are having this Green Bio International Symposium on this very meaningful day, and I am looking forward to see great progress through this symposium. I'd like to take a moment to thank all of the team, including President Ji-Yu for preparing this symposium, and also for everyone attending online and offline for taking part. Now, Chuncheon, of course, was no exception in facing all the challenges brought by COVID-19. But I'd like to highlight that COVID-19 had a critical impact on Chuncheon's economy because Chuncheon does not have a lot of knowledge-based industries, so logistics, retail, and manufacturing industries in Chuncheon were hit hard by the pandemic. But on the other side, we had what is close to a miracle, especially in the bio industry.
매출도 19년 대비 20년
If you look at the performance records of bio industry in Chuncheon, compared to 2019, we had a 15.4% spike in revenue and over 19% in exports. So that was a chance to see our progress looking forward and great potential in the bio industry of Chuncheon. Many of you logging in online from abroad may not know very well of the bio industry in Chuncheon, but we are making a lot of progress, especially in the COVID-19 related industries, including vaccine development and manufacturing and cure development, also vaccine CMO. I think we are the only case in the world to have response scheme for all COVID-19 phases on an industry scale, especially noting on the green bio industry in Chuncheon. I am very pleased to meet in person and online the leading minds and thinkers of the bio industry joining us on the event held in Chuncheon. Chuncheon has great visions and expectations for the bio industry, and it was one of our key areas for governmental support. And that's why we see and encourage more R&D development and recruitment as well. So home and abroad, joined by great thinkers and academics, I think it's even more meaningful. And I am excited to be in this place where you are sharing your research progresses and results. And I also look forward to seeing more collaborative work in the future. Now, as you already know, we are expecting a lot of discussions and debates through the symposium, and I look forward to see this in the industry level, making progress as well. I am sorry that I won't be able to join you until the end of the event, but once again, thank you very much.
큰 박수 부탁드리겠습니다.
Thank you very much for the congratulatory remarks. Let's give him another round of applause.
기념사진 촬영이 있겠습니다.
Now we'll take a moment to have a commemorative photo. I'd like to invite all of our speakers once more to the stage to celebrate today's symposium.
오늘 현장에 참석하신 분들이 많지 않기 때문에
We don't have a big group in the room, so I think it will be most of you joining us in the room. You can join us on stage for a photo session.
네, 감사합니다. 자리로 돌아가 주시면 감사하겠습니다.
Thank you very much. Now you may return to your seats to proceed with the program.
네, 지금부터 국제 심포지엄의 첫 번째 세션을 진행하도록
Now we're going to have the first session of today's event. The first session will be chaired by CBF Director Soo Eun-lee with the theme of revitalization of the international cooperative research.
앞에 지금 벌써 나와 계신데요. 큰 박수 부탁드리겠습니다.
Please welcome CBF Director, Mr. Lee.
네, 진행 부탁드리겠습니다.
네, 소개 감사합니다.
Thank you for the introduction. My name is Soo-eung Lee, CBF Director.
진행을 위해서 혹시라도 개인 휴대폰 다시 한번 점검해 주시고요.
I would like to remind you to put your mobile phone on mute.
의사에 따라서 강의할 때만 마스크를 좀 벗어도 무방하다 이런 말씀을 먼저 좀 드립니다.
Would like to tell you that the presenters will not be wearing masks based on their preference.
순서로 진행하도록 하겠습니다. 강의 중에 유튜브로 참석하시는
We have 3 lectures,
방에 올려주시면 감사드리겠습니다.
and if you have any questions,
첫 번째 강연에
can
소개해드리겠습니다.
ask those questions.
교수이시고
Especially if you're joining in through YouTube, you can just type in the chat box. And we have 3 lectures, as I said. We have
양력 소개를 좀 드리겠습니다.
professors and doctors and PSI lead assessor.
조선대학교 약학대학에서 박사를 하시고
The first lecture will be done by Professor Cheoryong Choi of Joseon University. He joined Joseon University early this year. Before that, he was working with us, our foundation,
근무를 하셨습니다. 그래서 기업에 대한
for the past 10 years. So he knows the needs and the status of the industry and the market. He's highly informed and has conducted many researches. So we'd like to welcome our first lecturer, Professor Choi. Thank you very much. Thank you, Ji-Wook CBF CEO, and the chair. Would like to wish a great success of this symposium. Let me start my presentation. So the topic is development of new drug for rheumatoid arthritis using Santonia hexaphilia. I will give you some example cases of new drug development using natural products.
보급화 성공을 해서 농민들이 소득 자원으로 활용하고 있는 소재에 대해서 발표드리도록 하겠습니다.
Cases where
일단 천연물이라고 하는
the farmer successfully developed natural products.
천연물이라는 것은 식물에서
So first of all, what are botanicals? They are plant-based compounds.
이거를 이제
Can be extracts
의학적으로 활용할 수 있는 건강을 위해 사용할 수 있는 소재들을 이제 보타니컬
or other materials that can be used medically.
그러면 이제 우리가 왜 이거에 대해서 연구를 해야 되느냐 보면
Why do we need
환경적으로 봤으면
botanicals and natural products?
저탄소 시대로
First of all, we are shifting from petrochemical economy to low carbon economy.
형태로 이제 삶에
And we also have the aging society where people are more interested in health
삶의
and
질이나
life
이런 걸
quality.
보다가 최근에는 이제 글로벌 환경을 생각하는 저탄소처럼 환경을
And
생각하는
recently, people are more interested
이런 것들을
in
생각하면서
safety,
사람들의 인식이 바뀌고 있습니다.
life quality. So there's a shift in mindset.
그리고 산업 자체도 이제 1차 산업만 생산하다가
Industry-wise, we're shifting from primary industry to industry 4.0 and beyond. So there is this paradigm shift. There is this globalization going on, and we are seeing more second, tertiary, fourth, and sixth industry. The scale-wise, we are seeing the change from small scale to large scale. So starting with the Uruguay round in '95, followed by WTO, FTA, and so on, we are seeing more free trade spreading across the world, and that means more competition. We have Nagoya Protocol. Just giving you a simple information about the Nagoya Protocol. So the supplement market has been growing rapidly. We have a market sized at $70 billion. The CAGR growth rate is over 7%.
그러면 이제 세계적으로 그 어떤 소재들이 이제 유통이 되고 누가 많이 사는지에 대한 부분을
So who are buying those products
제일 많이 팔린 건 입이나 룻,
and what's the market like?
그리고 예, 식품이라든지 그다음에
We have
헬스크림에
food,
대한 부분, 제일 많이 소비하는 층은
healthcare.
여성 부분, 여성이 많이 쓰고 그다음에
Key customer,
그다음에
target
이제
customers,
비타민 등이
women.
상승하고요. 그리고 제일 많이 팔리는 형태도 타블렛부터 캡슐까지 이렇게 있습니다.
Formulation-wise,
제일 많이
tablet
선호하는 층은 이제 무아메리카 쪽이고,
is the most popular.
그리고 이제 파마들 여러 회사들이 이 유통에
And we also have many pharma companies involved in this process.
주요 소비층에 대한 부분에 보면은 이제 압도적으로
Key consumers,
미국에서 소모하는 게 굉장히 크고요. 그다음
the
유럽이라든지
key market is America.
대학 그 나라들로 구분이 됩니다. 시장 자체의 규모가 굉장히 크게 차이가 많이 나고요.
where the market size is enormous.
활용하는 부분도 입이라든지 루트 부분이 제일 많이
Application,
그리고 마켓에서 사용되는 것도 파마시티컬이라든지 그러니까 건강을 위해서
is
사용되는
mostly pharmaceutical, so mostly for health.
되고 있고요. 그다음에 앞에 보셨던 것처럼 여성들을 위한
Key target customer, women,
여성이라는 겁니다. 여성들이 구매를 해서 사용하는
so mostly adult women buy those products.
그리고 이제 뒤쪽에 한 번 더 자료가 나오니까 한 번 더 보도록 하겠습니다.
We have more information in the following slide.
그리고
The source has been growing.
이제 그 주요 활용 부분이 2026년도에 어떻게 바뀔 거냐라는 걸 예측한 자료인데요. 그게 크게
So you can see the 2026 projection, not that different. Roots and leaves
이제
are the dominant
그래프를 보면서 이제
components here.
봤던 거는 이제 뿌리의 증가의 부분에 비해서 잎의 증가율이 굉장히 높게 나타납니다. 그러니까
So you can see the leaves portion has been will be growing faster than that of root.
증가는 되지만 거기에 비해서 뿌리에 비해서 잎이 굉장히 크게 많이 증가하고 있다는 걸 볼 수 있고요. 그래서
So the growth rate of the leaves
내년에 다시
is something that we need to
중심으로 바뀌고 있다고
focus on. And the market size by source, CAGR growth rate
그러면 어떤
is at the bottom.
제품들이 많이
Now,
판매되는가라는 겁니다.
what types of products are being sold?
그다음에
Tablet, capsules, followed by powders.
많이 유통이 되고 있고요. 이건 이제 세계적인 흐름이니까 이거에
So
비해서
this is the global trend,
시장이 증가를 하고 있어요. 그 전에는 그렇게 크지 않았거든요.
and the market of extracts has been growing.
전에 시럽처럼 섞어서 먹는 거
Now we also have syrup.
먹는 포 형태로 파는 익스트랙트의 시장이 이제 우리가 노릴 시장은 이건 일반적인 시장보다는 틈새 시장이 가까울 거라고 보면 이제 그 포 액상 형태의 시장이 생각보다 많이 성장하고 있다라고 보여집니다.
So the takeaway from this slide can be extract and syrup. Those liquids
많은 시장을 차지하고 있는
has very big potential.
차지하고 있는 곳 그리고 이제 시장이 그렇게 마켓이 크지 않은 곳으로 구분이 돼서
So the market status is here.
독일과
And in Europe,
프랑스, 이탈리아 등이
within Europe, Germany and UK
그 외에 다른
are the dominant markets.
시장이 차이가 납니다. 이제 이거는 그 익스트랙트에 대한 시장이에요.
So this one is about extract market.
이게 이제
What was interesting was
뉴트리언티시티컬 계열이에요. 그러니까 영양 몸을
mostly pharmaceuticals and nutraceuticals.
에 대한 시장 부분인데 이 시장에서 애니멀 피드 부분이 굉장히 시장이 확대되고 있다는 겁니다. 그래서
So we'd like to tell you that the animal feed portion is quite big or getting bigger.
이제 애니멀 피드에 대한 시장이 굉장히 확대돼 있다라는 게 굉장히 이제 좀
So the animal feed market is actually bigger than we originally projected. What are the top selling botanicals?
생소한 그 세인트 존스 워스트라든지 그다음에
So we have St. John's wort,
에스테리카 이런 것처럼 우리한테 생소한
Echinacea.
인삼이라든지
These are the things that Koreans are not that familiar with, but we also have ginseng
탑셀링을 일으키면서 판매가 되고 있는 소재들입니다.
and garlic that Korean people are more familiar with.
소재에 대한 가치 부분입니다. 가치 부분은 추출했을
And
때
this is
이제
about
원재료의
the high value,
진생 기준으로 보면 한 15배
high added
정도
value of
가치
botanical
자체가.
resources.
그리고 은행잎엑스 같은 경우는 프랙션을 나누기 때문에 약 140배 정도. 그리고
You have crude
캡슐로,
extracts
저기
and
탁솔처럼 캡슐로
fractions
만들었을 때 탁솔처럼 캡슐로
and
만들었을 때는
single
약 20배
compounds.
정도 증가를 합니다. 근데 이게 이제 우리 이제 저희처럼 학계에 있고 그다음에
So when you process those
보고 있는 시장인데
natural products or
시장이
botanicals,
이런 말씀을 드렸을 것 같아요.
the value of that
시장의
can
규모가
grow
있으면
by even 200,000 times.
규모는 고부가치 될수록 작아집니다. 그러니까 이제 여러 명이 잘 먹고 잘 살려면 이제 이것도 중요하지만 이거 전 단계인 이 시장도 상당히 크게 중요하다는 겁니다. 강원도나 제가 근무했던 전라도나
So for many people to succeed on the botanical resources market, we need to also focus on the earlier stages of the processing,
그게 못지않게 1차 산업의 부분, 그러니까 단순 가공
which
산업을
means
시키는 게 국민들한테 크게
that we
도움이
also need to
되고
focus on the primary industry, which is agriculture.
이제 소재 자체를 크루드하게 하고 프랙션을 만든 다음에 싱글
We have
컴파운드까지
crude and
가는
fraction
이제 여러 가지 난제점이
and single compounds, and there are many steps to go through
근데 여기서 중점으로 봐야 될
in
거는
each
이
step.
강원도나 이런 그 지역에서는 주로 봐야 될 게 이제 원재료에 대한 문제일 것 같습니다. 이
And
원재료가
the Gangwon province and many participants will be interested in
프로파일이 바뀌면서
discovering the earlier stages of that process.
지역에서는 굉장히 큰 장점인 거죠. 지역 소재를 가지고 개발을 했는데
This is where the regional areas can have competitive edge.
이제 고도화되면 될수록 심합니다. 일반 그냥 뿌리를 뽑아서 건조시킨 다음에 판매를 할 때는 문제가 되지 않는데 얘가 크루드 익스트랙트 넘어가고 프랙션을
If you think about crude extract and
그러니까
fractions,
여기서 이걸 강원도에서 키우고 있는 거를 제주도에서 키우면 약효가 안 나올 수가 있어요. 이거를
that is quite region or location specific. So if you have a certain compound that can be grown or extracted in Gangwon area, it is quite difficult to do the same thing in Jeju area.
아니면 그게 아주 재배할 수 있는 지역 자체가 한정시킬 수가 있다는 겁니다.
So the growing areas can be limited geographically, so that's something that the regional governments or institutions should be focused on.
한번 보여드릴 건데요. 따라서 이제 춘천에 나와서는 강원도의 소재를 가지고 개발해서 산업화하는 게 굉장히 중요하다고.
So it would be better for Chuncheon area to focus on the botanicals that grow in Gangwon province.
똑같습니다. 뭐 저기 자연에서 얻은 물질 자체를 임상, 1상, 2상, 3상 다 진행한 다음에 약으로 등록하는.
So this is the modern drug development process. You see the clinical studies, phase 1 to 3, before approval. We'd like to show you many cases and examples, but due to the time limit, I'll show only a few examples.
아셨으면 좋겠어서 집어넣습니다. 이게 이제
So this one
얘가 강원도에서 자라지 않기 때문입니다.
is Antonia. I brought this case because this does not grow in Gangwon area.
그 경상도하고 전라도 이쪽에서만 자라고요. 대전까지도 자라는.
You can see this mostly in Gyeongsang or Jeolla provinces of Korea.
죄송합니다.
Excuse me.
우리나라 고유식물입니다.
This is endemic plant in Korea.
이중밖에 없습니다. 그 종 자체도요. 제가 타깃을 봤던 것은 류마티스, 아스트라이티스 이제.
Our target was rheumatoid arthritis (RA).
자가 면역질이라든지 유전 질환이라든지 바이러스 감염된다든지 스트레스 받는다든지 상처를 받았을 때 이제 관절염이 유발이 되는데요.
When you get hurt or when you get autoimmune conditions, you can get RA.
그 미국에
The characteristics of RA.
환자가 상시 존재를.
There are 1.5 million patients in the U.S. alone.
그리고 이제 치료할 수 있는 방법 자체도 그렇게 크지 않고요. 그리고 또 하나가
And not many
발생합니다.
treatments for RA, and younger people actually get RA.
일반 관절염에서 골변형이 굉장히 심하게 일어나는 특성이 있습니다.
Causes deformation of bones.
거기 진통제처럼
And RA treatments
어쩔 수 없이
include
의사적으로 처방이 됐었고,
NSAIDs
그 다음에 케미컬에 대한 의약품과 그 다음에 저기 더마노이드 계열의 바이오 의약품들이 처방이
and
됐었는데
DMARDs
무릎에 이렇게 주사 맞는 거
and
있잖아요.
biologic DMARDs,
지금은 이 두 가지
as well as corticosteroids.
시합해서 합쳐서 치료를 하고 있고요.
So the RA treatments
저기 NSI
are mostly the combination of these four.
아스피린이나 타이레놀처럼 그런 제품들을 먹고요. 페이스 2에
In phase 1, you get
이제 단계별로 치료를 들어갑니다. 문제는 내성이 굉장히
combined treatments of DMARDs and steroids.
케이스 바이 케이스로 잘 안 듣는
In
사람들
phase 2, phase 3, you have different treatments.
부작용 사례가 굉장히 많습니다. 그래서
And there are side effects
되는 상황입니다.
and quite patient specific.
개발되고 있는 게 스몰 몰큐로는 이런 종류들이 개발되고 있고요. 그리고 안티바디
So we have small molecule treatments being developed
타겟 자체도 틀리고요.
globally.
그리고 IND 3상은 24세트 정도, 그리고 IND 3상의 그 MOA 타겟은 타겟 3상 간 타겟
And also IND3.
TNF 알파라든지 이런 안티바디들을 주로 사용하는
So they work quite differently.
저희가 사용했던 소재 자체는
Targets are different.
으름동굴과입니다. 현안신문문의 으름동굴과의
So back to Santonia.
소재고요. 이 열매 식용입니다.
This is
먹을 수 있고
the Disaballaceae
그리고 굉장히
family.
근데 저희가 소재로 사용했던 건 잎사귀를 사용을 했고요.
We use the leaves of Santonia.
일반적인 메커니즘인데 처음에 두통으로 접근했다가
So this one shows the inflammation pathway.
개발을 하게 됐습니다.
When it gets worse, you can have RA.
잎사귀 자체를 이렇게 추출을 한 다음에
We extracted the leaves of Santonia,
실험에 들어갔습니다. 이 잎사귀
fractionated.
하나에 이렇게 잎이 붙어 있습니다. 관절염에 대한 실험을 할 때 제일 많이 보는 게 이제 랑클 액티비티 테스트 하는 겁니다. 따라서 랑클에 유도된 파골세포 분화 자체가 이제 셀러브렉스처럼 이제 블록버스터 드럭이죠. 요거
So this is
나오는데
inhibition effect of water extracts.
마이크로부터 이펙트가 나오되 50마이크로면 거의 맥시멈 값이 나오는 걸 확인했고요.
And you can see that you have the maximum value
이렇게 족부정 유발
of 50.
이제 그 다른 약물처럼 효과적으로 관절염이 개선되는 걸 확인했습니다. 앞에
And we found out that the Santonia was effective in treating RA conditions. We had the CT and X-ray results,
좀 많이 줄어드는 걸 확인하고 이제
and the candidates especially showed quite a good improvement in terms of bone condition.
서로 상호작용에 대한 건데 IC50 값이 굉장히 높게 나와서 이제 굳이 그 약물 상호작용에서는 우리가 크게 관찰할 필요 없겠다라고.
IC50 value was quite high,
API 자체는
and API
이렇게 자라고 있는 애를 채취를 해서 사용을 했었는데
we collected at first the leaves like this, and now we are growing them.
보시면 잎사귀 사이즈를 보면 열매 크기를 대충
When you see the size of the leaves,
어린애 주먹이나 또는 이제 큰 거는
it's the size of a infant's fist.
지금은 열매에 대한 부분도 산업화를 추진을 하고 있고요.
And now we are also working on commercializing not just the leaves.
이 한 그루예요. 여기 대문이고요.
That's one tree.
이 안에 사람들이 다닐 수 있을 만큼 굉장히 잘 자라고 있습니다.
It's quite large.
제조 공정 자체는 저희가 이렇게
People can walk around it.
3배치에 대해 생산 자체는 GMP에 생산을 했고요. 추출, 농축, 분해.
We produced in GMP process.
를 제조할 수 있는 공정으로 개발을 했습니다. 이 공정 개발하기 위해서 많은 연구를 진행했는데
Collected, extract, fractionate, and produce the product.
세이프티에 대한 부분은
As for safety,
저희가 그 임상에 대한 보고서를 받았고요.
we worked with KTR to get the safety certificate.
그러니까 굳이 기관에서 하지 않더라도 단해투여 독성 정도만 하시면 나머지는 제약회사에서 별도로 다시 해야 되니까 연구자 측면에서는 거기까지만.
We just did the cell toxicity test, and the pharmaceutical companies did all the other tests.
저기 100mg 형태로 알약을 찍어서 임상에 들어가기 위한.
So this is what we made, tablets, for clinical trials. We were accepted for the clinical trial and went into the trial.
자체는 이제 여러
As for
군데
global
했고요.
patents,
총 7개국에
we have
대해서
several of them.
6건의 특허가 별도로 진입을 했어요. 그러다 보니까 건수로 치면은 30건 이상, 40건 정도 이 정도
We
되는
have
이상이
around
거의 대부분이 다
30
적용이 됐고요.
patents,
그리고 이제
mostly
요즘
registered.
시장에서 핫하게 계속 두드리고 이 문제를 제기하고 있는 게 원종에 대한 게 그게 확실한지 대한 부분이죠. 그래서 형태학적인 분석을 저희가 다 진행을 했고,
And we also did
거기에 대해서
the
유전학
morphological
분석까지 다
analysis
진행해서
of Syntonia
스탄토닉 엑사플리가 맞다라는 것을
at the
같이
request
제출을
of
했습니다.
the authorities.
유전학적 분석했던 자료들이고요.
Genetic analysis results.
그리고 이거는 이제 농가가 이게 보급을 했습니다. 지역을 한정을 했고요.
And we
왜냐하면
distributed
지역별로 저희가
Syntonia
난다고
to
하는
farmers.
식재지에 다 가서 샘플을 같은 시기에 다 채취를 했어요. 채취를 한 다음에 프로파일을 비교해서
Farmers in
가장
different
안전하다고
areas.
생각할 수 있는 지역을 찍었습니다.
Then we
그런
collected
다음에 그
samples
지역에서 계약 재배를 실시를 했고,
and identified the areas where Syntonia can grow the best.
분들한테 묘목을 나눠드렸고요. 그래서
So we gave
그다음 국가의 지원을 같이 받아서
Syntonia to the farmers
정부식물이기 때문에 이렇게
for them to grow.
했고요. 하우 설치한 거를 재배를 해서 지금 현재 이렇게 돼 있습니다.
So this is where it's going.
많이 열고, 그리고 이제 잎사귀
Water
자체는 재작년까지는
For the leaves.
영양 수거를 해갖고요. 지금 계약 기간이 끝나고 임상
We
이상
collected
결과가
them
나오고 나서 그 다음 스텝에
last year.
대한 이루어지고 있습니다.
And
이 원재료
the leaves are being
원료를 파는 회사가
tested.
다시 승계해서 그 수거를 하는 걸로 계약이 돼 있습니다.
So by contract, we
잎사귀를
are
따다
going
보니까
to
열매가
collect
부수하고 나왔는데 지금은 열매가 아마 좀 더 이제 2만 평을 재배를 했는데요. 이게 더 커져야만 열매가 산업화될 정도로 되는 물량이
we're growing the Syntonia in 20,000 평 area,
나왔던 내용이고요.
and we need actually more acres to commercialize it.
그리고
So
지금
we
현재
had
열매 가지고 나온
media
제품 중에서
coverage.
건강식품 등록돼 있는 지금 판매가 되고 있는데요. 지금
And this is the product that we are
온라인
actually
판매가 되고 있습니다.
that is actually being sold. Thank you.
네, 발표 감사합니다. 정확히 또 이게 10분을 좀 질의할 시간을
Thank you for the presentation.
질의하는
Thank
시간을
you
좀
for
갖도록 하겠습니다.
being so timely.
우리 여기 참석하신 분들 중에 혹시
Now we are going to have
네,
Q&A.
앞쪽에 계십니다. 마이크 부탁합니다.
예,
네.
흥미로운 발표 잘 들었는데요.
네.
연사께서 말씀하신
Thank you for the great
이 천연물
presentation.
데서 가장
Like you said, developing national products.
GPS라고 말씀을 하셨잖아요.
네.
GPS is the key point of developing natural products.
가신 그 식물 이름이 뭔지 잘
멀꿀이라고 부릅니다.
I don't remember the name of the plant. Oh, it's Syntonia that went into the second clinical trial.
신약으로 가시는데
And now you are developing new drugs based on Syntonia.
네.
But you know there is the global warming going on.
생각을
네.
I would assume that GPS would change due to the climate change.
이 GPS가 가장 큰 문제거든요. 근데 신약으로 가시기 위해서는 이 원료 확보를 위해서
To develop a new drug,
좀 고민을 할 필요가 있는데 GPS 변화에 따른
I think we also need to take into account the changes in GPS.
제가 이제 생각하기엔 이제 지금은 전라도하고 경상도에서만 자생하지만 좀 GPS가 변하고
Like you said, Syntonia grows only in Jeolla and Gyeongsang, but because of the climate change, maybe Syntonia can be grown in Gangwon area too in the future, maybe in 4 or 5 years.
그때는 이제 재배지가 강원도도 될 수 있다라는 생각을
So Gangwon province can
할 필요가 있다라는 말씀을 드리고
grow Syntonia because of the climate change. So I would like to get your input on this
체감한 케이스가 하나 있어요.
theory.
이제 좁쌀풀이라는 식물이 있습니다. 이 식물이 2015년까지 제가
I just thought of this plant
15년까지
that I worked on.
그래서
When I first started research, it was mainly grown in Jeolla area.
4, 5, 6월, 7월 이때쯤 좁쌀풀이 꽃필 때 되면 이렇게
The flowers bloom in April to June.
작은 국화들 잔뜩 피어 있는 것처럼 굉장히 많이 있었어요. 그런데 그게 이제
You could see a lot of flowers
산업화하겠다라는 기업이 언제
of
나타나?
that
19년도에
plant.
나타났거든요. 그래서 19년도에 기업에서 물어보더라고요. 얼마나
Back
쏟아질 수
in
있냐고. 제가 그래서
2019, when the company asked me
해드릴 수 있다고. 왜 그러냐면
when
야산
they
밑에
could
있는
get the flowers,
묘지감이 그 좁쌀풀로 가득 찰 정도로 남아났어요.
I told them that
19년도에
I can get you the flowers very quickly because by that time you could have more flowers
찾아다녔죠. 제가
in the area.
했고요. 그리고 나서 나중에 결국 찾은 게 강원도였어요. 그러니까 식재지가요.
And I ended up in Gangwon area collecting the flowers, which means that the area changed, the GPS changed.
현재는 강원도에서 식재를 하고 계시고 분들도 계시고요. 나물로 먹는 걸 풀렸거든요.
It turns out that plant was quite sensitive to climate
대전
change.
아래쪽은 전멸했습니다. 그러니까 이걸 보면서 느끼고 있고요. 멀꿀 소재 자체는 저희가 10년 동안 프로파일을
As for Symphonia,
뽑아서 찍고 있습니다.
we
아직까지
collect
이제 안전 범위 안에 들어가 있는데요.
the leaves
이게 저도 본부장님 얘기하신 것처럼
the same season of the year, but like you said, maybe we can see the same case with Symphonia, and we should be ready for it.
네네, 답변 감사합니다. 혹시 추가적인 질문 사항 있으시면
Thank you for the answer. If you have more questions, please state your name and your organization and ask the question. We haven't got any questions from the YouTube yet.
네, 에코비전의 조정석 대표입니다. 아까 발표 중에
My name is 정석 Cho of EcoVisnet.
기능성 물질 적용하는데 이제 애니멀 피드 쪽이 좀 많이
You said something about the animal feed market growing.
이게 혹시 그 농장 그런 쪽이 아니라 이제 펫 쪽인지.
Is it like pet related or? Oh, here in my presentation, the animal feed is pet related.
보타니컬 쪽은 거의 없다고
As for
보시면
botanicals, is
지금 현재 있는
pet
거는
related.
펫 시장이 확대되면서 커졌다고 보시는 게 맞을 것 같습니다.
So the animal feed grew as the pet market grew.
지금 그 온라인에서도 올랐는데 혹시 그 유튜브 해에서 지금 질문과 답변하는데 너무 좀 말이 빨라서 좀 잘 못 알아듣겠다 이런 의견이 지금 들어와 있습니다. 그래서
There were some opinions about the speed of the presentation being too fast.
알겠습니다.
예, 춘천바이오산업진흥원 유지욱입니다.
Jiwook Yu of CBF.
제가 뭐 이쪽 부분 전문가가 아니라서 좀 이렇게
I'm not the expert in this area, so I only have basic information or knowledge about it.
이제 대마 사업을 하고 있는데.
네.
But the Chuncheon city government has been involved in the hemp business since last year.
더 많이 그 어떤 종자에서 그 성분이 더 많은 종자를 선발을 하고 또 재배를
So the researchers are working on identifying the hemp species that has the strongest medicinal or therapeutic compound. The status CBD. If we chose one species, we may have different results based on where we grow the hemp or the content of the CBD can change depending on GPS. Do you think it's better to grow them in greenhouse to optimize it, or is it better to grow them in just plain land or just target one area and grow them? I would like to have your input on this.
쪽에 따라 좀 다를 것 같아요. 시장을 어디까지 보고
I think it depends on the purpose
이걸 이제 사용 목적을
of the market wants.
식품으로 가지 않습니까? 그러면
If you are developing
어마어마해요. 보통
health supplements,
하는 소재에 대해서
you need big acres.
지금 올해 계약제가 13만 5천 평이었거든요. 내년에 30만 평에서 많게는 50만 평 이상 늘릴 거라고 얘기를 해요. 그러니까 성이 그 정도 되는데
So by next year, the plant that we're working on, we are going to contract 500,000
좀 덜 들이시는 분도 계시고
평.
분도 계시고 이게 다 또 퀄리티가 달라지고요. 그래서
and the quality of the plants can differ depending on the farmers,
재배할 수 있는
based
면적과
on their priorities.
이거를 어떻게 관리할
So when you are
해야 될 것 같고요.
growing a plant
또 달라요.
for supplements, you need really big acres. For medicine,
많이 필요하지 않습니다.
you do not need that big of a land.
그러니까 그러면은 2만 평이면 원장님 얘기하신 것처럼 하우스에다 지어도 돼요. 지어도 됩니다. 근데
So if it is
뭐 40만 평,
100,000 평, I would recommend greenhouse. But if it is larger than that, bigger than that, you cannot build that many houses, greenhouses.
자체가 또 바뀌겠죠. 이거는 우리나라 시장을 말씀드린 거거든요.
And that is for the Korean market, the local market. If it is for the overseas market, the conditions should also change.
개발했으면 강원도를 떠나면 프로파일 바뀔 겁니다.
Like I said, if you started the research in Gangwon area, you do not want to leave Gangwon area because the compound profile change depending on the location. It does not change just a little. It changes radically.
위도가 틀려지고 경도가 달라지면서 굉장히 크게 차이가 많이 납니다. 그래서 어떤 목적으로 하냐에
So you do not want to
재배 조건을
move
안전하게
the farm.
강원도 브랜드화 시키는 게 제일 낫다고 생각합니다. 문제는
I would recommend focus on one area in Gangwon and sort of do the branding of it.
변종이 나올 가능성이 높기 때문에 그거를 철저하게 통제하는 기술 자체가 강원도에서 해가야 될 롤이라고 생각합니다.
So I think that's the role of the Gangwon province.
마지막으로 온라인상에서 질문이 하나가 좀 올라왔습니다.
And now we have one question from online.
좀 비슷한데요. 이제 멀꿀이라는 소재를 갖다가
Similar to what was asked.
열매 효능이 좋아서 좀 일부 사업화를 해서 기술 이전을 했고.
So the presentation was about the effectiveness of the Santonia, and the product that you showed us was related to hangover cure.
가지고 요즘 이제 국내에서도 이제 스마트팜 지금 말씀하신 여러 가지 표준화나 이런 것까지 문제가 되기 때문에 그런 쪽으로 해서 스마트팜으로 좀 접근.
Now, considering the trend of smart farms, the question was, can we apply smart farms
좋은 질문이신데요. 제가 아까
in the development process? That was a great question.
조건을 잡으라고 말씀드렸던 이유가 하우스나 이렇게 재배할 때 스마트팜 형태로 갈 수가 있거든요. 그리고 노지에 재배할 때도 물론 가능하지만
Building on the last question, we need to think about the conditions of the farming, because the greenhouse and the smart farm, the conditions are different radically.
그렇게 진행하면 그게 기준이 스탠다드가 되는 거거든요.
So if you choose one condition, whether it is greenhouse or smart farm, that becomes the standard of it. So once you choose one condition, it will be very difficult to change that condition.
이 소재는 그 노지 재배에
On Santonia, we chose the plain land because it needs to be, the Santonia needs to be exposed to cold weather to be effective.
노지 재배, 특히 이제 겨울을 나는 이런 그러니까
So we chose plain land.
콜드 샥을 받아야만 그 캔디데이터의 active compound expression
to have the active compound because it needs to be exposed to cold shock.
네, 감사합니다. 지금까지
Thank you very much.
교수님께 다시 한번 큰 박수 부탁드립니다.
Thank you. Please give him a big round of applause.
네, 다음 두 번째 섹션으로 좀 넘어가겠습니다.
Thank you once again. Now we're going to move on to the second presentation. We have Dr. Jeonghwa Jeon from Korea Institute of Intellectual Property. The presentation is on the Nagoya Protocol and the global trends. We will give you a reminder 5 minutes before the time's up for the presentation, just to help you keep time. To give you a brief introduction, Dr. Jeonghwa Jeon studied law in Gangwon University and has many awards in the international law arena. Also, in the policy research in Nagoya state government, Dr. Jun has been involved in building policies and designing legal systems. Let's welcome the presentation. Nice to meet you. I am Hwa Jun from Korea Institute of Intellectual Property. Thank you for the introduction. I am here to talk about Nagoya Protocol and global trends, focusing on Korea's trends and trends in Vietnam. First of all, it's a great pleasure to have this opportunity to talk to you in this meaningful event. Nagoya Protocol, of course, many of you are already familiar because it's closely related to the bio industry, and it's already has been 11 years since it was signed. About 131 countries have signed the Nagoya Protocol. And I think it's important to notice the global trends and where it's moving forward. Although it is considered a familiar topic, many people have heard of it, but may not be grasping the details or why it's actually needed, how it's applied in the industry in our day-to-day businesses. Sometimes it can feel like a regulation, it can feel like a hindrance. So I would like to tackle that myth just by giving you why Nagoya Protocol came into place and how it is playing a role in Korea and in the ASEAN region and where the global trend is heading. Now, talking about biological resources, we are seeing paradigm shifts. In the past, everybody's property, we saw natural resources to be everyone's property, but we see a shortfall in the property as when it comes to natural resources. So the lack of resource, that was a result from reckless development from many regions, and we are seeing challenges arising from that nowadays. Especially in developing countries, we see the use of genetic resources falling behind when compared to advanced countries, and the profits or the benefits do not go back to the developers, and it's not fairly shared. So that's the challenge point. So having a fair sharing of benefits of development of genetic resources was the beginning of the need for Nagoya Protocol. Of course, we do not want to have excessive distribution of profits and uncertain procedures. But that was the base point of the talks in the beginning stage. Before the Nagoya Protocol was signed, because of the importance was highlighted of the natural resources and the benefits shared, we had the former body, which is the CBD, the Convention on Biological Diversity. It was assigned and went into effect in 1993 in Korea and in many other countries. The CBD carries several values. It highlights the importance of the biological diversity and the biological resources. Having said that, the CBD has three main objectives. First, the conservation of biological diversity. Second, the sustainable use of the components of biological diversity. Third, the fair and equitable sharing of the benefits arising out of the utilization of genetic resources. These are the three main objectives of the Convention of Biological Diversity. These are directly linked to ecosystem, that's ecology, society, and economy. So those three areas are directly linked to the CBD's main objectives. Of course, we have more detailed protocols and processes that serve to meet these objectives, but we heard from the participating countries that it's not very effective when it comes to actually implementing it into the national system or legal systems domestically. Through the guidelines and many different negotiations and talks, we brought the Nagoya Protocol. That's the result. And building on the Nagoya Protocol's value, it is focusing on establishing more predictable conditions for access to genetic resources and helping to ensure benefit sharing when genetic resources leave the country, providing the genetic resources. So it's about setting boundaries and clarifying the limits and ensuring profit sharing for the countries that provide genetic resources. Now, with the Nagoya Protocol, before, if you make a comparison, maybe it's not going to be a very stark comparison to compare the before and after it was coming into effect. The general idea of natural resources and biological resources before the CBD or before the Nagoya Protocol, you would oftentimes see the natural resources used by an industry player and the shares not exactly going back to the provider of the natural resource. One example is the star anise of China, which was a resource or part of the recipe for a very well-known medicine. But Swiss Roche Corporation that reeks in revenues over 3 trillion Korean won, was that benefit shared with the providers of the natural resource? Probably not. And with Nagoya Protocol and CBD coming into place, what it did was it raises the awareness of the players and the countries that we do need to focus or think about benefit sharing in a fair manner. So after the protocols came into place, you can see Huria, which is a good example of after the protocol signed. This is a plant that grows in South Africa. Now, it is an important natural resource as well, but what it does is it's an edible plant enjoyed by one of the tribes in the region, and they take it, Huria, to suppress their diet because they have to go hunting for an extended period of time and they cannot be fed sufficiently. So these traditional knowledge and these resources were later extended and expanded into an R&D project that could be made into a medicine. Instead of just taking the natural resource as is and without sharing any benefits, Huria Slimming was developed and the benefits were shared to the original region. These tribes and the South African government, one committee that managed the tribe, entered an agreement with the company that made Huria, and they had a revenue sharing royalty agreement. So as you see in these cases, this isn't just about selling your natural resources, but it's about generating new sources of revenue and benefits and sharing the benefits fairly. That's the value of the Nagoya Protocol in a nutshell. As you see in this slide, there can be the providing side and the utilizing side in activating countries. And once the utilizing country uses the natural resource, certain portion of the revenue or the benefit should be shared with the providing country, and the data should be shared through a database. This is the protocol in place. So setting the protocol clearly and fairly is the key. And of course, how the data was used, how the resource was utilized, those information should be shared as well. That's set by the Nagoya Protocol, and it is implemented into the legal system of each participating country.
이 나고야 의정서에서 요구하는 의무가 총 3개.
There are obligations, mainly 3 of them in the Nagoya Protocol. First one is access obligations, second, benefit sharing obligations, and the third is the compliance obligations. Now, access obligation talks about how to access the natural resources in the providing country, providing a fair and non-arbitrary rules and procedures. If there are arbitrary rules or guidelines, or if the procedures are not clear, it would be very difficult to use the existing natural resources and hinders the access. So prior to any access, we need to set guidelines and rules for the processes for access to the resource wanted. Giving out permits or authorization and proving those by a certificate is also included in the procedure. Second is benefit sharing obligation. The domestic level benefit sharing measures are to provide for the fair and equitable sharing of benefits arising. Of course, sharing the benefits would be up to an agreement between the parties, but there should be a marginal line or a baseline set by the protocol to make sure agreements are done fairly. So there are examples or certain guidelines given. The third is the compliance obligation. Now, within the jurisdiction, providing that genetic resources utilized within their jurisdictions have been accessed in accordance with prior informed consent, and that mutually agreed terms have been established. So this is about taking measures for compliance. Also, it encourages contractual provisions on dispute resolution in mutually agreed terms. So as I have been saying, the Nagoya Protocol has been signed and adopted more than 10 years ago, well over 10 years, but it is still the topic of discussion because Nagoya Protocol can be pretty broad, and when it goes into detailed guidelines and regulations, there are some open areas on how to implement it domestically in each country. So those details are still under discussion among the parties participating. So it would be interesting to see how it develops in the future as well. Now, I have briefly mentioned it. Up to today, 132 parties, that is, that have joined the Nagoya Protocol, but one is before it went into effect, and 67 non-parties that have not signed or adopted the Nagoya Protocol are there. Now, countries that have a lot of natural resources in abundance, or developing countries, or even underdeveloped countries, have joined. But as you see in the map, in the darker shade, advanced countries or countries with more advanced industries may be reluctant to sign or adopt the Nagoya Protocol, including the US, Australia, and Russia, because they concerned that it might hurt their industries economically. But still, they are aware of the impact of Nagoya Protocol, and there are some considerations and talks. So this does have an impact overall globally.
국가 동향에 대해서는 이제 간단하게만
Now let's talk about the
말씀드리고
global trends. I'm going to be
넘어가도록
brief on this
하겠습니다.
side.
부분이긴 한데
This is
나고야
just about the
정서라는
legal
큰 틀을 두고서
procedures. If you
각각의
think about the Nagoya
국가들이
Protocol as a
자신들만의
broad
규칙을
spectrum or
만들어가고
a scheme,
있습니다.
you can see
우리나라도 이미
different countries implementing
2017년에
the
관련
detailed
법을
guidelines and
제정을
rules
하였었고요.
individually.
베트남 같은
Korea
경우,
also
베트남 같은
had
경우에는 동남아시아
local
국가에서
laws
가장
according to the Nagoya
먼저로 이런
Protocol
나고야
in
의정서에
2017, and you see Vietnam leading in the ASEAN
가고 있는
countries
국가라고 할 수가
in
있습니다.
devising the legal
우리나라 같은
system
경우에
and
말씀드렸다시피
procedures and
2017년에
policies
관련
for
법을
Nagoya
제정을
Protocol
해서 이미
according to
이행이
their
되고 있고요.
guidelines.
우리나라의
Now,
유전
in
자원은
Korea,
의무구나. 또
the
우리나라 사람이
law
다른
according to
나라의
the
유전
protocol
자원을
has been
이용하는 경우에
effect
있어서
when
어떻게
there are
사용해야 되는지에
utilization of
대한
natural
절차를
resources, how
규정하고
to
있는
access
것이
them, and
이
how the utilization process
유전자원법이라고 할
takes
수가
place
있겠습니다.
is
뭐 전체적인
specified in
절차는
the related
국가마다
laws.
사실 큰 틀은 비슷합니다만은
The overall
세부적으로
framework
조금씩
is
다른
very
부분들이
similar,
존재를
but
하고
there are
있습니다.
some
기본적으로는
small
접대에
details different
대한
from
차후
country to
동의와
country.
또 상호 합의
These are the
조건을 체결을
procedures
해서
in Korea
이후에
according to the
이행을 하게
ABS
되는 이런
laws.
큰 틀로
There's the
이루어진다라고 말씀을
prior
드리도록
agreements
하겠습니다.
and the verification
네,
process.
우리나라
That's
이제
in brief.
법상에서 좀 이제 규정들을 보시게 되면은 그러면은
Now, if you
유전
just look
자원이라고
into
하는
a little
것이
bit more
어디까지
detail
이제 포함이
into the
되는가
Korean
이런
ABS
부분들이 좀 많이
laws,
문제가 될 수가 있겠는데
the scope can
우리나라
be an
같은 경우에
issue of
있어서는
challenge or
적용 범위
discussion.
특히 적용이 되지
In
않는
Korea's
그런 범위들을
case,
법에서 제시를 하고 있습니다. 이제 유전
the
자원
ABS law draws
나고야
a clear
의정서에서는
line
유전
of
자원,
this
유전 자원 관련
scope.
전통 지식 그리고 파생물이라고 하고 있지만은 우리
So
법상에서는
the scope of
인간
the
유전
ABS law says the
자원이라든지 또는
natural resource
국가에
up
반할
to
만한
this
위치에
protocol
그러니까
would be
남극이라든지
all natural
해상으로
resources
반할
except those
것으로
that are
지정되는
human
유전
genetic
자원들은
resources
이런
or
범위의
genetic
적용
resources
대상이 되지
existing in area beyond
않는다라고
national
이야기를
jurisdiction,
하고 있고요.
such as Antarctica,
접근과
or
관련해서는 이제
genetic resources that are subject
국제사회에
to other
인간 유전
international treaties
자원을
related
이용할
to the
목적으로
access of
접근할
genetic
경우에는
resources and the
신고를
sharing
해야
of
된다. 이
benefits.
정도로 좀 심플하게 우리
So
법은
when
규정을
accessing
하고
domestic
있습니다.
genetic resources for purpose of use, it must be
베트남입니다.
reported. It's
베트남 같은
simply put.
경우에는 국가가 이제 남북으로
In
굉장히 긴
Vietnam's
형태를 띠고
case,
있기 때문에
you would
굉장히
probably know
다양한
that
유전 자원을
Vietnam
보유하고
is
있는
a
국가입니다.
long
또한 나고야
country from
의정서에
north to south.
2014년에 가입을 하였고요. 2017년에
Vietnam
이런 유전
adopted the
자원의
Nagoya
이
Protocol in
법률을 위한
2014,
시행령을 만들어서
and they have a
동남아
decree
국가들
on the
중에서는 정말
management of
가장
access to
상세한
genetic resources and the sharing of
절차를
benefits
구성하고
arising
있고
from their
이행하고 있는 국가 중에 하나라고
utilization.
보실 수가
So it
있겠습니다.
is one of the leading countries in
정부 차원에서
devising
베트남의
detailed
유전
guidelines and
자원을
clear
이용할 때
legal
어떻게
systems on
이용해야
adopting the
된다라고
Nagoya
하는
Protocol.
가이드라인을
How to
만들기도 하였고요.
proceed through the
발표하기도
procedure and the
하였고
guidelines are clearly set and published.
여기 먼저 보시게 되면은 그
And if you look
국제
at this
의무 준수
slide, you'll see
인증서라고
that
해서
there is
실제
an
유전 자원을
internationally
이용을
recognized
했을 경우에
certificates
있어서
of
어떻게
compliance,
이용을
the
했는지에 대한
IRCC.
확인 증서
It
같은
clearly
경우들을
states
올리도록 하고
it's a
있습니다.
certificate that
지금
shows you how the compliance is
2021년
done,
10월 말
where, by
기준으로
whom,
올라와 있는
and
의무 준수
as
이행서가
of
약 뭐 3,000개
December
정도가
last
업로드가 되어
year,
있는데
there
사실
are
그
about
중에
3,000
대부분이
IRCC
인도
certificates
케이스이긴 합니다.
uploaded.
그런데
Most of them are
그렇게
from
거의 그
India.
2,000 몇 개가 이제 인도 케이스인데 그 중에서도 이제
So more than
베트남이 이런
2,000
의무 준수
of
이행서를
them
굉장히
are from
활발하게
India,
업로드를 하고 있는
but you
국가로
see a
좀
lot of
파악을 할 수가
uploads
있겠습니다.
and frequent
이렇게
uploads from
보여지는 것은
Vietnam as
결국
well, which is
베트남
notable.
내에서의 유전 자원이 잘
What that
이용이 되고
means
있고 많은
is,
사람들이
putting
이제
that into
이런 절차에 따라서
perspective,
이용하고 있다라는
many
것을
academics
보여주는
and many
문제다라고도 할
entities in
수가
Vietnam
있겠습니다.
are complying to these
또한
guidelines and
이제 나고야
using these
정서에 대한
certificates of
이행
IRCC.
관련해서는 사실 개별 기업 간의 계약적인 부분들이 많기
And
때문에
the
관련
Nagoya
내용들이
Protocol
아주
also serves
성실하게
as a
공개가 되지
form of
않는 경우들이 많이
agreements
있습니다.
between
그래서
industry players,
기업이
that's company to
얼마의 이익 보유를
company.
했다라든지 또는 이익
So
보유를
the
누구와
revenue
했다라는 그
share
자체가
or the benefit
해당
share
기업의 영업
between
비밀이거나
business to
영업
business,
비밀까지는 아니더라도
that
공개되지
can
않는 경우들이 상당수
oftentimes
많이
be
있습니다.
confidential or simply
그래서
just not
사실 이런
open
나고야
to the
의정서가
public.
잘 이행이 되고 있는지를 파악하기가 매우 어려운
So
부분들이 있으나 비록
sometimes it
어떤
can be
경우에는
difficult
관련
to see
사업을 잘
whether the Nagoya
이끌어낼
Protocol
힘으로써
guidelines are
국가들에게
complied and
차별점을 주고
followed.
있는 부분들이
So
있다라고 보여지고 있습니다.
Vietnam has a leading case in
베트남
putting up a lot of
자체에서도
open
그래도 이 부분 사례를
information
이제 올리고 있긴
of good
하지만은 다른 나라에서
cases
다른
of
나라에서
Nagoya
이용을
Protocol
했던 그런
followed.
사례들도 이제 많이
There are also
올라와 있긴
cases
한데요.
of Nagoya protocols followed in other countries
독일에서
other than and Vietnam. This case
사이트 등에서
is
보시게
from
되면
Germany.
다른 나라의 유전 자원을 이용했던
This benefit
사례들을
sharing
확인해 보실
information
수가
was
있습니다.
uploaded from
보시는
Germany.
사례는
You can see it on the slide.
이용을 했던 베트남에
This was
있는
about collecting biological material, which was fecal samples of a limestone langer.
이런 대학 연구 차원에서 이루어진
This was part of a research in a university lab.
때문에 반드시 어떠한
And of course, those apply to natural resource utilization. This is not limited to just commercialized uses, but it's also applying to academic uses as well.
이제 마지막으로 중국인데 중국 같은 경우에는
And finally, there's the case of China. China is one of the biodiverse countries. So it's one of the 12 countries that have the most numbers of bioorganisms and great biodiversity. So it was a key player in the need for Nagoya Protocol, and they have been open about talking about the need to sign the Nagoya Protocol as well. They had the law go into effect in 2017, and even before that, people expected them to actually put it into effect sooner, but most of the part is still staying as a bill rather than being in effect. But biodiversity is not the only area that China is interested in devising legal procedures and guidelines. So we expect to see these rules come into effect in near future. So as I was saying, the law in China is not in effect, it is still a bill. So we cannot strictly say they do have these procedures or guidelines or regulations, but you can see the direction where they're heading on protecting their natural resources and how to devising those guidelines when it does come into effect. If you look at the main points, of course, it does cover the general provisions. But in addition to the procedure or the general provisions, you see that it forces the entities to share the benefit with the government entity as well, not just the direct entity they are dealing with in agreement. They also have a blacklist system or a fining system when the protocols are not kept or followed. So compliance is also there.
사실 이제 나고야 정서와 관련해서는
Now, in regards to Nagoya Protocol, again, as I said, China does not have the law in effect yet. And of course, you can easily imagine a case of amendments in the future. And in China's case, they have it as a bill, but you cannot say for sure if they will put it into effect as is or if they will make further amendments in the future. So even though we do see a lot of activities that are related to Nagoya Protocol, we cannot say for sure how the procedure is working in China. Okay, that sums up my presentation. Thank you for listening.
감사합니다.
Thank you very much for that presentation. We do have
영어가 이제 공식 언어로 이제 통역이 되고
simultaneous interpretation into English on YouTube, and we are seeing online participants listening to interpretation into Chinese and Vietnamese. So I would just like to I'd like to remind the presenters to slow down just a little bit for the audience joining in online and for the interpreters. Thank you for that. Now, we do have some questions coming up online. I see one here. On genetic resources, natural resources, and farm resources, how are they different when it comes to utilization? And
일부 품종을 갖다가 국내에서 재배했을 때 그 이익 공유는 누구와 공유를 해야 하는가요?
And talking about
품종을 이미
hemp,
돈을 주고 지불했는데
if you are to grow hemp
추가를 한다면
domestically, how would the profit sharing go? Isn't that
혹시 이거에 대한 어떤 의견이 있으면
double costs? How do you
네 가지 정도로 이해가
search there? I
되는데요.
think
먼저 첫
there are
번째
four
조건이
parts into
무엇이냐라고
that
하는
question.
것은
So
말
what
그대로
is the definition of a genetic
이런
resource?
지구상에 존재하는
Compared to
모든
natural
생물의 자체를 그냥
resources
자원으로
or
이해를 하시면 가장 좋을 것
biomechanisms,
같습니다.
what
그래서
exists in nature,
동식물이라든지 또
that can also be counted in as genetic resources. There are marine resources. There are also biomechanisms and the microbiomechanisms as well. But if you are using that natural resources as it is in its natural form, that's natural. Let's say you grow a coffee tree and you breed coffee out of it and drink coffee, that's just business as usual. But if you are using that natural resource and having an R&D activity per se and yielding benefits out of that activity, then that will be defined as genetic resource. Let's say you have coffee, but instead of waking you up, you found a substance that can cure a disease or a condition, then that's a new way of using coffee, and that's a different activity related to it. Farming coffee and breeding coffee and drinking coffee, selling coffee, the cost effect will not be very different. But if you making it into a genetic resource, the cost and the final price can be pretty different. So the companies involved in this process may have a big role, but still, the provider of the natural resource and the initial step must have the right to have those benefits shared as well. That's the basic idea of the Nagoya Protocol. Now, of course, the companies will pay a price to purchase those natural resources in the first place, but if you're creating a much higher value addedness, it's better to have a fair share of that benefit. And of course, we see middlemen playing a role in the trades of natural resources between the R&D side and the provider side. So there are some companies that require or request these information, and they also request a compliance certificate just to make sure they are complying to the Nagoya Protocol. So those are some cases that exist. And when it comes to countries, we do have what is called ABS agreements. It's not just government to government, but it can also be a three-way agreement with the middleman in place. So we see diverse versions of these agreements and trade cases. You mentioned hemp farming. The benefit sharing is regarding to the place of origin. So where is that place of origin can be the question. When we talk about place of origin, we're talking about endemic ones. I hear some places in Korea we grow maca, but they're not endemic plants because they're not originated in Korea. So I think that can help answer your question. Thank you for that Q&A. Because of the time restriction, I think we should end the session here. Thank you very much once again. Let's give her a warm round of applause.
강사님이 오전 섹션까지 참여석을 하시고 아마 다른 일정이 있어서 같이 식사.
I believe Dr. Chun will be joining us before lunch. So if you have any additional questions you'd like to ask her in person, I think it would be a good idea to catch her in person for additional questions.
네, 다음 섹션으로 넘어가겠습니다.
Thank you. We'll move on to the next session.
오전의 마지막 강연.
So this is the last lecture this morning done by DSI Group Korea Lead Assessor Gong-woo Lee.
FSC 22000 소개라는 주제로
Going to talk about FSC 22000.
큰 박수로 좀 부탁드립니다.
Please welcome him with a big round of applause.
강사님을 잠깐 소개를 드리겠습니다. 주요 경력을 보시면
Introducing him, he worked at 농심 and Hanmi,
근무를 좀 하셨고요.
has done GMP-related work.
ISO뿐만이 아니라 FSC 22000 이런 것도 굉장한 컨설팅도 많이 하시고 강의 경력도
He's been doing consulting related to ISO and FSC 2000, has many licenses.
해외로 진출하기 위해서 이런 자격증을 좀 많이 요구를 하고 있습니다. 그거에 대해서
Now you need those kind of licenses for the local Korean food companies to go overseas. So let's begin his presentation. I'm going to start my presentation without my mask. Excuse me. So it's been a while since I've been to Chuncheon.
국제 심포지엄에 식품 안전이란 주제로 발제하게
I'm honored to be invited to the Gangwon Green Bio International Symposium and talk about food safety system. I worked about 4 years in the food company.
인증에 대해서 한 13년 정도 활동을 했습니다.
And I also worked for about 13 years in the area of food safety certificate.
식품 안전
We would like to talk about why you need food safety system and food safety certificate in the green bio industry.
네 가지 목차로.
So I have 4 topics.
먼저
broadly.
인증이라는 부분들이 좀 딱딱한데요.
First
가장 우리가
of all,
부분
certificates
사항들을 간략하게 먼저 말씀을
can be very
드리겠습니다.
formal, but I think I have to go through the basic requirements of the certificate. FSC 22000. Currently, we have version 5.1.
ISO 22000 부분이 요구되고 있고요.
So you have the requirements of the ISO 22000.
카테고리별로 선행요건 프로그램이 요구가 되고 있습니다. 그리고
And there are different categories and the requirements for them.
추가적인 요구사항,
There are additional requirements added to the version 5.1.
합해져서 하나의 표준으로 운영이 되고
So
있습니다.
ISO 22000 PRPs and additional requirements constitute the FSSC 22000 version 5.1.
우리 바이오 산업 쪽에서 적용이
In the
필요한 부분들은
bio
이러한 파스
industry,
이것들이 나중에 ISO,
you have TAS standards
로 발전해서 바이오 기업에 현재 이 인증을 받으려면 적용이 되는
that are
부분이고요.
applied to bio
요구사항
companies.
부분에 있어서 이 파스 96 부분들이 포함이 되어
This
가이드로
TAS
적용이 되고
96
있습니다.
is also applied.
네, 이 표준은 말씀드렸듯이
This
세 가지의
standards,
그러한 부분들이 합해져서
like I said,
표준이 적용됩니다.
constitute 3 areas.
현재 이제 ISO 22000은 2018년 버전이 적용되고 있고요. 그리고
So for ISO 22000, we have the 2018th version applied.
라고 하는 단원, 유니리버, 크래프트,
The Big Four, Danone, Unilever, Kraft, and Nestle, they came together to create the standard.
된 부분도 이러한 세계에서 거대한 식품 기업들이 같이 참여해서
So we have these big companies, global companies, coming together to create this set of standards.
요구사항이 더 계속 늘고 있는데요.
Now we have more additional requirements.
총 15가지의 추가 요구사항이 적용이 되고
And in
있습니다.
version 5.1, we have 15 additional requirements.
ISO 22000 부분들은
ISO 22000,
기존에는 이 ISO 22000만 해도 식품 안전 경영 시스템이면서
originally the ISO 22000 was about food safety management system, but a lot of people thought that it needs to be built on.
전 세계적으로 많이 적용되고 있습니다. 그래서 왜
And now we have different versions, and this ISO 22000 2018 is being followed and applied across the world. ISO 22000
이렇게 4장부터 10장까지가 있고 여기에서는 주로 우리의
have many chapters here.
조직의 상황, 우리 회사의 상황이 어떤지, 우리
So
고객이 식품 안전 관련해서 어떠한
the earlier
것들을
part of it is
기대하고
about the
요구하고 우리
company, the
회사는 어떠한
organization of
식품 안전 관련
it,
이슈가
what are the
있는지
expectations,
그러한
what are
것들을
the potential
반영해서
issues.
6장에서 리스크를 평가해서
In Chapter 6,
그것들이
you
우리가
analyze the
리스크라고
risks.
판단되면 리스크를
When you
최소화하는
identify
그러한
risks,
계획을 수립해서
have
운영을 해서
to come up
식품
with a plan
안전을
to
좀
address
더해야
those
된다는 거죠.
risks
그리고
to improve
우리가
food
기회라고
safety.
판단되면 그것을 더 증진시켜서
And you
식품
also
안전
have
개선을
opportunities
요구를 하고
identified.
있습니다.
You would like
그리고
to
7장에서는 식품
double
안전
down
개선을
on it.
위해서 여러 가지
And
자원들이라든지 지원
in
관련된
Chapter
그러한
7,
요구사항들이
you
요구가 되고 있고요.
have support section and resources
그다음
for the food safety
8장에서는 우리가
system.
전통적으로 알고 있는
In
햇삽,
Chapter 8
햇삽
is
부분들이 적용이 되고
about
있죠. 저 햇삽을 어떻게
HACCP
운영할 것인지에 대한 요구사항을
that many people are familiar with, how to apply the HACCP
의도적으로 혼합될
system,
수 있는 그러한 사항들을 이 8장에서 관리를 하는 겁니다. 그래서
so how to manage that, operate that is in
식품 안전
Chapter
관련된
8.
그러한 유해 요소를 관리를 하는 것이죠.
So it's about
거기서
hazard control plan.
거기에 더해서 이 FSS 22000에서는 식품 안전을 더 확보하는 그러한 요구 사항들을 요구하고 있습니다.
So these are the requirements for food safety system
그래서 이제 8장에서 햇삽을
in ISO
운영을 이제 하고
22000.
내부적으로
So
성과를
Chapter 8
평가해서
was about HACCP and Chapter 9 is about evaluation, performance evaluation.
실사를 스스로 하는 부분들이 내부 심사, 인터널 오디시 될
There are internal
또
audits.
식품 안전에서 아주 중요한 부분들을 모아서 경영자가 참여해서 경영
And there's also management
우리가
review,
어떠한 부분들을 더 보완을 해야 될 거냐, 어떠한 자원이 더 필요할
where
거냐,
management
이러한
members
부분들을
have
검토해서
to
지속적으로 개선할
review
수 있도록
what kind of
하는
improvements
이러한
that they can
부분들이
make.
ISO 22000 식품 안전 경영 시스템이라고 간단히
So
말씀드릴
that's
수 있습니다.
the ISO
여기에 더해서
22000. On top of
경영
that,
시스템은 다 PDCA, 플랜
we have PDCA,
체크 액트 형태로 되어
plan,
있습니다.
do, check,
일반적인
and
다
act.
표준도 그렇게 되어 있죠. 그렇지만 ISO 22000의 특징은
So the key characteristic of ISO 22000
PDCA가 돌아가지만 이 8장 이 햇삽을 운영하는 데 있어서도 이 PDCA가 하나가 더 돌아가서
you apply PDCA principle to all chapters,
체크를 해봤더니 개선점이
as well as the HACCP chapter, which is Chapter 8.
이렇게 두 가지 형태로 사이클이 돌아가고 있습니다.
So this is the broad cycle that goes on, PDCA, across ISO 22000.
이제 선용요금 프로그램, 이제 식품 카테고리
And now it's about
아니면
PRP.
부분에 있어서 적용되는
The food chain category,
다 다르게 적용되고 있죠.
there are different categories where different standards apply. So we have farming, animal feed,
리테일,
catering, retail,
이런 부분들에 대해서
services, and biochemical.
우리 바이오케미컬 부분
As for biochemical
식품 업체들에 대해서는
or regular food,
아까 말씀드린
like food
파스도 부분에서
manufacturing,
발전한 ISO TS 22002-1이 적용되고 있고요. 또
you have ISO TS,
사료지만 펫 제품들, 고양이와 개가
and
먹는
as for
사료들은
animal feed, especially
카테고리 C나
pet
카테고리
food,
동일한 그러한 선용요건들이 적용이 되고 있습니다.
category C and K
내용을 보면 이제
follow the same standards.
파스 221이 적용되고 있고 한 125개 정도의 그러한 인증이 발행돼서 아직
About
많지는 않습니다.
125 certificates have been issued for PAS 221 and 50 for catering. As for transport and storage, you have a very different number.
표준이 적용이 되고 있고 한
The standards
93개 정도의 그러한
NEN, NTA, AT59, there are 293 certificates issued. As for food manufacturing, the number is the highest, 22,772 certificates issued for food manufacturing.
같이 이 부분으로 이렇게 적용이 되고 있죠. 예, 그다음 이제 포장재 부분도 이제
Food packaging
제조업체가
and
포장재 사양을
manufacturing.
많이 요구하고 있죠. 이런 인증을 받아라. 그래서
So food companies actually use this certificates for packaging companies.
요구되고 있고 이렇게 포장재 업체들도 인증을 많이 진행되고 있습니다. 동물 사료 관련해서는
Animal feed production,
고양이 개 사료 외에 나머지 사료에 대해서 ISO TS 22002-6이
not just dogs and cats, all the other pet market needs to follow this certificate or standards.
22002-3이 적용되는데 이것도
ISO TS 22002-3 is applied to farming category.
그래서 내용들을 보면 가장 기본적인
So you can see
22002-1 시리즈 부분들을 보면 표준으로 다 이렇게
the content of the 22002-1.
이 빌딩이나 레이아웃에 대한
You have
어떻게 해야 되고 입지적인 부분들이 이제
standards for construction and layout of buildings,
작업장에 대한 레이아웃, 그다음에
layout of premises and workplace. And you also have utilities, air, water, energy.
본 거죠. 우리 이제 건강기능식품회사에서 GMP를 적용하고 있잖아요.
You must be very familiar with this part. When you work with like food companies, there's a GMP process applied, and GMP actually encompass these components.
여기서 이제 밸리데이션 부분들은 언급을 하고 있잖아요. 오히려 식품안전에서는
It
밸리데이션
does not cover validation.
비의도적인 혼입, 비의도적인 그러한 위해들이 발생해서 문제되는 것들을 막는 거죠. 그래서 GMP에서
Because this set of standards is about how to prevent unintended hazard, how to identify and address those unintended hazards.
포함이 되고 있지 않기 때문에 그러한 부분들은 좀 보완할 필요가 있다라는 거고요. 이렇게 제일 처음에는 선용권 정도에서 이러한 푸드 디펜스 부분들이 언급이 됐었는데 추후 추가 요구 사항이 더 증가되면서 지금
You
버전
can see the
5.1이
food
적용되고 있는데
defense
버전
part
4.1부터는 식품 방어,
here.
식품 사기 예방.
So because of the feedback that we need to include food defense, we
가이드를 제공하고 있는 그러한
can see that that part is included from version 4.1.
그래서 지금은 이제 추가적인 요구 사항 총
So these are the additional
15가지로
requirements,
이렇게 부류가 돼 있지만
15 of
15가지가 다
them,
적용되는 게 아닙니다.
but not all of them are applied.
적용되는 부분들이 정해져 있기 때문에
Different parts or different components are applied depending on the category.
카테고리 K에 해당되는 부분
So for category,
푸드 체인에 다 해당되는 부분 이러한
so you can see the categories that each component is applied.
그리고 특히 추가 요구 사항에서 이 식품 방어 프로그램 부분들이 정말 중요합니다.
And I would say that the food defense or food security part is very important in the additional requirements.
예방적인 차원에서 관리를 하는 거잖아요. 이물 같은 거.
So the standards are about prevention
정말 적정 온도가
and taking preemptive actions,
유지하면서 정말 적정 온도를 찾아서
maintaining the quality, temperature, the right temperature,
위생적인 부분들을 제어하는 거고. 그다음에 화학적인
to remove microbial risks and hazards,
미리 원료에서 이렇게
or removing antibiotic compounds from the ingredients.
했었죠. 그렇지만 이제는 이러한 부분들을
And now,
의도적으로 혼입하는 부분들, 그러한 부분들을 예방하는 게 정말 중요하다.
we are also focusing on intentional hazard,
식품 사기를 예방하는 부분.
and that is related to food defense.
한 6년 전에도 우리도 건강기능식품 업계에서 아주 중요한 사건이 있었죠.
About 6 years ago, we had a very important
이업 우피소가 혼입돼서
incident
그 부분들이
in the Korean food industry, which is
제어하지 못해서 아주 식품
related
사기
to
사건의 아주 대표적인 사례가
food hazard.
산업에 그런 게 있었는데요. 그래서 아까 우리 두 분이 이제 발표하면서 우리 교수님께서 아까 발표하신 이 사기를 예방하는 측면에서 보면
and that is related to
계약
food
재배를
fraud
통해서
mitigation.
그러한 것들을 미리 예방할 수 있겠죠. 그죠? 예.
And one way to
그러한
prevent it
그냥 구매하셨을 때는
is like
어떻게
my
재배해서 어떻게 우리한테
previous
그러기 때문에
presenter said,
그러한 부분을
to
계약을
have a
해드려야 되는지
contract with the
아니면
farmers.
받을 때 뭐 검사한다든지 하는 형태로
So
해서
contract with the
이러한 사기를
farmers
예방하는
or
것을 가지고 가야 된다. 특히
checking the
고효과
product
가치인
or
건강기능식품
ingredients
업계에서는 아주
when
중요한
at the time of
부분이죠. 그것들
delivery.
만약에
These are the things
예방하지
that we
못하면 우리야말로
can
오랫동안 연구해서
prevent food
중요한
fraud.
걸 가지고 갔는데 아주 개별 인증인까지도 가지고 갔었는데 그러한 부분들이 비슷한 그러한 작물들이
We actually had a separate certificate for
부분이 있다면 그러한
food
부분들을
fraud
연구 단계부터
prevention.
사기를 예방하도록 개발자도
And now it's
관심을
included
가지고
in the additional
계획
requirements
접근해서
of
해야
this
된다라는
certificate
부분
to prevent food fraud from the very beginning
얘기고요.
of the state process.
자, 그래서 이 FSC 12000에서는
So FSSC 22000
기본적으로
has 4
우리가
parts.
햇삽 부분이 다 포함되죠. 햇삽에서는 이
Of
미세물질
course, HACCP is included.
물리적인 부분들을 평가를 통해서 유해 요소를 관리하는 기획을 햇삽
It is to control the hazards
OPRP 플랜을 통해서 하계
through
기준을 정하고
HACCP and
기준을 정해서
OPRP plan.
관리를 하도록 하고 있죠. 이것들은 다 많이 적용하고 있죠. 거기다가
So this is quite common
22000에서
standards applied.
리스크를 우리의 상황과 우리의 고객이
To further
이해관계자가
address the
요구하는
risks,
식품 안전 관련된 그러한 요구 사항을 평가해서 그러한
and to evaluate
리스크와
food
기회를
safety system,
뭔가 관리할 수 있도록 하는 그러한 계획을 수립해서 운영을 하면
we
좀더
need to have plans
여기 이제 IS
ahead
22000까지 적용되는 거고
that is specific to the company.
우리는 비의도적인 게 아닌 의도적으로 뭔가 혼입될 수 있는
We would like to prevent both intentional and unintentional hazards.
경제적인 이득을 취할 때도 위협을 할 수 있어요. 옛날에 멜라민 사건 같은 경우 그런 사건들이죠.
Just like the melamine incident
사대와 식품 방어
years
같이
back
동시에
in Korea.
발생된 사항들이 멜라민 사건이었습니다. 그래서 위협을 평가해서 우리가 이 중대한 위협을 식별해서 이 위협을
So we
완화할
need
수 있는
to
프로그램을
preemptively
해서
identify the hazards, just like the melamine,
그래야지만 안전한 식품이 만들 수 있다라는 거고요.
and address them
제품을 개발하는
accordingly and
과정에서부터
timely
이러한 사기에 취약한
to
원리
provide
그리고
safe food.
공정 중에 또 아니면 이
So we need to be able to identify food fraud from the very beginning and to identify what could be the potential hazards in order to come up with the plans to address the risks and opportunities.
더 안전한 식품이 제공될 것이라는 것을 우리의 고객들은
So that's how we can improve the food safety for the customers.
이 바이오 산업에서 정말
So in the bio industry that we are in,
이러한 고객들이 안심할 수 있도록 식품
we
사기
need
예방과
to
프로그램을
have those food safety system and food fraud prevention measures
인증 프로세스는 인증에 대해서
for sustainable growth of the
어떤 사항인지에
industry.
대해서 질문지를 통해서 파악을 하고
And the certification
그다음에
process
제안을 통해서
is
인증이
laid out
기재되면
here. You need to submit the certification questionnaire, submit a proposal,
고객에서 요구하고 있는 그 요구 사항이 다 문서화가 됐는지에 대한 확인을 하고 다 문서화가 됐으면
and the assessors will look into whether the company has documented all the requirements
2단계 심사에서 심사를 통해서
in stage 1, and in stage 2 you also have stage 2 audit
시정 조치를 통해서
4 weeks after stage 1 audit to see if you made improvements or addressed the risks identified in stage 1.
FSC 12000 이 로고가 포함된 인증서
Before you get this kind of certificate, FSSC 22000.
트렌드를 보면 인증을 많이 받고 있습니다.
FSSC 22000 international trend
지금 한 27,000년
as of October 17, 2021,
인증서가 발행이 됐는데요.
about 27,000 certificates issued. China has the largest number of
그리고
certificates
베트남도
issued.
네, 베트남이
Vietnam also has
한 1,245건? 이거 다 포함해서 그러는 것 같은데요. 예, 이렇게 동남아 쪽에
1,200.
한국은 한 950건 정도.
I think it's the East Asia,
17경에
Southeast Asia combined.
전 세계적으로 특히 이제 전 세계적으로 이렇게 유통이
So
활발해지면서
globally,
인증이 더이 코비드-19
the
팬데믹 상황에도 이제 많이 증가되고
certification
있습니다.
activity has been growing,
네,
especially after the COVID
카테고리별로
outbreak.
홈페이지에서 확인할 수가 있습니다.
You can
이렇게
see the
카테고리별로
status in the website.
카테고리 K 부분에서
You
보면
choose
이렇게
the category. For example, you choose category K.
네, 뭐 별도로 첨가물만 따로 볼 수도 있습니다. 이렇게 해서
You can see that you have 3,300 certificates in the category K.
인증을 받도록
And these companies actually
인증을 안 받았다면 아예 거래를 할 생각을 하지 않는
require
그 다음에
suppliers
제품 얘기를
to
하자고
get
하는
this
분들이
kind of
많습니다.
certification.
그래서 이러한 아까 네슬레
Without the certificate, you cannot work with these
이런
companies.
기업들이 인증을 받도록 요구하고 있고
You can see Costco and Unilever and so on.
라는 거죠. 예. 자, 그다음에 이제 해외로 확장했던 이 인증을 받고
I would also like to share a case of overseas expansion. So our client company
이렇게 제노 포커스라고 여기도
is an enzyme production company.
인증을 받았고
They received FSSC 22,000 certification,
수출하는 회사입니다.
and now they're exporting to the global market.
고객이 요구해서 받겠다고 해서 이렇게 진행을 했었고요.
They initially received this certification and applied for the certification process at the request of their client.
수출이 많이 증가됐는데 코로나
Now you can see that their export volume has increased.
그렇지만 이 회사는
Although it went down a little bit because of the COVID, but the trend is strong.
디렉터리 검증을 통해서 영국에 수출하게 됐다고 저한테 알려주더라고요.
They told me that they got to export to the UK after they got the verification of very high directory.
이 베리파이가 뭐냐면 주로 이제
Verify
지켜보고 있다라는 뭐 이런
directory.
형태로 나오고 있는데.
You can see the eye logo, like we are watching you.
당신의 회사가 우리하고 거래를 하려고 하는데
So when you work with global companies, certification is very important.
그다음에 여러 가지 그 기업이 과연 믿을 수 있는
certification,
그러한 부분들이 첫 번째 인증이다.
saying that this company is trustworthy is something that is very critical when you work with global companies. So if you consider expanding into the global market or overseas partner market, overseas markets, you need to get this kind of certifications to increase your chance.
이상 마치겠습니다.
Thank you. Thank you very much.
최근 이제 식품 관련 업체분들이 해외 진출을 할
Like you said, a lot of food companies, when they want to export to other countries, they need to get HACCP
ISO
certificate.
다른 거를 인증을 받았는데
They also got ISO 22,000.
이런 걸 강조하기 위해서 더 추가적인 이런 걸 좀 요구를 하고 있습니다. 그래서
And global companies also require additional certificates
나라들도 많이 있고 저희 국내에서도
to guarantee the trustworthiness of their partner companies.
좀 알고 있습니다.
And the trend is that a lot of more Korean companies are getting that kind of certification and applying for the certificates. Due to the time limit, I think we can ask about one question regarding the presentation. If not, I would like to ask a question.
지금 국내 기업 같은 경우가 이제 해외로 나가기 위해서 이제 많이 좀 이렇게
for Korean companies to expand into the global market compared to other countries,
하신 분들이 있는데 실제적으로 이 기업을 받으려고 하면 소요 어떤
a lot of them are small and they are just in the beginning phase of the business development.
시간적으로 좀 들 것 같고 그다음에
So it takes more time for them to get prepared, and the key question would be like how much
요거에 대한
consulting related to certificate would cost.
네. 이제 컨설팅이 있고요. 인증
So we
분야가
have
있는데요. 저는
consulting
인증 쪽이라서
division and
이제
certificate
시스템
division. I'm
구축할
in charge of
때
the
바이오 기업
certificate
같은 경우에
division.
GMP를 인증하고 있다면
When we
시설적인 측면에서는 벌써 이제
consult
기본적인
with
것들이
companies,
다돼
if
있기
the company
때문에
has a
나머지
GMP, then we
부분들에
would
대한
assume
부분만
that
좀
the
보완하면 될
company
거고요.
has like basic
시스템적인 측면에서는 이제
foundation.
선후요건 부분들을 커버하고 있어서 이제 해썹 부분들이 조금 접목되고
As for the
그리고 이제
system
식품 방어에 대한 이런
side of
평가
it,
또 식품 사기
we
예방에
would
대한
look
평가
into
이런 부분들이
hazard
되기
and
때문에
food defense
오히려 뭐
and
시설적인
food
부분들을
fraud
커버할 수 있고요. 컨설팅
prevention.
비용은 사실은 그
As for the
기업들이 준비
consulting
정도에 따라서
fee,
다르기 때문에
I think it's really related to, or it depends on the readiness of the company.
베트남하고 중국이 좀 참여를 하고 있습니다. 같이.
So we have participants from China and Vietnam.
기업에서 베트남하고 중국 쪽으로 해서 이 인증을 받아가지고 좀 그런 사례가 있다고 하면 간단히 좀 소개해 주시면
Would you like to share some cases where Korean companies received certificates for China and Vietnam?
수출한다고
So one of
쪽에서
our
이렇게
clients
아까 말씀하신
applied for the
만들어서
certificate process
중국으로 이제 수출하는 이제
to export to Walmart.
뉴팜이라고 있는데요. 거기서는 이제 그런
called Newpalm.
요구가 있어서 인증을
But because of the their client's requirements, they got that certificate and now they are thriving.
오전 섹션을 좀 마치고 다시 한번
Thank
큰
you
박수
so much.
부탁드립니다.
Give him a big round of applause again.
오전에 다시 한번 그
So that sums up our morning session. Thank you
이상으로 오전 기조 연설을 마치고
for the lectures.
사회자분께 마이크를 좀 전달하도록 하겠습니다. 네,
I would
감사합니다.
like to give the mic to Han-seok, our facilitator. Thank you.
대상을 맡아주신 이승훈 실장님, 네 감사합니다.
Thank you very much for moderating, Mr. Lee. Now we are ready to have a lunch break. Now we are approaching 12:20 in Korean time. We will have a 50-minute lunch break, and I will meet you again at 1:10 Korean time. The second session, before we start the second session, we ask you to be in your seats before the second session begins. We do have lunch ready in the cafeteria. You may enjoy lunch there, and please be here on time by 1:10. Thank you very much. Enjoy lunch.
네, 잠시 후 1시 10분부터 강원 그린바이오 국제 심포지엄이 다시 시작될 예정이오니 장내에 계신 분들은 자리에 착석하여 주시기 바랍니다. 네, 잠시 후 1시 10분부터
Shortly from 1:10, we will begin the afternoon session, the second session of the 2021 Gangwon Green Bio International Symposium. Ladies and gentlemen in the hall, please take your seats.
다시 한번 안내 말씀드리겠습니다. 잠시 후 1시 10분부터 강원 그린바이오 국제 심포지엄 두 번째 세션이 시작될 예정이오니 장내에 계신 분들은 행사장 자리로 착석 부탁드리겠습니다. 네, 식사 맛있게 하셨나요?
I hope you had a good lunchtime.
지금부터
Now we will
2021년
begin
강원 그린바이오 국제
the
심포지엄
afternoon
두 번째
session
세션을
of the
시작하도록 하겠습니다.
2021 Gangwon Green
두 번째
Bio
세션은
International
중국
Symposium.
그린바이오 산업
We will now
연구
start the
현황을
second
주제로
session
강원대학교
on the topic of green bio industry research status in China, chaired by Professor Yeonho Jung from Gangwon National University. The professor is already here with us.
큰 박수 부탁드리겠습니다.
Let's welcome him with a round of applause.
네, 이후 순서는 자장님께서 진행 부탁드리겠습니다.
I'll hand the mic to the chair now.
감사드립니다.
Professor,
저는
thank you for the introduction.
받은 강원대학교 의생명 융합학부의 정연호 교수입니다.
I am Yeonho Jung, a professor of Gangwon National University as introduced. Session 2 is on the green bio industry research status in China.
특별히 이 그린 바이오가 그 범위가 굉장히 넓은데
Now, a green bio industry is a broad sector. Usually we think about ramping up the productivity of crop yields and many other production-related topics. But in green bio industry, we also need to think about how to apply these technologies into red bio and white bio industries, how it is applicable, and how it can be commercialized. These are some of the topics we will be touching upon in the second session. This has to do with production development, but in the red bio industry, it can be taken as resources or raw material. So how green bio and red bio merge, or how green bio and white bio touch upon each other's sectors, that could be related to our session's topic today. Now, most of the bio industry players think hard about manufacturing and product development. Having said that, we will be focusing on two types of sources. One is the wild types, and others will be crops. So how the natural resource coming from the forest resources touch upon the red bio industry, and how the crop yields or crop-related products can be applied into different industries. That would be white bio industry. Those are the two topics we will be touching upon during today's second session. Now, without further ado, I'd like to invite our first speaker. We have Professor Tao Tong from China Agricultural University.
各位领导、各位同仁，大家好，我是童涛，
안녕하십니까?
大学。首先呢，感谢江源绿色生物论坛的邀请，感谢吉林省绿色食品研究院的支持。
만나뵙게 되어서 반갑습니다.
在这里
우선 강원 그린바이오 국제 심포지엄 요청과吉林省녹색식품공정연구원 지원에 대해 감사를 드립니다. 좋은 기회를 주셔서 제가 디하이드로 케르세틴에 대한 연구 상황을 소개할 수 있게 되었습니다. 먼저 자기소개를 하겠습니다. 저는 한국과 인연이 깊습니다. 한국에서 8년 동안 좋은 추억을 갖고 있습니다. 2014년에 중국에서 석사학위를 마치고 2018년 연세대학교에서 박사 공부를 마치고 귀국해 중국 농업대학교 식품학원에서 근무하게 되었고, 저는 오늘은 아래와 같이 백두산, 장백산 생물 현황에 대해서 소개하고 디하이드로케르세틴 연구에 대해 중점적으로 소개드리겠습니다. 제가 소개해드릴 내용은 아래와 같이 4개 부분입니다. 첫 부분은 도입 소개이고, 그 다음으로 디하이드로케르세틴의 추출과 식품 원천, 세 번째 중점적으로 소개할 내용은 디하이드로케르세틴의 생물 활성, 넷째는 중국에서 연구 현황을 소개해드리겠습니다.
长白山是整个欧亚大陆东沿的最高山系，地处中国吉林省的东南部，也与位临中国的朝鲜相邻。因其主峰呢多白色浮石和积雪得名，
As you know, Changbik Mountain is a vast land with beautiful scenery. And what you see in this slide is the Cheonji Lake on top of the mountain. In 1986, the Chinese government has designated Changbik Mountain as a natural reserve area. Changbik Mountain currently has 2,277 more species in botanically, and there are more than 4,300 mushroom species, and animals and minerals number up to more than 1,700. In Europe and Asia, in the continent, it's one of the most biodiverse areas on the continent. And Changbik Mountain has 15 medicinal animals. That's more than 870 medicinal plants. And among those, we have 29 medicinal animal-related species, and the natural resources are abundant. Ginseng and other herbal medicines are edible, and efficacy has been proven. Today, I am going to talk about the dihydroquercetin, the DHQ. It's also named taxifolin. The DHQ is usually found in a species of pines across the Changbik Mountain that are rich in the DHQ. This year, April this year, DHQ was designated and proven by the Chinese authority to be for its efficacy as a food product. That authority works just like the Korean FDA, KFDA. Now I'd like to talk about the plant origin and the extraction of the DHQ. If you look at the characteristics of the DHQ, it's a 2,3 dehydroderivative of quercetin. It's colorless, it's a needle-like crystal, 50% in, 50% ethanol, and it melts at 200 to 210 degrees Celsius. It's easily soluble in ethanol and has acidic properties as well. DHQ originates from usually pines and diverse species of pines. And other plants as well have DHQs found in them, including roses, grapes, and grapefruits as well. Largely pine trees that are found across China, some in Korea, Hacheon City and Unnam City as well in China. How we extract DHQ from botanical plants and species. This is how it's done, as you see on the slide. We usually use boiled water, high temperature water. That's called the enzyme incubation water extraction method. We also have the refluxing extraction with ethanol and acetone. And ultrasound and microwave assisted alternate extraction is also possible. Now, usually the edible products made of DHQ is produced in the US and Russia, mostly coming from Russia, probably because of their vast land and great produce of pine trees. Globally speaking, the produce yield is about 20 tons, and out of that, about 10 comes from Russia, and another 10, most of the 10 comes from China. And the Jilin company has DHQ products using the natural ingredient as pine trees. The whole process of homogenating, cavillation, all the way to dispersion is done there.
下面呢，我将重点介绍一下二型货币。
Now I'd like to focus a little bit on the bioactivity of DHQ.
在介绍生物活性之前呢
Before I go into my slide, let me cover just briefly what I didn't put into my PPT slide due to the time constraints. I didn't put in all the numbers of the safety composites of DHQ. According to studies, DHQ is a very stable natural substance or resource. The stability is higher than quercetin, and DHQ was discovered in the 20th century in the 50s, and academics in China and abroad was very excited about DHQ, and studies followed one after another. The academia did discover many different efficacies related to DHQ, including antioxidant activity, anti-inflammatory activity, genotoxic activity, and hepatoprotective activities, to name a few. In 1996, academics in Russia were the first to introduce the antioxidant activity of DHQ. And they reported that through their lab tests, they input DHQ into the lab rat's liver, and they found an efficacy of suppressing the oxidation of the liver cells in the lab rats. So that was the reported antioxidant activity of DHQ. In other lab tests, we did see the suppression of heart cell deterioration, and DHQ had SOD, CAT, and other factors, other profiles proven through the labs. After I returned to China from Korea, I've been focusing more on chronic metabolic disorders, such as insulin deficiencies, obesity, and so on. And in these studies, DHQ is proven to be more and more important. I'm currently working with the Jilin Green Food Engineering Institute on DHQ studies. As you know, when you talk about insulin deficiency or insulin resistance, that's diabetes, and most of the diabetic people are type 2 diabetes. That takes about more than 90% of the patients. Our projection is that by the time it reaches 2045, we will have 30% more diabetic patients. So you can easily imagine the impact on the healthcare industry from that change or projection. That highlights more importance of the DHQ and its efficacy and the studies related to that. Now, anti-diabetic activity proven from DHQ has to do with the alpha glucosides and alpha amylase in vitro. And this is proven in the labs with animal testing. DHQ has proven efficacy for suppressing diabetic symptoms, where it decreases the blood glucose and the serum. And the serum alpha amylase level in albino rats. This was proven after the diet test. And the blood glucose and serum amylase level was proven to drop significantly with DHQ. So the efficacy was proven in the lab tests, and this can be applied to diabetic cases. Moving forward with the anti-diabetic activities,
二氢货币素显著的回调 PI3K-AKT 信号通路的一
The
些
PI3K AKT pathway and metabolic syndrome
可以
rats
改善葡萄糖稳态，具有治疗糖尿病的
showed the
潜力。
results as you
由于时间
see
关系
on
呢，
the
在这里面
graphs.
相关的分子
Because of the time
分
constraint,
我不做详细
I'm
的
not
解
going to
释。
go into the details of the graphs.
我们知道，除了
As you
糖尿病
know,
之前，
aside from
目前困扰
diabetic,
全球，包括中产在内的
obesity
六
is
大
one of the
接近
key
慢性病
highlighted
之一就是
areas
肥胖。
that
肥
medicinal
胖它是由于遗
and
传因素和
patients
环境
are
因素等
also
多种因素相互
interested
影
in.
响。这个图呢显示的是
It's
我在
highly
中国的
affected
情
by
况。
environmental
我们可以看
changes,
到，
and
2000 年
China
以后，
has a growing
中
rate
国
of
的糖尿病， 中国的肥
obese
胖人
patients.
肥胖和超重人
As you
口呢
see in the
逐
graph,
步上
after
升。
the year 2000, we
肥
have
胖人口逐步上升，
16%
男性肥胖和超重人
obese
口，
men and
男性
30%
肥胖
obese
和超重人
women
口
from the Chinese population, and that's a significant
16%，
growth in
女性呢
numbers
大概
as
能到
well.
30%左右。
So that growing trend in obese
我们可以看到这个比例
patients
还是非常
are
的高。
obvious.
我们来看韩国的情况，这是整个
Now let's look at Korea's status compared to other OECD countries. So this is a projection of the based on the current number and trend of obese patients, how many increase we can expect in the future. If you look at the Korean record, you're doing pretty well, but by 2030 we do expect a significant increase in numbers. Now, DHQ does have an anti-obesity activity proven from lab tests with the lab rats given a highly fatty diet. We had a test group given the DHQ where it proved to decrease the weight significantly, and white fatty cells were decreased in numbers as well. Also, we ran cell runs to see if it lowered the level in the liver cells, and the size of those fat cells were also decreasing. Similar lab tests showed that DHQ also improves insulin sensitivity in high-fat diet-fed mice. And as some of you may already know, DHQ improves gut microbiota in high-fat diet-fed mice. It's related to the insulin level inside the system as well. And it had an impact on the number of useful microbiomes inside the system. And DHQ had an impact, as what you see on the slide is the Helicobacter numbers. So the balance was broken. Once the balance is broken, the system reacts to it, and DHQ did make some improvements to shift the balance back into order. Of course, how the detailed lab test will be needed to prove how the improvement takes place. And in our lab, we do have a mature level of testing on diabetic and obese symptoms and conditions. Another very common condition is the hepatoma, or hepatic disorder or damage, and DHQ has proven hepatoprotective activities as well. DHQ treatment had a dramatical efficacy effect that reduced liver damage, and you see the liver index. The APAP-induced liver injury was treated with DHQ and showed dramatical effects. So this was done also on rats, in the lab. And after treating those liver damages with DHQ, we saw a significant rise in the numbers, and a curing effect was proven as well. As you see in picture C, we dyed those cells and tissues, and DHQ treatment has proven some tissue repairments. So we see a correlating or relation between the anti-diabetic effect, anti-obesity effect, and the hepaprotective activity of DHQ. I think this happens simultaneously overall in the system. And of course, how the correlation works and reacts to each other, this is open for more study in the future. Now, other than that, the hepaprotective activity within the blood was shown like this. DHQ reduces inflammatory responses from APAP-induced acute liver injury in mice. As you see in the graph, you have the TNF-alpha, IL-6, TLR4, and other indications are currently improved, going lower. And this has to do with the cardiovascular activity of DHQ. DHQ prevents the IR-induced myocardial injury and enhances the antioxidant capacity in cardiac tissues. So this means we induced a myocardial injury in rats and treated it with DHQ and saw the prevention effect of those cases. It improved the dissolving effect of condition, and it had a significant improvement effect on the tissues in the heart tissue. And the antioxidant effect was also playing a role there. The MDA and active ROS levels were decreased. These studies show that the DHQ will decrease the oxidants and protect the tissues in the heart. As you know, we are seeing a graying trend globally, and Alzheimer's is one of the key issues when it comes to healthcare. And Alzheimer's is a progressive neurodegenerative disease. It has insidious onset, and it's characterized by dementia, such as memory impairment, aphasia, and so on. According to our lab results, DHQ inhibits the cognitive dysfunction by suppressing the APOE, ERK1 and 2 amyloid beta precursors, protein axis.
磷酸化水平以及淀粉样蛋白、淀粉样贝塔的分泌活性。而我们知道呢 ，APOE 是一个。
As you know, APOE is very closely related to the Alzheimer's disease. So there is some promising signs for DHQ having anti-Alzheimer activities, but we need more proven data through lab tests and animal tests. Now let's talk about the anti-cancer activity of DHQ. DHQ inhibits the progression of viability of colorectal cancer cells. Colorectal cancer has a high ratio in cancers globally, and we see a recurring incident or events of colorectal cancer. That's rates number 3 for male and 4 for female globally. According to our lab tests, the colorectal cancer cells HCT116 and HT29 did show some significant number changes in cell inhibition caused by DHQ treatment. Now, by dyeing the tissue cells, we were able to see how the DHQ is impacting the cancer cells. The DHQ is actually killing the cancer cells here, and in a nude mouse was used in this testing. We implanted a colorectal cancer cell to the rat and treated it with DHQ, and it showed that it hampers growth of the HCT116 xenograft. So it looks like a very promising option for curing colorectal cancer. DHQ also has some efficacy related to skin health. I'm also very involved in this area of study relating to improving skin with the efficacy of natural resources and natural ingredients. Now, skin aging is caused by environment, heat, and also photoaging is a big factor. Photoaging is most crucial for causing skin aging and damage of skin. According to our studies, DHQ has a beneficial effect on skin aging, especially in grown-ups. Now, in our study, we had a 3% DHQ cream applied to the skin of our subjects, and we saw a great improvement in the elasticity of the skin caused by DHQ creams. And the indexes showing the skin aging signs were improved dramatically. So this is a promising sign that DHQ can be used for the skin products in the future. Actually, DHQ is already used in this industry already globally. And as I mentioned earlier, there are many areas that DHQ can be applied to, and this will follow with future studies as well. Antimicrobial activity, anti-psoriatic activity, and pulmonary activity, and genotoxic activity, to name just a few. Now, we talked about some of the effects of the DHQ, and now I'd like to mention briefly on the application in China. As I mentioned earlier in my talk, in April this year, DHQ was proven and designated as a effective ingredient, but the application is taking some more time. In Russia and in America and in Europe, there are many applicable areas, and it is a proven good ingredient for supplements. In China, we are just in the beginning stage for applying this DHQ into products, and there are some DHQ products out there with high purity, and the daily dosage is less than 100 milligrams. For DHQ, that is over 90%. It should be kept with a dosage of daily dose of 100 milligrams. I think it has a great potential in the food supplement market as well. Currently in China, DHQ has been introduced in the cosmetics industry for R&D. It is authorized ingredients, but we do not have a noticeable product yet out in the market. The same goes for the medicinal side. DHQ does have proven activities for treating cancer and heart diseases, but the pharmaceutical products are still in the R&D stage. To wrap up, DHQ has very promising potential in new drug development, food ingredients, and additives for cosmetics. Now, DHQ is stable. It's a natural ingredient that can be used and applied in different markets and in products. I hope to see more coming up from China and from Korea.
在这里呢，我值得一提的是，通过
Now, aside from that,
在这个整理 PPT
I
和搜寻
researched
相关
some studies about
二级
DHQ,
呼吸相关研究的时候呢，我们就
and while I
通过
was
医学就发现，
researching,
就是说
I found
在
something
这
very
个新冠
interesting.
肆虐全球这个全球
It seems like
新冠
recent
新的背
studies
景下呢，
have proven that
有
DHQ
研究
could
表
be
明
a
呢，
potential
这
inhibitor
个
against
有
SARS-CoV-2
可
main
能
proteins.
抑制
And it can be further
预防这些新
analyzed
冠
by
病毒
in
所要带来的
vitro
某些
and
抑制
in
剂。
ex vivo experiments
虽然这
for
里的氦用红素
management
不是
of
从
the
这个松树中
ongoing
提取出来的，
pandemic.
而是从这个柑橘中提取出来的。
This
那我
is
认为呢，
using
应
not
该
the
这
ones
个
not
可
from the
能松
pine
树中
trees,
提取的
but
氦用
from
红
the
素呢，也有这样
citrus
的
trees.
抑制潜力。
But I believe the
当
pine
然，
tree
其他卫生的
derived
去采用分子
DHQs
对接
may
的方法
carry
去
the
做，
same efficacy
进
and
一步的进一
activities
步
of
的
profile.
细胞动物以及是
So
临床实验
I
上
look forward to
是很有
see,
必要。
noting that it's very necessary to have further
我的报
studies.
告呢，差不多到此就接近尾声。在
So
剩余的
this
时
is
间呢，
most
我
of the
简单的
introduction
用
that I
1分钟呢
prepared.
介绍一
Just
下我们的学校和我
leaving
们的
one
团
more
队。
minute for my
学校呢，我
presentation,
为
I'd
了介
like
绍
to
学校是
introduce
中
you
国农
to
业大
my
学，
school. It's
是
China
是这
Agricultural
个
University.
中国第一所农科大
It's
学。
the
我们
first
的学院
agricultural
叫做这
university
个
in
食品科
China,
学与营养工程学院，在相对于韩国的那个
and
这
it
个
is
这
working
相
just
当于韩
like
国的这个
a branch of
类似于韩
KFDA
国
in
的这个
R&D,
这个
and works like
这叫
the
什么
same
生
system,
这叫
works in the same system and
一个
manner
蛋
of
挞吧，
Korean
类似于这样一个
universities as
这
well.
样一个就是一个情况，一个机构吧，一个编制。然后我们学院呢，在食品科学、食品营养、食品加工
Our
这样的
university
领域，
has
在全国
food
全球是一个非
engineering,
常领先的一个
food
地位。然
nutrition,
后我们本人的实验室呢
and
是
food products
这个中国农业大学罗云波、黄
studies
峰老师的一个
and
团队。
departments.
我们呢，我们
We
团队在食
have
品安
several
全、
labs led by
在食品
professors.
安全、代谢、
My
以
lab
及代谢研
deals
究
with
的方
food
面呢，就是很
safety,
深很积累。
nutrition, and metabolism.
很希望今后有机会呢，能够能够去
And
在
I
家
look
园
forward
去
to
春川
once more
这个在座的
visit
这个领导
Chuncheon
在
and
座的同
Gangwon-do
仁啊，进行
and
一个
have
进行一个交
interaction
流
with
学
all of
习，
you
也
in
欢迎
person.
呢这个
All of you
春川
joining
欢迎
this
春川的
symposium
这个领导同仁，
and
欢迎
everyone in
欢迎这
Chuncheon.
个在座的各位学者啊，欢迎这个吉林省
And
立
ladies
食
and
品医院
gentlemen,
的这个
I
领导
hope you
领导
can
学
one
领导同
day
仁呢
visit
来我们
us
学院
in
呢，对我们的
Jilin
工作进行一个指导
Green Food
和
Engineering
帮助。
Institute.
谢谢大家，我的汇报到此结
Thank
束
you。very much. That's all from me.
고맙습니다.
Thank you so much for the presentation.
예, 지금부터 좀 시간이 많이 가서
Now we are a bit behind schedule, so I'm just going to limit the number of questions to 1 or 2. I think we have some from the floor.
예, 안녕하세요. 춘천 바이오산업진흥원장 유지.
Nice to meet you. I'm Ji Yu, CEO of CBF. I enjoyed the presentation.
에 대해서 두 가지 질문이 있습니다. 먼저 한 가지는 발표 자료 9페이지를 보면은
My question goes to slide 9.
스테레오케미스트리가 R로 표현이 되어 있는데요. 앞에 7페이지에는 2번 위치에 스테레오케미스트리가 S로 표시가 되어 있습니다.
My question goes to slide 9 and slide 7. The straw chemistry in slide 9 says R, and the straw chemistry in slide 7 is marked S. So I would like to ask for a little bit more explanation on how they are different.
听得见吗，洪教授？
听得到，听得到。
那个看了一下你这个化学式这边标注的是一个 S， 那么这个二氢胡皮素是如何提取的？
等一下，我看一下这个，是因为是标注错了，是标注那个有问题吗？
표기가 이상이 있는 겁니까?
예, 9페이지의 그 카본 두 번째 위치는
Did you mean there's an error in the slide?
스테레오케미스트리가 따져보면은 그게 R 폼인데요.
I'm pointing to slide 9, where the straw chemistry is marked R form, and in slide 7, it's an S form. So I am just curious what the actual straw chemistry form is.
针对这个问题，我是这样的，因为这个图呢是농모에서따온거예요。然后呢，所以说这个图，因为我不是直接来提取这样的不是在提取这方面呢不是很精通，是直接从论文中来的图。我不太这个问题可能是在图的摘抄过程中出现一个问题吧。我回去之后查一下这个7和9页这个图的区别。
그림의 표기가 이상이 되어 있는 것은 제가 찾아본 논문에서 그냥 그걸 복사를 해서 가져온 것이기 때문에 제가 다시 심포지엄 끝나면 다를 찾아서 차이를 알아보겠습니다.
예, 감사합니다. 두 번째 질문은 DHQ가
Thank you for the question. This was copied from an existing study, so I would have to double check and verify, and I will get back to you after the symposium.
2期护臂术已经有就是申请专利了吗？
2期护臂术的专利情况是这样的，据我目前掌握的信息呢，是它的提取方法专利呢，国内以吉林村工为首呢有好几个，然后它的应用专利方面的话，在我的 PPT 的就是末尾处有化妆品方面应用的一个专利，在这个药物方面呢有应用的专利，这么一个情况。
네, 특허에는 추출 방법이라면 제가 얘기한 것이 길린 산림보험 회사에서 이미 추출에 관한 특허를 이미 신청을 했고요. 그리고 활용 단계 특허는 저희 아까 슬라이드에 화장품 미약품 페이지에 지어져 있습니다.
Now the question regarding patent, there is an existing patent for homogenation and cavitation. And for cosmetic side, the patent information is in the slide. There was one more additional question online from our YouTube chat box.
산업화 과정에서 양적 공급 가능성이 굉장히 중요하다고 생각되는데요. 혹시 지금 이게 낙엽송 뿌리죠. 낙엽송 뿌리나 소나무 뿌리. 그래서 양적인 특히 뿌리이기 때문에 양적 규모 확보가 제한적일 것 같은데 혹시 이것을 농산물로부터 공급할 때 나무 유래 물질과 동일한 효능을 기대할 수 있는지요?
The question is, when commercializing such natural ingredients, I think the production, the yield of those resources are quite important. And having the natural ingredients being from larch and pine, I think we may have a limitation in the supply. Do you think we can affect the same efficacy if we get this from crops or other types of botanical resources?
实现了一个大规模提取，年产呢大概能到10吨左右，可以应该是占到世界产量的快一半吧。至于说它从其他的农作物中来实现规模提取的话，这个目前来讲的话应该是有难度的。为什么呢？因为它这个2氢护臂素存在的目前发现的存在植物中呢，主要是松树、松根。 其次呢，有一些，比如说洋葱呀，有一些这样的农作物，但含量比松树要低很多，所以说实现规模化提取有难度。目前主要还是从松树的根里面来进行大量提取。这样。
현재 대규모 수출은 소나무 우리에 제한되어 있습니다. 아까 말했다시피
Now, mass scale cavitation was made possible from the roots of pines mostly, and this is currently done in Russia in a large scale. One other crop type is the onions. But the volume of the substance yields is very limited in other types of crops and botanical resources.
네, 충분히 답변이 된 것 같습니다.
Thank you. I think that answered the question.
좋은 강연 다시 한번 감사.
Thank you very much once again for the excellent presentation.
박수함으로써
And
마치겠습니다.
we'll say thank you and goodbye
감사합니다.
with a round of applause. Thank you very much.
자, 그러면 저희 세션의 두 번째 발표해 주실 분
And now I would like to open
소개를 드리면
a
연변대학의
second presentation of session 2.
잠깐 양력
Would like to welcome Professor Tianyan Jin from Yanbian University of China.
전공에서 이학 석사를 하시고
Actually
2003년
studied
전남대학에서
a few years in Korea in Yeongnam University.
식품공학 전공으로 공학 박사를 받으셨고요. 저희
Also received doctorate at Jeonnam University.
박사후 연구원으로 강원대에서 재직하고 연구를 수행.
And he also worked in Gangwon area from 2017. Please welcome Tianyan Jin Professor.
안녕하십니까.
Good afternoon. My name is Tianyan Jin, Professor of Yanbian University of China. It is my honor to be invited to the 2021 Gangwon Green Bio International Symposium. Let me start my presentation now. I'm going to present anti-cancer and antioxidant activities of aqueous extract or water extract and ethanolic extract of Acer tegmentosum maxim on tumor cell lines. Here is the table of contents for my presentation. As we all know, tumor or cancer poses a major threat to human life. The number of deaths due to cancer ranks the second highest, as you can see here in this slide. According to research over the past 30 years, the number of deaths due to lung, prostate, and breast cancers has been on the rise. The number of new cases of lung cancer is 11.4%, breast cancer 11.7%, and prostate cancer 7.3%. Most common cancer treatments currently available include surgery, radiation, and chemotherapy. They're effective, but not without their own side effects. Meanwhile, plant-based bioactive compounds also have impressive anti-cancer therapeutic effects. They target cancer cells without destroying normal cells, and that makes them a great candidate for cancer drug development. So this is Acer tegmentosum maxim, or AT in short. It's a type of maple tree. AT grows in mountains in China, Korea, and Russia between 600 and 1,000 meter height above sea level. AT is used in the Chinese and Korean traditional medicine to treat liver-related conditions. And the Korean FDA has categorized the AT extracts as non-toxic food ingredient. There are references that say AT extracts are rich in bioactive compounds such as polyphenol and flavonoid. That's how they reduce cholesterol and skin inflammation and prevent obesity, among many other health benefits. And they also are known to prevent diabetes. However, current research on AT is limited to their effect on liver cancer cells, and there are no study done on other types of cancers.
没有进行。因此，本研究的话是对氢开体的，就是水
This
提取物和
paper analyzed
乙醇提取物
AT
对它进行
aqueous extract, or I'll say
成
water
分分析
extract,
啊
and
成分分
ethanolic
析，
extract.
然后那里边的
And we also measured the
黄土类化物
polyphenol content and flavonoid
啊
content.
对它进行了研究，还有对癌细胞啊就是癌细胞进行
We've
了
also
对
done
3种癌细胞
cytotoxicity
癌细
tests
胞
on 3 cancer cell lines,
还有
which is lung, breast, and
前列腺
prostate
细胞
cancers.
对它进行就是抗毒性研究啊，抗毒性研究。下面具体的
Materials and
方
methods.
法是什么？
So first of all,
这个
research
就是
method.
水
We
提取物的话
extracted
是在
AT water
水
extract
里边
at 100 Celsius
提取
degrees for 10
水
minutes.
里边提取10分钟
And we also
200度水里
extracted
边提
ethanolic
取10分钟
extract
乙醇的话
by
水提取物
keeping
的
the
话
AT barks in 70% ethanol for 24 hours.
24小时浸泡以后提取啊提取，然后对这个水提取物
We measured the TPC, which is total phenol content, and TFC, total flavonoid
进行了什
content,
么呢？就是
in AT water
总量和
extract and
就是总量
ethanolic
的反应
extract.
测定，主要是通过什么呢？就是通过光度计算。
Here, we used GCMS
然后对水提取物
GCMS assay to analyze them.
进行分析啊分析。
For
然后
antioxidant
它的抗氧
activity,
抗
we
氧化
did
性研究的话是对它的
EPPH
DPPH 和
and
ABTS
ABTS
就是消
analysis.
除能对它进行了研究，然后对它的抗癌
We did
性
cell
的话是
toxicity
对
tests
就是
too
这
on
个
lung
细胞
cancer
还有一
cells,
个的话就
breast
是
cancer cells, and
乳腺癌
prostate
细胞
cancer cells,
还
as
有
well as
对
normal cells.
前列腺细胞对它进行了研究，还有还有一个阳性对照啊阳性对照，然后对
And then we also conducted
对
fluorescence
它就是进
staining
行了
test.
荧光分析啊荧光分析。下面我们具体的
So
看一
let's
下啊
see the result.
这个表一的话是
Table
它是
1
就是两
is
种提取物
TPC
的
and
总分
TFC
含
of
量
two
和
types of
就
AT
是
extracts.
呃
You can
水
see that the
含量
numbers
和
are quite high.
分别是都是比较高的。表那个
Figure
图一的话
1
是
shows
它是就是
DPPH
DPPH
and
消除能和
ABTS
ABTS 消除能的
radical
就是它
scavenging
的
rate.
就是结果，在这里边可以看出，
You can see that the rate is around 70% when the concentration is 1,000 microgram per milliliter. An ideal radical scavenging rate, I would say.
这个是对水
This one
水
is
提取物
the
的成分
GCMS
最起码是
results
对它
on
进行
water
分析结
extract.
果啊分析。然后这
Figure
个
3 here
第三的话
shows
是
the
它是分别
cytotoxicity
对
test
3种
on
癌
3
细胞
types of
对它
cancer
进
cell
行了
lines.
就是毒性的实验的这种结果。毒性实验结果的话，第
Figure
A 的话
A
它是
is the HEK293,
对照
meaning
就
normal
是
cells.
对照
This
细胞
means
的
that
话
the
是它是
extract
没有
was
毒
not
性
toxic
啊
to
没
the
有毒
normal
性，
cells,
但是它对其他的肝癌细胞也
but it
好
was toxic to
前列腺细胞
liver,
也好前列腺
prostate,
癌细胞
and
也好
breast
然
cancer
后那
cells.
个就是乳腺癌细胞也好，有明显的毒性啊，明显的毒性。然后再
And we also did
进行了
IC50
IC50 这
analysis.
个 IC50 值的话是
The IC50 value of the water extract on lung cancer cell lines
值的话
was 96.32,
的话是它是
meaning
细胞的话是
it suppressed cancer cells quite aggressively.
很强的抑制力啊，抑制力。表示的话是它是对水提取
The selective index of AT water extract on cancer cells was over 10 at 17.80.
所以我们可以选择水提取物继续研究癌细胞的。
So based on these numbers, we chose AT water extract for tumor suppression research.
这是就是水提取物
This figure 4 shows the microscope
进行的
photograph
显微的这种研究啊，显微的研究，通过显微的
of AT water extract at IC50. The photographs show that lung cancer cells that are not treated with AT water extract have normal cell structure, whereas cancer cells after being treated with AT water extract showed more dead cancer cells. The tumors were shrunk, expanded, vacuolized, etc., meaning cancer cells treated with AT water extract were dying.
出现什么呢？就是癌细胞凋亡的这种现象啊，这种现象。用水处理用水提取物。
You can see more green fluorescence among lung cancer cells that were treated with AT water extract or STA.
绿色荧光的话，就是强度多少线。
Fluorine.
表明水提取物。
This shows that AT water extract causes reactive oxygen species or ROS and induces apoptosis or cell death.
图5所示啊，图5所示的话
Figure 5, the fluorescence intensity results show that the numbers are higher than those of rhodamin 123. This means much lower level of red fluorescence and fluorescence intensity percentage increased in DCFH-TA. So with these numbers, we did some simple analysis of and also data interpretation. The results told us that the AT water extract had these compounds that have clear anti-cancer effects on lung cancer cell lines. I think we can definitely do more in-depth research on this topic. To summarize, I would like to draw 3 conclusions from the research. 1, AT water and ethanolic extracts contain rich phenol and flavonoid content. 2, AT water extract and ethanolic extract have a very strong antioxidant activity. 3, AT water extract has a strong anti-cancer effect on lung cancer cell lines. I would like to thank the people and organizations that helped me with this research. I would like to thank, in particular, Professor Myung-hyun Wang of Gangwon National University of Korea and his team for their support and partnership. And thank you very much for listening. Thank you.
네, 수고 많이 하셨고요.
Thank you, Professor.
지금 좀 긴급한 공지사항이 있는데 지금 계속해서
have an emergent
지금 김철암
announcements to make.
발표에 대해서 Q&A를 진행해야 되는데 교수님께서 지금
I know that it's our turn to do the Q&A session with Professor Jin. Well, I just got the news that Professor Jin is in hospital right now for emergency, so I don't think we can do Q&A session, live Q&A session with Professor Jin. So if you have any question regarding his presentation, please leave your question in the chat box so that I can relay them to Professor Jin and do some follow-up on those questions.
대한 답변을 여러분께 드리겠다는 말씀을 드리고 다음 세션으로 넘어가야 되겠습니다.
And I think we have no other option but to move on to the next presentation. So, but before that, he talked about his research on Acer tegmentosum maxim, and it is actually a compound that Gangwon area and its related
대부분 간에 집중됐는데
institute is working on related to liver treatment.
그래서 두 번째 발표는 이것으로
His presentation was about anti-cancer activity of that compound, but we are also working on it liver-related. Now we're going to move on to the third
네
presentation.
번째 발표는 중국 그 양주 대학의 이송난
Our third presentation for the second session is given by Professor Lee Songnan Lee from Yangzhou University. Professor Lee will be presenting on OSA modified starches from molecular state to granular state.
2020년에
By trade, Professor Lee is a food engineer, and he got a doctor, a PhD from food engineering, and currently is working as a professor of Yangzhou University. I'd like to invite Professor Lee for the presentation.
Hello everyone, 我是来自扬州大学的李松南。
Hello everyone, nice to meet you. I'm Songnan Lee from Yangzhou University of China. It's a great pleasure to meet all of you in 2021 Gangwon Green Bio International Symposium. And it's an honor to give you a presentation. Today I'd be talking about the OSA modified starches from molecular state to granular state. My talk today is divided in 4 parts mainly. I'm going to start with the emulsions background and talk about research progress of OSA starch and our recent work in OSA starch in the next section, and I'm going to end with a home message. Let's go into the background of the emulsion. As you know, an emulsion is a stable dispersion of 2 or more immiscible liquids. It's held in suspension by small percentages of substances called emulsifiers. In the right condition, if the condition is right for homogenation, or you can add the emulsion, it ends up with a stable system, which we call an emulsion system. In some cases, the oil is surrounding water moleculars or vice versa. So you are looking at the schematic representation of the emulsion. So this stable state of system is what we call the emulsion system. There are different types of emulsions, mainly 2 categories, an oil and water category or a water and oil category, and 2 types of emulsions, depending on the continuous phase. The oil and water emulsion, one of the well-known examples would be milk. But it dissolves greatly. And the water and oil emulsion is like mayonnaise. And because the oil has a sticky condition or profile, it works like mayonnaise in day-to-day activities. This can easily be applied or thought of in the food products we are familiar with. The emulsion products you are probably familiar with are salad dressings or sauce like mayonnaise. Milk also applies, as you've seen. Soft drinks, ice cream, and other nutritional beverages also are emulsions. And OSA modified starch is one of these examples. So let me talk about starch. What is starch? It's a natural polymer, mainly composed of glucose. The main substance is used by plants to store carbohydrates, and it's the most important energy source for all living organisms, as well as an important industrial raw material and additive. As you see in the picture on the right, starch-based products are used in everyday life. The rice we eat, the bread, and the food products, animal food, the pet food, ethanol-based food, ethanol-based products, that is, medicines, even paper and glue for engineering also are based on starch. So if starch comes from plants, which part of the plant are we talking about? Usually it's the seed, the cereal grains, like in maize, rice, wheat, barley, and potatoes. The potatoes and cassava are the root parts that yield starch. And leaves also give starch as well, and fruits are not an exception. The main yields of starch come from maize, rice, wheat, potato, and cassava. Those are high in starch. And there are different types of starch as well. It's usually divided into different shapes and sizes, and that's how we devise different types of starches. Mainly, the smallest granule of starch is about between 0.5 to 2 micrometers, and the larger starch would be flour. But flour as well has different types of granules, A granules and B granules. So they are different size and shapes of granules of starch, and the scale of the starch is also different in structure. Looking at the amorphous growth ring and amorphous lamella and crystalline lamella, they are all different on the structure it forms. We're looking at different types like the superhelix and lamellae and double helix and so on. Natural starch has bigger granules and are bigger in size than the particle size. And it has the hydrophilic glucose backbones causes them to display poor surface activity. The modification, well-established enzymatic, chemical, and physical modification technologies will allow us to tailor-make molecular structures that will allow us to optimize the performance of the starch in the manner we want it to act. And that can be applied into different industries and products. As you see in the right side of the slide, that's in European food law, the OSA modified starches are allowed to be used as food additives. So let's talk about OSA modified starch or OSA starch. It is a chemically modified starch. It was first synthesized by Caldwell and Wurzburg in 1953. It is a hydrophobically modified starch. That was a water phase synthesized starch. So this is the basic principle you see in the slide and the pictures. And you're looking at the helix level and the molecular level. So as the name explains, OS is octanyl succinate. So the dihydroic anhydride profile is seen in the molecular level. So in the engineering part, OSA modification is preferred over OS modification. So by adding OS groups onto the starch, you're generating or synthesizing a modified starch. That's why we call it the OSA modified starch. Sometimes it's also called OS starch or OSA starch to include all those concepts. If you look into the helix, it's a rather broader structure, and it has a higher potency of OSA group in it in the molecular level. The OSA synthesis principles are as you see in the slide. OSA starches in the commercial area are greatly preferred and common in the international market. Roquette or Tate & Lyle and other players are dealing with OSA starches, and some companies in China are also producing OSA starch-related products with great produce and exports as well. OSA starch is already active in the application, including in drinks, powders, cosmetics, plastic products as well. So how do you generate or synthesize a commercial OSA starch? First, the OS group is mainly distributed in the amorphous area, and increased OS groups to improve the hydrophobicity of enzymatic hydrolysis for better emulsification properties. So if you do not increase the OS groups, if you do not improve the hydrophobicity, most of the OS groups will not have the desired emulsification properties and will not be fit for the commercial application. So emulsification is needed for commercializing. The current researches on OSA starch is mainly reviewed in these 3 studies. And these are the references I've taken from 2013 through 2018, studying OSA modified starch. It provides a thorough and comprehensive explanation on OSA starch. OSA starch in the commercial area is, as you see, has a network structure in the molecular stage. And a molecular stage, a stable emulsion system, is just as the conventionally known emulsion system. But as you know, commonly emulsion systems are going to be unstable once heated. So over time, it will become unstable. So the stability will decrease over time. You will see the clogging or clotting or dissolving over time. In the commercial area, in the production line, we are aiming it to have a more stable emulsion system. So why don't we just leave it as a granule? We want to put it into a structure to make it more stable. Now in the lab, before molecular dispersed in water, it's not a clear emulsion. Later on, after it is emulsified, we have a clearer substance because the molecular structure is changed. And through lab tests, we have seen the difference between the synthesized emulsified emulsion systems compared to the conventional emulsion systems, particularly in the stability of the molecular structures. The stabilization mechanisms between the 2 are different. The conventional or traditional emulsions are on the top, compared to the Pickering emulsions. This is after emulsification is done. You can see the tissue wrap around the surface level. And to give you an example of the Pickering emulsion, it's an emulsion system stabilized. As you see in figure A, it's a colloidal particle. It's a series of colloidal particles. And it has outstanding storage stability, and the strength is much more improved, mechanically speaking. That means it has various application possibilities, including bioactive delivery and functional materials. So they can merge or group together very easily. And that can be used in production of raw materials. And Pickering emulsion is currently used in different industries. So why do we choose OSA starch? That means why are we going with the Pickering emulsifier? Because starch is a natural biograde that's edible, abundant and derived from natural sources. The main source of carbohydrate is in the human diet. It can be easily processed, easier than cellulose to process, and it's stable, as I mentioned before. It's stable in higher temperatures and higher pH or lower pH compared to protein and lipids. And Pickering emulsions cannot be synthesized with using natural starch. It does need the modification process to have the Pickering emulsifier possible. So the OSA is needed for that effect that we're going for. My lab team is studying OSA starch, and we're particularly focusing on decreasing the size and the hydrophobic modification. With the controlled release, we are focusing on getting the result of a nest stability. That's pretty much self-explanatory in the picture you see on the slide. Now, the size effect is there when you talk about the starch granules with different particle size. We chose 4 different sizes between 1 through 5, and from 5 to 10, from 10 to 20, from 20 to 30 micrometers. Now, that's the range of the particle size. There's no obvious change in the shape and size after OSA modification through that lab test. We emulsified both natural starches and OSA modified starches at the same time and had a verification test. And smaller the granule size, we saw the stable and formulating profile was higher and enhanced. Based on that finding, we were able to see the hydrophobic modifications. High degree of substitutions increased slightly the average particle size and significantly increased the hydrophobicity, indicating improved emulsification ability. And taking a step further, the synthesized OSA starch with higher modification rates and higher emulsification rates, we saw hydrophobic modification graphs as follows. You're looking at the emulsification index in the graph, and you can improve the emulsification ability through a lab work. So you can control that For example, under the condition between 50 to 70%, with a 0.0286 emulsification rate, the emulsion will stay stable even if you flip the bottle over. So the emulsification rate is higher and can be manufactured to become higher as needed. We also ran a rheological property test. The improved emulsification ability should be related with the emulsion's network and strength, reflected from storage modules and apparent viscosity. So another side of the lab test we ran was the CLSM images. The CLSM image, as you see, shows the different number of granules inside the given size of real estate. And we saw an increase of number of granules as the emulsification profile increased. And in the second line, you see that with the bigger the size of the granules, you see a wider spread of emulsified molecules spreading away from each other. So this is our projection of the mechanism. OSA modification increased the amount of absorbed OS starch granules at the interface and enabled the efficient formation of stable emulsions with high strength. Appropriate oil volume is largely associated with the aggregation of oil droplets, resulting in gel-like emulsions, hence giving a network structure as so. At the same time, the third part of our lab test was based on the second finding. OSA starch granules stabilizing Pickering emulsion as lutein cargo. So using the lutein as a sample, we saw the emulsion system stabilization test using the granules of OSA starch. And with the lipid-soluble test, we saw how it is affecting the lutein cargo. This is what you see from the lab work. As you can see from the bottles, between the 10% and 60% range, we had an ideal emulsification rate, and specifically focusing in on the 20% to 60% range, that is the range we went for further testing. Under the CLSM, the blue images are oil phase, and the red images are OS starch granules. And the droplet stage over gel network of OSA starch and Pickering emulsion could be controlled by oil volume between 30 to 60%. And the higher the oil volume, the denser the emulsion network. That's the finding of our test. And again, we ran a test on the lutein cargo, as I mentioned earlier. This was a test on the cargo stability. And the emulsion with the lutein, the half time of lutein in the emulsion increased from 24 to 41 days with the increase in oil volume from 20 to 60%. So if you take the same principle and repeat the work, you can increase the stability of the emulsion system and have a higher shelf life, a longer shelf life, that is. We also had the water-soluble applicability test. That's the anthocyanin cargo.
前面我们所形成的这样一个乳液体系的
The
话，我们
OSA
也知道是水
starch-based
包油，
pickering
但是的
double
话，化学
emulsion
干是水溶性
as
的，所
the
以说我们
anthycyanine
为
in
了
cargo.
去把这种水溶性的物质把它给包起来，
The
所以说
confocal
我们是
images
需要
you
先
see on the
形成
slide
这样一个油
confirms
包
that the
水的这么一个
interfacial
体系，
activity
然后再用我
of
们的这
double
样一个
emulsions are
OSA
there,
淀粉颗粒，再进一
and
步
it
将
improved
这样一个
the
油包水的体系
stability
中再过
and
一层，
controlled release
于
of
是就是说如图
anthocyanin
文所
were
示，我
achieved.
们就制备了这样一个 OSA 淀粉颗粒稳定的这
So
样一
what
个
we prepared the
水
emulsion
包油
system
包
in two
水的这样一个
types,
双重乳
water
液体系
base and
来作为我们这样
oil
一个预
base.
送体系。就是说，如图 B 所示，就是说
As
通
you
过这
see
样
in
一个
the
荧光突谱，
figure
我
B,
们能够看
the
出，然
CLSM
后
picture shows you that
就是说它的确是
two
形成了
layers
这样
of
一个
emulsion
双重的这
system
么
is
乳液体
formed.
系，然后我们再对其这样一个这种
And
体
we
外
also
的一
ran
些
a
消
test
耗、
on
铁
the
环素
external,
又做了相关的实验，而且我们
the
发现
outside
就
of
是
the
说通过我
system.
们这样一个双重乳液体系
And
的
the
这个包
emulsion
白，
system
它这种
did prove
这种花色干，然后
the
它的驻
interfacial
场稳定性
activity
是
of
有
double
提高的，
emulsion
而且的话就是说它也能够达到这样一个小
with,
汤
again,
这样
as I
保持一
said
个效
before,
果。
improved stability and controlled release.
然后是关于这个 home message，
That brings me
然
to
后
the
是关于说这个
final
home message 这一
segment,
块，
the
然
home
后的话，
message.
首先的话就是说这种分子
Now,
态的这种
commercial
生物
OSA
液的这
starch
种
in molecular
OSA 淀粉，
state
现在已
has
经被
been
普遍
widely
的应用到
applied
我们的日常生活当
in
中，
day-to-day
比如说我们日
business,
常中
especially
常
in
见
the
的一些饮
beverage and
料，还有
food
这样一些零
additives.
食的配方当中，我们可以有一些去
Although
看一下，
OSA starch
你
in
其实已
granular
经有
state
这
has
个
better
硒硫和含钙
emulsification
固醇
abilities, it is
这
still
样一
in
个
the
生物
lab
压剂存在的。
stage, and it takes
但是的
a
话，就
long
是
way
说，尽
to
管说
go
我们现
for
在已经
practical
这种颗粒
applications to
的这种
come.
OSA 淀粉颗粒， 然后
The
它的这
most
种永断
stable
稳定
shelf
性
life
会比 OSA 淀
is
粉分子态
known
会
to
更
be
好。
2 years
它
long,
最长稳定性就是说有相关研
but
究，
in the
它
current
可以
stage,
保
it
持
is still
2
in the
年这样
lab,
一个稳
so
定
it
性，
will take a
而不
little
会说这种
longer
分层的现象。
for actual
但是呢，目前
applications
相关
to
这个
show
研
up
究
in
的
the
话，
market or
还
in
是
our
主要
daily
属于
lives.
实验室的这种阶段。然后的话，就是说从实验室到我们的日常生活当中，这个 OSA 淀粉颗粒可能还会经历着和 OSA 分子
So
态
we
的这
are
种淀
looking
粉
forward to
可能
see
会
that
有
in the
会
future.
有一个类似的一个处境，可能还需要一
Based
段
on
比较长的
the
一个时
emulsion
间
formula
去
and the
调度
requirements,
到我们的日常生活
whether
当
we
中。
want to choose the
然后
molecular
的话就
stage
是说
or the
关于
granular
OSA 淀
stage,
粉分子态的
when
还
we
是颗
deal
粒
with
的，
OSA
究竟
starch,
是作何选择，这还是主要是就是根据就是说我们配置这个乳液的配方，还有这个乳液的一些特性，
and that
然后
will come to a
来去
decision
决
on
定
what
我
type
们
of
究竟选择
emulsion
这样一个分
compound
子
you're
态的
dealing with
OSA
and the
淀粉，还是这
characteristics
样
and
一个颗
profiles
粒
of
态的
them.
OSA 淀粉。其次的话就是说，
But there's no doubt it
关
is
于
going to
就
become
是
more
说
and more
跟韩国
popular.
方面的一些合作
And
方案
since
的话，
starch
就是
is
说
my
由
focal
于本
area
主要
in my
是擅
studies,
长的是关于淀
I
粉态这
am
一
looking
块，
forward to
所
see
以说
opportunities for
以后就是说
collaboration
想合作
with
的这样一个
R&Ds and
研究
labs
方
in
向，
Korea
还是希望与
and
能
for
够有这样一个
commercialization for products
就是说
development,
这种淀粉
manufacturing, and
或者是这
application
样
as
一个
well.
变性淀粉为主
I'm
体
welcome
的
to
这样一些
those
相关的一
chances
些
and
生
opportunities
产、制
and
备以及
discussions.
相关的一些这种
Thank you very
应用，
much.
然后就是说都是可以进行一些考。
네, 리송남 교수님. 네.
Thank you, Professor Song-Nan Lee, for the presentation.
리송남 교수님, 저기 우리 Q&A를
Professor Song-Nan Lee is online with us, joining us for the Q&A.
那个连上了吗，李教授？
能连上，就是说你们能够听见我的声音吗 ？Hello Hello。
네. 자,
OK.
지금
Hello.
연결된 것을
I can see we are linked.
안녕하십니까? 혹시
Nice to meet you, Professor.
플로어에서 질문 있으시면
I will open the mic to the floor to see if we have some questions from the floor. I think we have time for questions, maybe 2 or 3.
네, 교수님 안녕하세요. 춘천 바이오산업진흥원장 윤희웅입니다.
Nice to meet you, Professor Lee. I am Ju Yu from CBF. I'm the CEO of CBF.
제가 강의 들을 때 하나
Hello.
놓친 것 같아가지고 다시 한번 여쭤보겠는데
I just wanted to clarify that something I missed during your presentation. You mentioned the comparison of the traditional emulsion and the synthesized emulsion. You mentioned that the synthesized one is more stable. I'm guessing the Pickering emulsion's stability is the key of your technology. Can you elaborate a little bit more on that, please?
皮克林那个淀粉的制作方面，我不是听得特别清楚，您能再介绍一下那个皮克林的淀粉制造的这个过程？
好的。然后首先很感谢您提的这样一个很细节的一个小问题。首先的话就是说，首先我们要明确一点，这个稳定这个皮克林乳液的是这种颗粒态的。然后的话，这样一个颗粒态的话，是直接用我们所生产得到的这样一个天然的这样一个淀粉，因为天然的这样一个这种淀粉的话，它就是这种颗粒态的，然后直接用它为这样一个原料，然后通过这样一个 OSI 的这样一个这种改性，然后就能够直接去得到这样一个 OSI 改性的这样一个淀粉颗粒。但是我们现在日常生活或使用的这种 OSI 的这种商品化的这样一个商业 OSI 淀粉的话，它是还要会多加一步这样一个酶解的这样一个步骤的。然后的话，就是说它这是我们团队去研究的这样一个 OSI 淀粉颗粒稳定的这个皮克林乳液，跟现在我们就是说国内以及这样一个国际上的这种商品化的这种 OSI 这个分子态的这样一个这种淀粉上面的一个主要的这种差异，就是说，如果我们现在想直接得到这样一个 OSI 这种淀粉颗粒的话，就是说是可以直接用我们现在比较成熟的这样一个商品化的这种 OSI 这种淀粉的这样一个生产工艺，只不过是把这个酶解的它这个步骤可以把它给省略掉，然后的话就是说我们就可以直接的去获得这种商品化的这种 OSI 这种淀粉颗粒，从而就是说使用这样的一个新的这样一个颗粒态的这样一个产品，就能够得到这样一个皮克林的这样一个乳液体系了。好的，谢谢大家。
네, 문제 감사합니다. 아시다시피 정부는 그 과리평을 외워 있어서
Thank you for the question.
피커링 emulsion 그 전분을 생산하려면 직접
As mentioned during my presentation, and as you probably already knew, because we're dealing with a granular stage,
OS 변성 전분은 촉매 분해를 더한 촉매 분해 같은 그 가공을 한번더
the OSD starch-based emulsions are metastable, and traditional emulsions are not thermodynamically stable. They tend to separate into oil and water. But compared to that, through OSA modification, we use the enzymatic hydrolysis, making a more stable structure using both the granular and molecule dispersed in water. And that is the Pickering emulsion in a nutshell. Thank you for that. I have another question for you. You mentioned it's possible to increase the emulsification rate, but how does that affect the HPA value? If you have the numbers with you or that data, could you mention that?
提问一下关于那个亲水性，还有刚才那个替换度的那个问题。那么根据替换度的变化，它的那个值是如何变化的？
是一个什么氢化度还是取代度？
就是个取代度啊，取代度。
然后是取代度的这个变化会引起什么方面的一些变化？
他说是这个 pH。
pH。
后期 pH
No,
그 수치를 말하시는 겁니까?
HLB.
HRB.
What value did you mention again? The HLB.
HRB 就是HLB
The hydrophilic balance value. Is there a way to impact that?
首先很感谢您的提问。首先，这个 HLB 是这个亲水亲油平衡值的意思。然后，它这个指标的话是用于评价这种传统的这样一个乳液体系，也就是这样一个分子态的这种分子态的这样一个乳化剂是亲水还是亲油的一个主要的一个评价指标。然后的话是由于我们现在是研究的是这种颗粒态的这样一个乳化剂了，所以说如果是用这个 HLB 去评价它这种亲水亲油性的话，可能就相对而言就没有那么的合理了。然后的话，在现在的这种国际上面的一些研究的话，是常用这样一个接触角叫 contact angle， 就是说是通过是先把我们的这样一个颗粒先压成这样一个薄膜的形式，然后通过往这个薄膜的上面去滴加一滴水，然后通过去看这个水的这样一个这个水与这个薄膜的这样一个接触角，如果它大于90度的话，是说明这个颗粒态它形成这个膜是很疏水的。然后的话，如果这个角是小于90度的话，是说明它这个颗粒的这种乳化剂是很亲水的。然后的话，首先这是第一个问题。然后第二个问题的话，就是说我们就是说其中通过是提高它这样一个取代度，是因为这个 OS 的这样一个基团的话，它是这种脂肪酸的长链，就是说这个脂肪酸的长链可以赋予这样一个淀粉以这样的一个疏水性。所以说当它的这样一个取代度越高的时候，然后它的这样一个疏水性它也就是会得到一定的提高。然后所以说就是说这个亲水程度的话，就可以通过这样一个接触角的这样一个指标来体现。就是说也像是我们那个这个 PPT 里面就是说所呈现的，就是说是其中的是关于取代度的，它在这 PPT 里面就是说是有一个是在这个 SEM 图里面是有一个小的图的。然后的话它在这个小图的话就是关于这样一个这种接触角的图。然后就是说从这个4个图中我们可以看出，随着这个取代度从0到0.286这种提高，它这种接触角的数值可以从40度，然后一直变化到78度。就是说通过这个数值上面的一个变化，可以看出这个取代度的提高是可以提高它这样一个这种疏水性的。然后它这样一个这种疏水性的提高，然后就是说我的这个 PPT 里面就是说它也提到了这个数据的提高的话，就是可以提高这样一个乳化的这样一个乳化能力，以及就是说后面的这个乳液的这样一个长期的这样一个就是这样的一个驻场稳定性。而且的话就是说当在一定的条件下，就是说在这样一个高取代度以及在一定的这样一个油相体积分数这样的条件下，它是可以从这样一个乳液态然后到这样一个乳液凝胶态的这样一个这种转变的。它就是相当于是从这样的一个我们就是说经常使用的这样一个这种水这样一个形态的这样的一个就是说比较稀的这样一个乳液，然后的话就变成了这样一个比较浓稠的这样一个雪花膏。对，好的，谢谢。 네, 문제 감사합니다. 아까 HRB 평가를 한다면 그게 전통적인 분자형 에미션이 그 진수
To test the HRB value,
평가는 합리적이 아니라고 생각하고 있습니다.
there are the hydrophilicity tests, as you've seen in the slides of my presentation. And we measure the angles of the structure. If it's more than if it's larger than 10 degrees, we look at it as less stable. If it's less than 10 degrees, it can be more stable. And the lipid solubility is also a factor.
따라서
And the goal is to have a higher emulsification rate. In an emulsion system, if it transforms into an oil base, you can think of it as a cream that turns over time into a oily cream over time.
이승남 교수님 좋은 발표 그리고
Thank you very much for the questions and for the answers. Thank you once again, Professor Lee. I think that concludes our second session. Thank you very much for your attention.
네, 두 번째 세션을 진행해 주신 우리 강원대학교 정현우 교수님께 다시 한번 뜨거운
Thank you very much, Professor Hyun Jung, for chairing the second session.
네, 감사합니다. 세 번째 세션에
Thank you.
앞서서 10분간
Before we start the third session, we're going to have a break for 10 minutes. Now it's 2:45, so we're going to resume at 2:55.
다시 세 번째 세션을 시작하도록 하겠습니다. 감사합니다.
Thank you.
네, 잠시 후 저희 강원 그린바이오 국제 심포지움 세 번째 세션을
We're going to start
네,
the third
앞에
session of the
보시는
2021
저희를
Gangwon Green
따라서
Bio
다시
International
하겠습니다.
Symposium very soon.
네, 국제 심포지움 세 번째 세션을 진행하도록 하겠습니다. 세 번째 세션은 베트남
The third
그린바이오 산업
session
연구 현황에 대한
is
주제로
themed as the
한림대학교
green bio
강영훈
industry research status
산업부총장님께서
in
저자를 맡아
Vietnam.
진행해 주시겠습니다.
Will be
네,
chaired by
들어가겠습니다.
Hanyang University Professor Lee Chun
저장을
Kang.
맡은 한림대학교
Let's
강일준
welcome
교수입니다.
Professor Kang.
오늘 오후
Thank
세
you.
번째
My name is Lee
세션은
Chun Kang
베트남
from
지금
Hanyang University.
설명하신 대로 베트남과의
So, as Han-seok said, the theme of the third session is the green bio research and industry status in Vietnam. The first presenter is
키스트 원장님이십니다.
the VKIST president, Dong-hwa Kim.
공대 금속공학과에서
He graduated from the Material Science and Engineering of Seoul National University of Korea, and he received a PhD in Material Science in Stanford University. He got the postdoctorate at Stanford University. So after his study,
기획평가원의 연구기획 관리단 단장님을
he joined
또 2008년,
KIST,
2011년도에서는 국가과학기술위원회 청와대 민간위원을
and he also worked as a consultant at the Blue House of the Korean government.
그리고 2002년부터 4년까지
From 2002 to 2004, he served as the vice president of the KIST, and then he became the president of the KIST. The topic of his presentation is Now and Future of VKIST. Please welcome VKIST President Dong-hwa Kim. Good afternoon, everyone.
잠시 이렇게 다녀가게 됐었는데
I had a chance to travel back to Korea.
이런 심포지움에 참석을 해서 또 제가
I'm very happy to be joining you in Gangwon province
소개를 할 수 있는 기회를 주어졌다는 것에 대해서
and introduce to you what we are doing in Vietnam.
이 본인 개인으로서 이렇게 이런 행사에
Personally too, I'm very happy to be here today.
제가 준비한 거는 이제
What I prepared for today is a brief introduction of the VKIST,
중요한 연구 분야
our organization.
메디시널 허브 그러니까 그 천연물이죠. 그런 들도 있고 그래서 아마 이제 이런 것들이 뭐
Some of the hot topics in the green bio area are medicinal and natural products, the topics that we also do at VKIST.
우선은 이제 뭐 VKIST에 대해서
So this is the brief history of the VKIST.
현재 어떤 상황인지 말씀드리겠습니다.
Then I'll talk about our current status.
이거는 이제 그 개발 원조 사업이라고 그러죠. Development Aid.
So we started
2012년
as an ODA project, Official Development Assistance.
해가지고 박근혜 대통령이 그 방문을 하실 때
At that time, we had the President Gune Park. And when she came to Vietnam, she met with the Vietnamese president
주전에 있다 말씀드리지만
and started the discussion to establish VKIST. The following year, we officially started the building process of VKIST.
키스트가 했던 것처럼 기업을 도와주는 응용 연구기관을 만드는데
So the main object of VKIST was to sort of benchmark KIST, Korea Institute of Science and Technology, and duplicate that in Vietnam, where the institute helps companies and contribute to industrialization of the country.
베트남 국가연구소를 세우는 일부터 해서
So it was about establishing a national research institute
이거는 이제 마침
in
2018년에
Vietnam,
그 건물
benchmarking the Korean model.
문재인 대통령께서 참석.
We did a kick-off ceremony, and then we also did the groundbreaking ceremony in 2018, participated by the current President Moon.
그래서 그 베트남이 이제 이런 그 일을 하게 된 제일 큰 이유는 뭐 구태여 비교를 한다 그러면 베트남은 여러분들도 잘 알고 계시지만
Vietnam wanted to establish weakness
하나는 그 소시오 이코노믹 디벨롭먼트 스트래티지라고 해서 전략을 10년짜리 전략을 만들고
they had this 10-year strategy to socio-economic development strategy.
소시오 이코노믹 디벨롭먼트 플랜 이제 이런 과정을 하고 있는데 마침
One is another development plan called socio-economic development plan.
구태여 비교를 하라면 정확히 맞지는 않지만 우리나라의 3차 경제개발 5개년 계획
comparison, the strategy and the plan are very similar to the third industrial development plan of Korea. So that was a 5-year plan in Korea to modernize and industrialize the Korean society years back. And now Vietnam has this 10-year plan focused on industrializing, achieve industrialization. And they realize the necessity or the importance of research institutes to accelerate that.
이거 좀 보이시나요? 여기 보면은 베트남은 우리 초창기하고는 달리 이미 이제
So there are some differences between Vietnamese and Korean economic development.
나름대로의 제가 얘기한 내셔널 이노베이션 시스템이라는 게 기술이
So NIS here stands for National Innovation System. And Vietnam has a strong foundation or strong NIS.
지식을 만드는 일을 하고, 그죠? 그다음에 중간에 바스트 등이라고 그랬는데 국가연구소가 무지하게 많습니다.
You can see on the right side you have universities that contribute to research, and in the middle you have VAST.
차이니즈 아카데미 이런 것처럼
It's like
이공계 분야만
science and technology, economic.
넘는 이공계 분야의 연구소가 40개 훨씬 넘습니다. 이제 그거 말고도
They have several of those vast institutes
농림부라든지 상당히 많이 있는데
by Ministry of Information and Technology and Science and so on.
그러니까 기초 쪽에 상당히 이렇게 포커스가 맞춰져 있습니다.
So VAST and university are knowledge-based, driven
기업하고 가까이에서
model,
당장 필요한 기술을 개발을 해주는 연구소가 거의 없다시피 합니다.
where they had several research institutes, whereas they didn't have any of those research institutes in the left side of the slide, where research institutes support private companies and businesses.
같이 참여를 했다 이런 뜻이 됩니다. 이게 그래서 그러면서 이제 이 일을 하기 위해서 이게 사회주의 국가인데 새로운 패러다임을 만들어라라는 이제 총령을 만들어놨어요.
So Vietnam is a socialist country,
이게 보시면은 우선은 이제
and for them to realize industrialization, they thought that they need some research institutes that can support companies.
이렇게 하려고 그러면은 산업부에 있어야 되는 이걸 과학기술부에 둡니다. 그래서 중요한 부분이 두 가지인데.
If it was Korea, we would have established a research institute under the Ministry of Science and Technology, but it was quite different in Vietnam.
이 시계 회사가 시계를 만들어서 팔아서 이윤을 남겨서 운영을 하잖아요. 그런 것처럼
Let's say, just like clock and watch companies that make profit out of manufacturing watches, they thought that they needed a research institute that can win projects and make profits out of it
처음에 시작할
while
때부터
supporting
100%
private
컨트랙트
companies.
연구소 개념을 가지고 시작을 했고
So the basic model is
정도는 연구가 자기
100%
미션을 하다고 그래서 지원을 받지만
project-based
나머지 반은
research
경쟁적으로
institute.
연구비를 따서 운영을 합니다. 그런 것처럼 그런 연구소를 사회주의 국가에서 만들어 달라는 게 첫 번째 숙제고요.
So that was the first request
특별히 예외적으로
from
파이낸셜
Vietnam.
오토노미라 그래가지고 우리가 우리 노력으로
Another request was that this institute should have financial autonomy.
쓰는 거는 우리가 좀
So
기존의
they win
국가가
projects
지정하는 거하고 다르게
from
써서
outside, and they have financial autonomy, which means they decide how and where they spend their
그래서 이
money.
과제는 총액으로는 7천만 불인데 한국이 3,500만
So it was $70 million project, 35 million contributed by Korea,
인프라라든지 앞으로 10년
and the rest, 35 million, and land and others were contributed by the Vietnamese part.
총 책임자는 그 코이카가 맡고 있어요. 그래서
KOICA was in charge of the entire project.
그다음에 이제 나머지는
We bought
이거를 이제
building,
KIS가 위탁을 받았어요. 그래서 장비 사는 거 600만 불.
and the other parts of building the VKIS was done by Korean counterparts, like renting or contributing equipment and facilities and so on.
나머지는 여기 커패시티 빌딩이라는 부분은 그런 새로운
Also
시스템을
provided consulting, and as for capacity building, which means training,
그래서 여기에 있는 거는 이제 이건 뭐 그냥
was also provided to VKIS.
베트남에 새로운 연구소를 세우는데 코이카가 도와주는 책임자다.
So most is Ministry of Science and Technology.
아까 얘기한 나머지들은 키스트가 위탁을
So they built the building, and the rest of the project was done by KOICA, Korea International Cooperation Agency.
서쪽으로 떨어진 데 있는데
So as for the building,
여기는 이제 땅하고 이런 걸 다 도와주는 거죠. 그래서
we built the buildings in HATP, Hualak High Tech Park, near Hanoi.
넘어가겠습니다. 이거는 이제 이제 이거를 위해서
Let me move on.
근거법으로 총령이 돼 있는데 거기에
The next slide, there's a presidential decree regarding the establishment of VKIS.
구태 우리말로 한다 그러면 기술 해결사 역할을 하겠다는 게 비전입니다.
So the vision of VKIS is to be a technology solution provider for companies.
기본적으로 키스트에 벤치마킹하는 새로운 그러니까 베트남 사회주의 국가에서는 기존과 다른 연구소를 만드는 게 제일 큰 목표 중에 하나고 만드는 게
The ultimate goal is to build a Vietnamese version of KIST while taking into consideration the fact that Vietnam is a socialist country. To operate an organization like VKIS, a lot of things to consider, and a lot of supports are needed, which are given by KOICA. Like I said, it's a new paradigm benchmarking the KIST model.
선진국에서는 특별히 다른 거는 아니에요. 이제 개발.
There are many other similar cases in other advanced countries.
한국도 옛날에 잘 안 됐던 건데 이걸 하자는 거죠. 우선은.
Of course, we ourselves in Korea had some difficulties or challenges to overcome when we built our own model still.
그걸 하기 위해서 연구 친화적이다 이런 거는 뭐 여러 가지 뜻이 있습니다.
We now have a financial autonomy,
다른 연구보다 연구 장비도 좋다든지.
the VKIST or KIST model is R&D friendly
연구 관리에
institute.
있어서도 연구원들이 더 편안하게 관리를 한다든지.
So at VKIST, researchers are a priority.
프린지 베네핏. 이런 것도 더 준다든 이런 걸 다
and
포함하고
researchers get more like fringe benefits. So they are
그다음에 중요한
definitely the
거는
priority
이제 테크놀로지
at
비즈니스라고 흔히 얘기하는 기술 이전이죠. 그래서
and it's also efficient
정말
technology
기업에
business
다가가는 기업을
system.
도와주는 뭐 이런 연구소라고 생각하시면 되겠고요. 그러기 위해서
About transferring
두
technology.
개의 칼럼이 있는데 하나는
So on this slide, you see two columns. The first one is financial model. Second one is R&D model.
내용인데 뭐 키로 얘기하면은 오버헤드 시스템 연구비 과제에서 오버헤드 시스템을 만들어서 그거를 아까
As for the financial model, we have new overhead system with financial autonomy.
모델이고요. 근데 독립적으로 하기 이전에는 그 ODA 계획에서 10년 동안 베트남 정부가 이 연구소가
Before
도와주겠다는 그런 기회.
the three
그다음에
tests become fully independent, they
이런 것들을 이제
get some budget support from the Vietnamese government under the 10-year development plan and also from KUICA.
충분한 운영비를 확보하는 그런 모델이 생각하는데 그건 기본적으로 키스 있고 우리나라 정부 출연 연구소 26개 연구소가 하는 그런 PBS 시스템과 유사한 거를 만들어 주는 게 여기
But ultimately, they will have a PBS system, project-based system, just like Korean KISS system, where they were built by the Korean government, but they strive to win projects. As for R&D model, it's not just for fun, the project, it's for the market.
아까 얘기하시는 것처럼 미생물로 오는데 뭘 하라 그러면 그게 뭐가 됐든 문제를 해결하는 엔지니어링 솔루션을 먼저 만드는 우선적으로 하고
Just like microbial solutions that we talked about in the previous presentations,
나중에 한다. 대신 안 하는 경우에는 아까 제가 말씀드린 대로 베트남에는
VKIST will do some analysis on the viability or feasibility of the project and make decisions on whether to proceed on the research project.
여기에 이제 요거
It's a market pool approach.
후진국이 하면은 캐치업. 그래서 국산화.
When you think about developing countries, you would think that they need to catch up, or they would need to do catch up projects. That shouldn't be necessary. They can also do
그래서 현재
pioneering.
여기 큰 마스터 플랜을 가지고 있는데 우리한테는
We have a big master plan.
땅이 할당이 돼 있고요. 여기는 호알락 하이텍 파크라 그래서 베트남의
650,000 strong in area, located in HHTP, Hanoi.
R&D 플러스
So in Hanoi campus,
지금 이제 저희가 요 V자 형태의 건물에 이제 기계동,
we have a V-shaped building.
기계가 연구동, 여기가 본관동이 이제 다 완성이 돼서 입주해 있습니다.
For researching.
구태드리면 이게 조직표인데 연구 조직표고요.
This one is the org chart. We have research division, support division, and strategy division.
군대 싸움 하려고 그러면은 공병대 온갖 그 로지스트 다 해주잖아요. 여기는 그거 하는 부대고 여기는 가능하면
like military and troops. When you go to war, you need to support troops
여기는 브레인이다.
and combat troops.
여기 그 이코노믹 스타디라는 부분하고
Just like that, we have
강조를 해서
R&D part and strategy and planning part and admin part.
나서는 현재 국가기관으로 180명의 티어를 받았고 이건 뭐 예산은 넘어가기로
Headcount is about 180
저희가 그 새로운 시스템이라
for 2022. And we go over the budget, and then as for the operating system,
베트남은 사회주의 국가잖아요.
like I said, Vietnam is a socialist country, and
자기의 그런 어떤 봉급 수준이나 수준이 어닝 수준이 무슨 일을 하는 관계없이
Vietnamese
그냥 대충 정해집니다. 예. 그런데 이제
income level
연구원들이 그 공부를 한 사람들이
similar.
없어요. 생활을 하는데
if you are a certain age, you would earn this much.
리서치
But at
인스티튜트라는
VHS,
컨셉트 중에 공급을
we
많이 주라는 겁니다. 구태에
aim
비하면
for
베트남
TDS
가보시면 보면
system, which means that they
토탈
would earn
5배
more
이상을
if they do
줍니다.
more or
정부에서.
do better.
제가 한 배라고는 다 이해하시죠, 그죠? 그래서 그거를 꼭
When I
우리가
say
생각해봐라
한대, which
그래가지고
means Korea,
너
Vietnamese,
베이직
you
정부가
would
주는 거를 VKC
just
두 배를 줍니다.
understand as Korea,
그래서
Vietnam.
나머지는 저희가 이런
Okay, and then
벌어서
this is how the
이거는 베트남에서
salary or compensation structure is at
대학교에
VKIS.
이런 사례가 이제 먼저 있고요. 또 공공기관 특허청 같은 데 이런 식으로 지금 제대로 운영하고 있는데 이제 국가연구소로서는 이게 첫 번째.
We see similar structures at university, research institute, or government-run research institutes.
계약연구소 그걸 한다는 거고.
And now we are implementing it at VKIS. And the bottom part, you see the overhead system. This one is for the financial autonomy that I talked about earlier.
인터널 그러니까 내부 인건비라는 포션.
So you have internal labor costs
오버헤드를 흡수를 해서
and indirect costs. Combined, we have overhead.
85년도에 교육하는데 한국도 대학교에는 대학교 방마다 선생님 그 연구하는 방마다 캐비넷 하나씩 가지고 있었어요. 연구 과제를 교수님한테 주고 교수님 계좌를 넣었어요. 지금 베트남이 그렇게 합니다.
When I first joined KIST at 85, at universities, there were some cabinets with research papers at the professor's office, means that professors were the leading part of each research project, and just like that, we can see the same structure here.
그 메디시널 허브 쪽 화학 실험하고
As for medicinal herb, we have laboratory facilities.
관한 분야가 하나 있고
Like so in the slide.
이제 하드웨어가 없으니까 CAD만 하고 있는데 그 모터를 개발하는 팀이 하나 있고
There's a team that is working on motor engine, doing some CAD work right now.
이런 큰 프로젝트를 하고 있습니다.
Their team is working on imaging process, like face recognition imaging process.
실험실을 만들겠다 이런 거고.
We have planned to operate 10 labs until 2022. I'd like to sum up my presentation with this slide.
뭐 여러분들 이따가도 듣겠지만 소위 이 한약재라는 것들이 마늘뿐만 아니라 식생활에서
In Vietnam, there are a variety of Oriental herbs.
여러분 야채들이라는 게 대부분 다 메디시널 허브입니다.
They are all medicinal herbs.
그거에 대해서 특별히 이걸 더 잘할 수 있는 걸 좀 못해요. 우리 저 허준의 동의보감 책도 다 있습니다.
I think
그래서 저는
we can do better with medicinal herbs. We have a tradition of great medicinal herbalists.
베트남에 비해서 우리나라 한약재 연구하는 사람은 원료가 상당히 적습니다.
I do think that we have fewer experts in this area in Korea, and I believe that we can do better compared to Vietnam. So that's why we opened this on-site lab in Gangwon.
이제 이거를 통해서 베트남 측은 분석도 아직 잘 못하는 걸 정확히 분석하라는 걸 우리가 해주기 하고요.
So this one is KIST Gangneung Institute of Natural Products.
그런 말을 씁니다. Untapped potential.
I would say that there are a lot of untapped potential where we can leverage and create much more value. One more thing before I close. Have you ever tried the red rice in Vietnam? Nobody? So there's this fruit, red fruit,
빨간 건데 이거는 뭐
harvested like melon.
인도까지 다 많은 거예요. 이거는 사람들이 눈에
You can see them in a lot of Southeast Asian countries like India and so on.
건너뛰겠습니다. 여기에 있는 베타 카로틴이라는 게
called
훨씬 많다는
Vietnamese
거예요.
GAC,
그건
and it
베트남
has
사람뿐만 아니라 인도 사람 다 알아요.
compounds that are good
뭐를
for eye
발견하냐면은
protection.
저 강릉 분원당하고 그 해가지고
And a lot of
베트남의
Vietnamese
특정
people
지역의
know
특정
that.
시점에 채취를 한 그거를 보면 이게 이제 뭐 비교하자면 이게 이 베타카로틴이라는 거는 시금치
And the Vietnamese is working on this Vietnamese GAC
만약 여기를 하나, 둘, 셋, 넷, 다섯, 여섯, 일곱, 한 7, 80배 많죠. 이제 이런 걸
to analyze the beta carotene content in GAC.
는 뭐냐면 빨간색 그 음식에 도마도, 수박 이런 데 많이 있는데 이거는 뭐 정말 그 성인병에 좋다라는 거 아는 사람 다 아는 거예요.
The compounds that are commonly found in red fruits
제일 많이 지금 빼쓰는 데가 도마도랍니다.
that's really good for diabetes and other
거기서
diseases.
해보니까 처음에는 50배가 많다 그래 난 150배 내지 거의 200배까지 많은 이런 거를 그러니까
Initially, we assumed or projected that it would be 50 times strong in terms of the efficacy, but after the analysis in the lab, we found out that it was 150 or even 200 times stronger in efficacy. So they're working on beta carotene and preparing for patent application with that. So the value of the VKIST project is a shared prosperity between the two countries. And it's probably the largest project that KOICA is doing. For shared prosperity, I use that word because scientific technology knows no national borders.
저는 그래서 제가 이 분야에
Same for the talent.
공동 번영이라는
So I use the word shared prosperity,
세계 중에 제일 좋은 거다고 주장을 해요.
which I believe is the
이게
best
상당히
value.
사람들이 이제 그 한국의 경제 발전 모델을 다 하잖아요. 그거를 제대로 벤칭하기는 어렵고 그거 한 데 없습니다. 한국만
And
특이하고.
Vietnamese people or the government want to benchmark the Korean model, but they didn't have like clear picture or they didn't know exactly what to do or where to start. And this project is actually
장점이 있는가 하면
providing some guidance in that
저는 키스가 평생 입장에서는 우리나라의 과학기술 브랜드가 높이는 일이라고 생각이 돼요.
And I also believe that
많은 분들이 야
our
그거는
weakest
기술도
project
어떻게 하냐 이런 질문을 하지.
enhance or elevate the standing of KIST
그거는 우리가 좀 다르게 생각을 해봐야 된다. 우리는 이제는
in the world.
아닙니까?
We are now one of the advanced
똑똑해서 따라옵니다. 시간이 오래 걸리겠죠.
countries, and we know that Vietnam has great potential and they will thrive in the future.
아세안 빼면 3등이고
We
아세안은
can
지금
save their
4등입니다.
time by helping them
지금은 부가가치가 난
and working with them.
그런데 그것만 해가지고는 계속 파트너를 갈 수가 없습니다. 저는 우리나라 규모에 맞는 베트남의 부가가치가 높은 그런 걸 거래한 나라고
That's why we need to partner up with Vietnam.
베트남도 빨리 와야 우리한테 유리하다 이거죠. 그런 의미에서 이 사업은 제가 생각엔
When we are partners, if Vietnam thrives, we can also thrive.
사업이다 이렇게 설명도
So I
실제 그렇다고 생각도 하고
believe
이상입니다.
that's why this project is so important. Thank you.
질문 받는 건 아니죠?
네, 금동원장님 좋은 강의 감사합니다.
Thank you very much for the great presentation.
한 정도만 플로어에서 받도록
I would like to
필요하신 분들은 또 채팅을 통해서도
have one or two questions asked and answered. You can also type in the questions in the chat box.
잘 들었습니다.
Thank you for the
이전에 한번
presentation.
여기 좀 방문을 했었고 이제 오늘 와서
I visited just about 2 years ago.
이제 다 구축이 되어 있어서 좀 먼저 축하드립니다.
And I would like to congratulate you on the almost completion of the VKIST project and the success of it.
시범적으로 강릉 키스트하고 공동 연구를 해서 준 좋은 성과도 있고.
And the VKIST is also working with the Gangwon KIST lab.
우리 한국에서 그쪽에 있는 기관을 좀 이렇게 좀 같이 조인트해서 좀 하려고 하면 좀 그 방법론에서 좀 어렵지
If
않겠나.
the Korean institute wants to join in on the project or work with KIST and VKIST, how can that be?
노하우 내지는 그런 걸 좀 이야기해
Do you have any insights on how to do that?
못하고 올 것 같은 과 연관이 돼서 정확한 답이 될지 모르지만 제가 아는 정도 의견을 드리겠습니다.
Well, thank you for the question.
거기 있다 보니까 이제 많은 기업들이 오게 되고 제 사무실이 바로
We had many companies visiting the VKIST
되게 많이 만나게 돼요.
Also met with a lot of Korean people visiting the campus.
파트를 찾거나 아니면 기회를 찾기 위해서
We're looking for business counterparts. They also did some roadshows in Vietnam. It has that kind of activities subdued due to COVID-19, but still, I know, that's why I know that it's quite difficult to find the right partner. Project ends this year, and the infrastructure of VKIST is quite spacious, and it has strong network. I believe that VKIST can be a great catalyst that can find business counterparts, business partners for both Vietnam and Korean companies.
아직은 충분치 않지만 제가 가진 혹은 VK가 가진 장점을 가지고서 베트남의 진정한 카운터를 찾는 일을 해보려고 합니다.
It may be a little bit early now, but it is actually one of my agenda to work on.
오래 간다라는 측면에서 VK 같은 경우가
So I would love to be a matchmaker between Korean companies and Vietnamese companies. And I'm also sharing my insight and plan to my team at VKIST. Thank you very much. Due to the that sums up the Q&A session. Thank you.
Thank you once again. Now I will introduce our next speaker, if you are ready. Guest joining us for the next presentation is Professor Nguyen Van Binh from Dalat University, who will be speaking on study in medicinal plants in Vietnam. Professor Nguyen Van Binh is currently lecturing at Dalat University. He was trained in a BA, and he got his BA and MI in biology in Dalat University. He also studied in Korea in agriculture and got his PhD in agricultural engineering. After returning to Vietnam, he has been involved in many research and many projects.
Scientific Research Institute에서 연구원을 하셨고 또 베트남
He also was a researcher in the Scientific Research Institute in Vietnam. He's also has joined the research institute run by the Vietnamese government on ginseng studies.
강사로 계십니다. 주로 하시는 연구는 plant cell tissue culture, plant biotechnology,
Plant tissue culture and plant biotechnology is his area of focus in his studies. Currently, in recent years, he has published more than 15 theses in ginseng plants, especially Panax ginseng. Now we will listen to his presentation online.
Xin chào quý vị, quý anh chị và các bạn.
Nice to meet you, ladies and gentlemen. Today, I'd like to share with you my study of medicinal plants in Vietnam.
Thì phần lớn các nghiên cứu của tôi là tập trung về cây dược liệu, đặc biệt những cây dược liệu.
Most of my studies focus on medicinal herbs and medicinal plants, especially those in Vietnam. For the past 15 years, I have focused my studies on ginseng. As you know, some of the ginseng, one of the well-known ginseng forms are Korean ginseng or Panax ginseng. And thankfully, Panax ginseng also exists in Vietnam. It's also called the Ngoc Linh ginseng. We call it the Vietnamese ginseng. The academic name of it is the Panax vietnamensis. Many of you know that ginseng is a well-known medicinal plant. First of all, it has a lot of adaptogen substances. It supports the blood circulation and enhances the immune system. It is also known for its cancer prevention effects, and it improves the liver function, and it's also known for its anti-diabetic and anti-obesity effects. So taking ginseng to a sufficient substance, it is advantageous for healthcare. What you see in these photos are the 3 different species of ginseng: the Korean Panax ginseng, the Panax quinquefolis, and the Panax tripleiflum. And the other 4 you see are the Panax notoginseng, Panax japonicus, Panax vietnamensis, and Panax stipulianatis. Now, out of these 7, the Korean ginseng and the tetraploid are some are from the colder regions where it snows in the winter, and the other 4 grow in the warmer regions where it does not snow in the winter time. So they are a little bit different in their form and their characteristics. If you look at the different types of ginseng, you can understand how they have evolved, looking at their relations and their dispersion. Also, we also have a color-pass genome analysis to look into their different characteristics. As you see in the screen, the 7 different ginseng types have had the genome analysis that was done on the Korean ginseng, US ginseng, Chinese ginseng, Japanese type, and the Vietnamese ginseng, also the Panax stipulianatus and the Tripolium. We looked at the size of the ginseng and also the size of the chloroplast genome. That was 156 kb, that's about 156 kilobase. There were 114 different genes, and we built a genome map of these 7 types of ginseng. Based on that analysis, we were able to compare it with the previously analyzed Araliaceae genome map. This was taken from the data of the NCBI of the USA, and it provided us information to compare it with the ginseng genome map to see how the ginseng types have evolved over time and how they diverged over time. And we were able to build a phylogenetic tree. You can divide them into 2 different types. First, they diverged from the Panax trifolius, and then to the stipulinatus, and then to the quinquefolius. And the rest is the Panax notoginseng, which is the Chinese type, and then the Japonicus, and then the Vietnamensis. So, and the Chinese, Japanese, and Vietnamese type keep diverging and splitting into different types.
cũng như là đã xây dựng được cái mối liên hệ phát sinh loài giữa các loài sâm.
After the chloroplast genome analysis, we were able to understand the relations between the different types and where they originated. Then we moved on to the DNA barcoding. And as you know, ginsengs are very expensive. They have high value economically. So you can often find falsified or fake ginseng types in the markets. And people often blend different types of ginsengs, but that is not desirable in terms of medicinal efficacy, and it does harm the broader image of ginseng as well. So in order to prevent those disadvantages and have a better understanding and a clearer analysis on the ginseng types, we developed molecular markers. In other words, we did a DNA barcoding. So this is to discern or tell apart different ginseng types. There can be a chemical method to do this, but DNA markers has proven to be a much better way and more effective and efficient in doing so. So DNA markers are well used in molecular biolabs. It yields much more results in a shorter amount of time compared to other methods. First of all, we developed indel markers based on the previous lab results on the 5 different ginseng types. Those 5 were the Korean ginseng, the ginseng from US, Japan, China, and Vietnam. So this was done pretty successfully and was published in a journal, as you see on the screen. So we developed and positioned an indel marker. Each marker would highlight 1 type or 2 types at a time. And to tell apart different parts of ginseng, different types of ginsengs, we developed 18 different SNP markers. So we still did develop SNP markers, not just indel markers. We defined 3 different characteristics markers for the US ginseng type, another 3 for the Chinese type, and another 3 for the stipulinatus, and then for the tryptolium type. So these distinct markers were there to tell different types of ginsengs apart. Each marker would be the device to tell 1 type of ginseng from the other 6. For example, a Korean ginseng would be identifiable apart from the other 6 if you use this marker. This was also published in a different journal on ginseng research. During our study and research, we discovered that we had more types of ginsengs growing in Vietnam than we knew before. Starting from the southern region over to the highlands in the mid region, we had lots of different types if you look at the type of the shape of the leaves, the stems, the characteristics of the plants were different and proven to be different types of ginsengs. So we did our best to collect as many types as possible for ginsengs growing in Vietnam, going from different topographies and different regions, different types of farming environments in the wild, in the natural reserves, in the farms, and so on. Even in the marketplaces, we were able to find some new types as well. So after we collected as many samples as we could, we made them into samples that are usable in the labs. First of all, we characterized them and categorized them, and then we again used the molecular markers, the biomarkers, so that we can tell them apart, and we group them I won't go into detail on how we group them and how we analyze the markers because of the time constraint, but you can see from the slide that we were able to do the MAT-K of the DNA marker, and some genes were able to spot the difference from other types a little bit more distinctively, and we did categorize them into a similar group if possible. And each species came, or each types came from different samples that were collected from marketplaces, natural reserves, farms, and so on, as I mentioned earlier. Now, the Panax Vietnamese group was the first group we categorized. The second was the variation of that Panax Vietnamese. And then there was the Vietnam Lai Châu ginseng. It's a subgroup of the Hoc Lin ginseng. The third group was the Panax Noto ginseng, which is the Chinese type. And the third one was the Stipulinatus. And that was the fourth one, the third being the Chinese one. And then based on the gene analysis and the biomarkers, we did another round of the gene analysis. Mainly, we were able to distinguish them into two different groups, one being the Vietnamese and the other being the Stipulinatus, the US type. So we grouped them into two large categories based on the results of the DNA sequencing marker results. And this is the size, looking at the particles and the nucleotide and the base pair. A difference in the base pair is noticeable there, but the rest is very similar. Looking at the four different types of collected biodata, we again treat them into the phylogenetic tree based on chloroplast genomes. The Panax Vietnamese variation has LC4 and SP13, which is closely related to the Panax vietnamensis, which is also called the Ngoc Linh type. If you look at the picture below, they look very different, but actually in the genome marker, they are said to be in the same group. That is under the Panax Stipulinatus group. In the shape and size, they may seem very distinct and different from each other, but the genome marker tells us that they are closely related and belong to the same group. Now, our co-researchers in Talat University and co-authors discovered new populations of ginseng, and we named it the Panax vietnamensis variation of Langbianensis. The Langbianensis variation of the Panax vietnamensis was analyzed again using the molecular marker in order to understand it in relation with the previously discovered types. Again, we ran the chloroplast genome analysis and did a tree-based analysis to categorize them. The Langbianensis variation is there, and you can see the relations with the different types in the tree. The genome analysis, the evolution analysis, and other types of research was done on different types of newly discovered Vietnamese ginseng. And as you know, the Ngoc Linh ginseng is a particular type that grows in high grounds over 1,700 meters above sea level. They usually grow under the canopy in a forest, in a rich forest, and they endure harsh environments. So growing these types of ginseng can be challenging. We did a in vitro cultivation and succeeded at that and carried on with the research. We developed many different types of samples from them using the seeds, plant leaves, and the roots and different parts. We developed samples, generated embryos, and then we brought it to different environments where it could cultivate into a bigger plant base. You're looking currently at a one-year-old plant, and these were grown in vitro. This is what the cultivation lab looks like, and some of our work. Some Korean professors visited us at the sapling grounds. These were in the high grounds. Now, the next part of our research was focusing on the root building biomass using wind ginseng and other types of ginseng. Biomass made out of Adventist roots. And we did make the biomass with the Adventist roots of wind ginseng. This is a metabolic engineering via hairy root transformation. So aside from adventitious roots, we also had used the hairy root genes. Using the agrobacterium rhizogenes, we took the hairy root and put it into the different types of ginsengs, including the Vietnamese type and the Korean type. The hairy root cell helped it grow much faster without any other types of defunctioning or demorphing. The adventitious root and the hairy root, or either part of it, is generated, and the bioreactor system has proven to be efficient in cultivating these cells. Then we did an analysis on the ginsenoside and saw how much it is in the substance composition. In the hairy root, the ginsenoside had a high population, and it was similar to those grew in the farms of ginseng farms. Now, ginseng research isn't all the plants that we've researched in medicinal plants. We also deal with other types of plants, some of them including the Anictochilus, which is also called the gem orchid. It's part of the orchid family. It's a medicinal plant, good for the lungs, the livers, and the kidneys. These gem orchids were also grown and cultivated in vitro. We were able to get samples and embryos, and we also did the same type of analysis and grouping that you saw from the ginseng family. We also had analysis and research on the diversity of their genes and the evolutions planned for preservation. Another type of plant that we studied was the Condonopsis pilosula. These do not belong to the Panax family. They do have a rich compound of saponin, alkaloids, glucose, inulin. And these plants were also grown in vitro and taken as samples and analyzed of their genomes and grouped and categorized. This was meant for future cultivation. Now, another type I'd like to mention is the Malakia. Oftentimes we just call them Bochin ginseng. But again, although it does have the word ginseng in it, it's not part of the Panax family. So we'll just call it bojin. They do have a rich compound, especially in quinone. It's very healthy substances. It helps with dizziness or fatigue, and it's anti-inflammatory. Those are some of the known effects. And another type is the angelica. We also call it the female ginseng. Oftentimes it's because it's especially beneficial for women's health. It has a lot of angulae, amino acids, vitamins. It's rich in different types of nutrients. And it's known to have an anti-aging effect, especially useful for female immune system and the blood circulation. And there are some researches and lab works done to preserve these female ginseng angelica and to have a larger scale of cultivation in the future. In Lamdong region, we study artichokes and their medicinal effects. Again, artichokes are under the in vitro cultivation process. In Vietnam, artichokes are usually grown in Lamdong, Dalat City, but it's also exported. No, that means imported from Italy or other countries. As you see in the screen, artichokes are known to be healthy foods and healthy plants, especially beneficial for your liver and lungs. Another type worth mentioning is the dandelion family. The dandelion, especially the Pteroxacum officinale. Dandelions have a lot of different substances in the compound. If you analyze it, it is beneficial for the liver health and kidneys. And we are currently at the stage of categorizing the different types of dandelions and looking into how they are grown and how they spur. And then we're trying to run a biodiversity analysis on the dandelions currently in Vietnam labs. They are grown under the photovoltaic generation, PV generation fields for cultivation. Now, there are many other medicinal plants in Vietnam, I'm sure, and I know that Korea has a rich group of beneficial medicinal plants. The Centella asiatica is very well known for its saponin and alkaloid and many other beneficial compounds in it that is healthy. It's anti-inflammatory and it's beneficial for liver and kidney, and it has an anti-diabetic effect as well. It's also edible and food, but it's also used for cosmetics and medicines. These are some of the products that you get out of the Centella asiatica. They are well-known ingredients in foods, but also a compound for cosmetics products. And currently we are working on building back the original form of the Centella asiatica. Now, on the coastal lines of Vietnam, we have medicinal halophytes. One of them being the one you're looking at right now is the Asteraceae. Those yellow flowers is what you see, and they are rich in saponin, polyphenol, flavonoids, and it is known to have an invigorating effect and anti-inflammatory and other beneficial effects. They are easily found in the coastal areas. Currently, we are working on categorizing them and growing them in a mass scale, and also running a gene diversity analysis. This type of plant is the Tribulus terrestris. It has an abundance of different types of compounds. It's rich in tannin, saponin, and other different substances. This type is especially beneficial for male stamina, and regeneration effects are also well known too. We are currently collecting the samples of these plants, and we're considering a large-scale cultivation of them. This Limnocitrus littoralis is edible, of course. You get oil out of it, and it is easily found on the coastal region of Vietnam. They are very sweet, and the oil also has a higher oil compound compared to other citruses. We are currently working on cultivating them in a larger scale, and getting the seeds, growing them in vitro is what we do in the research labs, just to preserve the species and then have a mass cultivation when possible, if needed. This one is called the noni, or Morinda citrifolia. Nonis are rich in terpenoids, alkaloids, and flavonoids, and other types of substances. Nonis are known to help your bone structure, strengthen it, and it's especially beneficial for older people because it is known to help RA. Now, when we were studying the coastal lines for medicinal plants, we found that nonis and several other types of plants are growing better when the grounds have more sodium in it. So we were able to collect samples, and when we did a medicinal substance analysis, we compare it with the ordinary noni types with coastal region noni types and compare the medicinal effects. There are some other medicinal plants that we collected from different islands of Vietnam. This was one from Con Dao. So it's called the Con Dao ginseng, which is rich in flavonoids, alkaloids, triterpenoids, and saponin, and other types as you see listed on the slide. This has an invigorating effect, and it is especially good for antitoxinating, detoxing effects. Although it does have the word ginseng in it, again, this one also is not part of the Panax family. We did collect the samples from these islands, and we are analyzing them in the same manner. These ones are probably familiar with you a little bit more. They are available for extracting oil. As you see in the picture, they are rosemaries and lavenders. Now, these two plants, we are currently cultivating them and trying to produce seeds and species. They are known as adaptogens, and stress relief is one of their known effects. It's refreshing and comforting, and it's known to build an inhabitable surrounding when used correctly. Now, due to the time constraints, I was trying to rush through all my research objects, and I hope this was useful for you. Once again, thank you for listening, and thank you for your interest. That's it for my presentation. And also, I hope we can have some collaborative opportunities in the future. Thank you.
네, 수고하셨습니다. 자, 웅이엔 반빈 박사께서
Thank you. Dr. Nguyen Van Bin walked us through the 7 different types of ginseng, how they ran a gene analysis, and the trees, and biomarker development, and the categorization, and how they were working on the large-scale cultivation. So that was a large arena of studies, including many other types of medicinal plants. Now, we are open for questions. Professor Nguyen Van Vin, are you with us?
네.
Có đây ạ.
네, 반갑습니다.
네.
Korea, nice to
좋은
meet
발표
you.
감사합니다. 혹시 우리
Thank you again for the great presentation.
혹시
네, xin cảm ơn người phát biểu
플로어에서
của.
예.
Do
혹시
we have any
질문이
questions from
계시면은
the floor?
질문 받겠습니다. 네, 정연호 교수님.
Now we'll open the mic for the questions.
강원대 정연호 교수인데요.
Hello, I am Professor Yeonu Chung from Gangwon University.
유전자 분석을 통해서 가짜
That was an elaborate research, and I was impressed to see how much work you're doing. And
베트남 인삼인데 예를 들면 거꾸로일 수도 있고. 근데 사실은
And it was curious to see that whether it's actually a Vietnamese ginseng or Korean ginseng where it really originally came from. That was interesting too. Now, ginseng, as you know, is very well known and popular in Korea. But in Korea, we also divide between cultivated ginseng and wild ginseng because their ginsenicide profiles are drastically different. So though that is, in Korea's case, a much more important focal point in profiling these medicinal plants. So going back to your research, how is your research applied to the different
Đầu
plants?
tiên thì tôi xin tôi giới thiệu tôi là giáo sư Trần Nghiên đến từ trường đại học Gangwon, và trong phát biểu của ngài thì ngài đã có phát biểu về rất là nhiều cái vấn đề nghiên cứu, ví dụ như là phân tích về di truyền, và đặc biệt thì ngài cũng có giới thiệu về các loại nhân sâm của Việt Nam hoặc là các loại được gọi là sâm nhưng mà không phải thuộc nhóm của nhân sâm. Thì theo tôi nghĩ rằng là cái vấn đề hiện nay thì đối với những người tiêu dùng thì việc nhân sâm thì không phải là cái loại nhân sâm từ nước nào đến từ nước nào, mà theo tôi nghĩ thì người tiêu dùng họ quan tâm tới cái việc là nhân sâm tự nhiên, tức là ở trên núi, hay là nhân sâm được trồng ở đồng ruộng, tức là trên vườn hay thôi. Thì tôi nghĩ thì đây mới là cái vấn đề mà người tiêu dùng họ quan tâm, bởi vì là cái nồng độ, ví dụ như là cái nồng độ tryptophan ở trong cái nhân sâm nó như thế nào. Thì với cái sự mà nghiên cứu rất là nhiều loài của ông như vậy về các loại nhân sâm của các nước, thì tôi muốn đặt câu hỏi về tính thực dụng thực tế, tức là việc áp dụng của chúng như thế nào trên thực tế ạ.
Trước tiên xin cảm ơn câu hỏi của ông. Thứ nhất là xin gửi lời chào tới tất cả các quý vị tham dự hội thảo hôm nay. Nhất là cũng cảm ơn ban tổ chức, cảm ơn CVF đã tổ chức một cái hội thảo để tôi được cũng như là một số nhà khoa học được tham gia để trình bày một số nghiên cứu của mình. Thì thứ nhất là trở lại với câu hỏi của ông, thì thứ nhất là về nhân sâm thì là đương nhiên là cũng giống như ông nói đó, thì người ta sẽ quan tâm nhiều nhất là liên quan đến cái hợp chất của nó, cái cao hay thấp thôi. Thì là gần như là chúng ta thì lâu nay chúng ta chỉ quan tâm là sâm nó trồng trên núi hay là đó là điều tự nhiên hay là trồng ở đồng ruộng. Thì về cơ bản thì đương nhiên là về nó sẽ có hai hướng người tiêu dùng. Một hướng người tiêu dùng là sẽ thích mùa sâm trồng tự nhiên, một hướng người tiêu dùng thì bây giờ người ta muốn là giá thành, người ta muốn cái giá thành sản phẩm nó phải rẻ để có ai cũng sử dụng được. Thì chính vì thế mà người ta muốn là sản xuất nó mang chất đại trà. Thì nếu như mà chỉ trồng ở trên điều kiện tự nhiên trên núi không á, thì thứ nhất là về cái diện tích núi, diện tích đất rừng mà để trồng đủ trồng thì không đủ trồng. Thứ hai là cái công tác mà để cơ giới hóa nhân giống thì nó rất là khó khăn, chứ chúng ta không thể can thiệp được kỹ thuật được vào. Chính vì thế mà mục tiêu là chúng ta phải sản xuất được ở quy mô mang chất là đồng ruộng, hay là nói là chúng ta sản xuất được quy mô công nghiệp. Đó, chính vì thế mà chúng tôi cũng đang là hướng tới là cái phương pháp là sẽ tạo một nguồn trồng ở trên núi, một nguồn sẽ tạo trồng ở trên quy mô đồng ruộng, để thứ nhất là đáp ứng được cái target khách hàng nó khác nhau. Có người sẽ chọn sâm trồng trên núi hoặc người chọn trồng sâm đồng ruộng, thì tùy theo cái sở thích cũng như là cái nhu cầu của khách hàng. Và một cái tiếp theo đó là liên quan đến một số cái đối tượng mà không phải sâm, nghĩa là gọi là dược liệu, chúng tôi gọi tên dân gian chúng tôi gọi là sâm nhưng không phải sâm, tại vì do là nó có những cái tác dụng rất là tốt cho bồi bổ sức khỏe con người, nên được dân gian người nông dân người ta yêu quý, người ta gọi tên là sâm. Đó, và chúng tôi cũng đang tiến hành phân tích những cái hợp chất sâu hơn, cũng như là để thử nghiệm về cái hoạt tính, để xem là cái tác dụng của nó là như thế nào, để là xem nó có ok tốt không sức khỏe con người hay không, để đưa vào sử dụng. Xin chân thành cảm ơn.
네, 먼저 교수님의 질문에 진심으로 감사드립니다. 그리고 이
First
자리를
of all, thank you
빌려서
for your
인사
question, and
말씀을
I'd
여러분께
also like to
전하겠습니다.
take
오늘
this
이렇게
moment
뜻깊은
as
자리를
an
마련해 주신
opportunity to thank
CDF와
you once
여러분
again
관계자분들을
for bringing
분들께
me
감사한
to this
말씀을 다시 한번
meaningful function.
전달드리겠습니다.
It's very nice
다시
to meet you
한번
all and
교수님의
have this
질문에
chance to
대해서
talk to you.
답변을 드리자면
Now, going to your
인삼은
question,
당연히 사람들이
ginseng
흔히
is, of course,
화합물에 대한 많은 관심을 가지고 있는데요. 예를
a
들면
very popular
이
because
화합물이
of its
높거나 이제
components
함량이 높거나 낮거나
and
그런 부분에서도 많은 관심을 가지고
the
있으면
compound
또
and the
산삼이냐,
breakdown of its
야생이냐, 아니면
compounds.
밭에서
As you
재배되느냐 그런 부분에
mentioned,
대해서
the
교수님께서 말씀하신
profile can
것처럼
be
그
different
부분에 관심을
depending on whether
가지고
it's
있는데
wild ginseng or
근데
cultivated ginseng.
소비자의
That may be an interest
추세에는
point for
두
some
가지로 분류할
people,
수
but
있는데요. 첫
I think
번째는
you can see the market trend
야생,
going in two different
즉
ways. One is
산삼에
going
대한
for the wild
관심을 가지고 있는
ginseng
소비자들이 있고 반면에
and focusing on
가격이
that.
싸고
And the
그
other
몸에
market
좋지만
trend
가격이
is
싼
going for a more affordable type of
인삼에
ginseng that
대한
is
관심이 있는 소비자들이
nutritional and
있습니다.
beneficial
즉
for
두
health.
번째
So
경우에는
there are
대량
different
생산에
types
대한
of
관심이
consumer
가지고
base
있는
here.
거죠.
We're in the market.
왜냐하면 이제
So the
충분히
second
알고
type would be
계시겠지만
grown
산삼의
for
경우에는
mass
산에서
production
재배되기
or
때문에
cultivation. As you
면적이
know,
적고
ginsengs grow
또
in
번식이나
mountainous
사람들이
areas
이제
and
노고 뭐
they
이런
are
부분들이 다 어렵기
scarce in
때문에 대량
number
생산에
compared to
대한
other
추구가
crops or
충분히
plants.
있습니다. 그래서 우리의 연구의
So there
목표는
is
앞으로
a
산업화, 즉
stable
얼마나 더 많이
demand,
대량 생산할 수
and I
있는지를
think
그러한
the mass
부분에
production or
집중하였고
large-scale
또한
cultivation is the way
우리도
to
두
go
가지 통로로
to
두 가지
build on the
부분으로 구분하고
commercial side
있는데
of
첫
ginsengs.
번째는 이제 물론
Now
이제
I'd like
산에서 계속
to
재배하도록
look
이제
at it in two
유지하고 두
different
번째로
ways. We can
두
grow them
번째는
in mountains and
다양한
keep it that way, but on
다양한
the other side,
고객층의
on the different track, we can
그 요구를 충족하기 위해서는 이제 대량 생산
we
즉
can
그
reach a
밭에서
different
재배할 수
consumer
있도록
base
지금
by
부분에서
cultivating
연구하고 있으며
ginseng
또
in the farm.
산업화할
So
수
we keep
있는
it in a
방안으로 하고
two-track
있습니다.
model for the
나머지의
wild ones
목표는
and the farmed ones when it
실용성에
comes to
대해서도
ginseng
말씀하셨는데
cultivation.
사실
You
아까
also
제가
talked about the
발표하면서 그
application of our research
베트남에서
work.
삼이라고 이제
In Vietnam, when we
이라는
say
이름을 가지고
ginseng,
있지만
there
인삼
are many plants
인삼과에
that are
속해 있는
called ginseng
약용식물은
but does
아닙니다.
not belong
다만
to the Panax
민간에서
family. It's
그러한
just
삼이라는
that
이름이
they
붙이면은
have a name
그러한
ginseng, like a
그만한의 좋은
nickname,
그러니까 민간 요법이기 때문에 그만한 좋은 성과를
traditionally,
것으로 그
because they
애정용을 둔
are
삼의 이름을
proven
붙였습니다.
to be
따라서
beneficial for health.
저희가
So
이러한
lovingly,
삼을 가지고
people
있는
just
약용식물을
gave
가지고
them the nickname ginseng
생물
because it's
활성을
a healthy
실험하고
ingredient.
앞으로도 이제 대량
So I
생산의
think
방향으로
our lab work
접근을
will
하고자
go
합니다.
toward
이상입니다.
actually analyzing these and prove how
네,
they are healthy and
감사합니다.
beneficial. Thank
지금
you.
중국 길림성의
Now,
녹색식물관광원 김수령 원장님이
we have the President Suryong Kim from Jilin Green Food Engineering Institute. So I think this will be our last question.
논이가 어느 국가로 주로
I'm interested in noni. Where is noni exported mostly? And what type of products or how many types of products do you have based on noni? And where do you find these products mostly? I would ask you to be a little
xin
brief
tôi được
due to
hỏi
time
một tiếp theo là một
constraints.
câu hỏi đến từ Trung Quốc của một giáo sư đến từ Viện Công nghiệp xanh, công nghệ xanh. Thì giáo sư quan tâm tới noni, tức là về nhầu. Thì tôi xin được hỏi một câu, ngài trả lời ngắn gọn, tức là hiện nay thì nhầu đang được xuất khẩu sang thị trường nước nào và các cái sản phẩm làm ra được từ nhầu thì có khoảng bao nhiêu loại và được đang bán dưới cái dạng hình thức và con đường nào?
Xin cảm ơn câu hỏi của quý giáo sư bên Trung Quốc. Thứ nhất là nhầu thì hiện tại thì chúng tôi đã xuất khẩu cũng qua nhiều nước, đặc biệt là bên Hàn Quốc là nhiều. Có quý vị ở Hàn Quốc thì rất thích nhầu. Thì là hiện tại chúng tôi có rất nhiều sản phẩm. Thứ nhất là về trà nhầu này, thứ hai là dung dịch chiết từ trái nhầu, hoặc là ngay giờ chúng tôi bán cả cái nhầu sinh thối là nhầu khô xuất trực tiếp đi.
간단하게 이제 질문에
Thank you. To be brief
답변드리겠습니다.
and to answer
교수님
your question,
중국에 계신 교수님의 질문에 다시 한번 감사드립니다. 논의는
thank
사실
you
우리는
for
많은 나라로
the
많은
question
국가로
from
이제
the
수출하고
professor
있는데
in China.
그중에 잘
As you
아시겠지만
mentioned,
중국
noni is
시장이 제일
exported to
큽니다.
many different countries.
한국 시장이
China
제일
is one of the
큽니다.
biggest
한국에서
markets for noni,
논의 제품을
and
많이
followed by
사용하고
Korea.
있고요.
Korea
그리고 이제
is also a
제품의
big market for
종류를
noni
마시는 차
products.
있고요. 그리고
Usually,
액체용,
noni is
그리고 이제
enjoyed
건조용,
in
그리고 이제
teas
이런
or
세
liquid
가지로
types of
크게
products
분류할 수 있습니다.
and dried noni. Those are the main three.
Thank you.
Thank you very much. Thank you, Professor Nguyen.
Presentation.
네, 감사합니다.
네, 고맙습니다.
Thank you very much.
자, 저희가 조금 시간이 오버됐는데요.
We are slightly behind the schedule, but I would like to introduce to you the presenter of our last presenter of today, EcoBusiness CEO, Dr. Jung Sub-Chu.
연세대학교에서 학석사를 마치시고
He graduated from Yonsei University in '86
소재공학에서 박사를 수료하셨습니다.
and received PhD in Gangwon National University.
근무하시다가
He worked at Busan Environment Group
연구소장을 하고 계십니다.
and became the EcoBusiness Research Institute.
협의체에서 역할을 해주고 계신데요.
He's been working in various areas, also working with KIST, Korea Institute of Science and Technology,
농기자재 수출 기업 협의회 부회장, 또 강원 수출
and bioindustry-related committee member, also member of the Business People's Council.
입주 기업 협의회 회장 등을 맡고 계시고요. 뭐 여러 가지 수상 경력도 많으십니다.
And also received various awards.
기능청장의 표창장, 춘천시장의 표창장, 또 강원 환경 대상을 2020년에 받으셨습니다.
From various government agencies.
베트남 미생물 시장 진출 사례에 대한 그런 발표 부탁드리겠습니다.
So Dr. Jung Sub-Chu will talk about entering Vietnam microbe market. Good afternoon, ladies and gentlemen. We'd like to share with you the case of our company, EcoBusiness, and how we entered the Vietnam microbe market. Our mission is to contribute to a clean environment and healthy life. We aspire to be global #1 microbe solution provider. To achieve this mission, we did extensive research on microbes to develop micro business platform.
친환경 미생물 분야로 패러다임이 변하고 있는 농업, 축산, 수산 양식, 그다음에 이제 환경 분야.
Based on the paradigm shift from chemical materials to eco-friendly microbe, which has 4 columns: agriculture, livestock, aquaculture, and environment.
실적을 받아서 신뢰를 이제 구축하는.
So these are the certifications that our company has received over the years. We established the company in 2000.
일반 회사들처럼
Early days,
완제품화하고 그걸 유통하고 이제 판매를 해왔습니다. 그러다가
we manufactured and sold products.
문제가 된다 해서
Then we ran into this barrier, realizing that there should be more and we need to go beyond the Korean border.
제대로 된 사업 시스템을 갖춰야겠다라고 해서 2015년까지 이제 미생물 배양기를 개발하고
So until 2015, we worked on developing
배양해서 쓸 수 있게 하는 사업 모델을 구축을 했습니다.
cultivation system.
국내도 그렇고 해외 시장으로 저희 사업 모델을 이제
Since then, we have been providing that solution both to the local market and the overseas market.
그래서 뒤에 이제 베트남 부분은 자세히 설명을 드리겠고요. 아까 말씀드린
I have more cases or examples related to Vietnam at the later part of my presentation.
그동안 노력으로 해서 저희가 이제 미생물 관련 특허 뭐
So thanks to the research and the efforts that we put into our work, we have received various patents in the areas of microorganism, fermenter, and design,
기술에 대한 부분을 이제 지식재산권으로 이제 보호하는 노력을 하고 있고요.
and trademark registration.
일단 저희가 왜 사업 모델을 구축하게 되었는지
Why we came to build this business model.
미생물 시장은 이제 21년
The micro
전 세계 한 15조
market
4조 원 정도의 규모가 됩니다. 근데 그
is
시장에
about 15.4 trillion Korean won in value.
23%밖에 되지 않습니다. 그러니까 그 지배적 사업자가 없는 그런
And there's no dominant player. The top 5 combined
영세 기업들이
have 23% market share. So that means there are a lot of small companies, or mom and pop companies.
제일 큰 부분이 뭐냐면
The reason for that is that microbe, they have expiration dates for about 1 year.
등록된 10의 6승 뭐 이런 기준을 맞추려고 그러면 생산할 때 10의 9승, 10승을 넣어야 됩니다.
It is very difficult to get the certification from the relative authorities within that time frame.
제형화 기술이 굉장히 중요합니다. 그래서 앞서 말씀드린 글로벌
So formulation technology is key.
그게 안 되는 그러니까 실험실에서 굉장히 효과가
So if you don't have the formulation technology, you cannot really commercialize your ideas or technology.
품질이 떨어지는 그런 속도가 빠르기 때문에 농장에서 처음에 테스트
And micro products can quickly deteriorate in terms of quality. When you test it, it's good quality, but when you put them into the market, it's not that good anymore.
물을 희석했냐라는 소리까지 이제 듣게 되는 상황이 오고 또 이제 다단계 유통을 하다 보니까 특히
And it is a multi-step distribution model, especially when you export. It adds on the cost.
단계 거쳐가면 베트남에서는 5-6천 원에 사야 되고.
So let's say that it costs about $1 in Korea when we developed it and commercialized it. When you export it, the price goes up to $5.
라는 것들이 붙는데 그걸 사서 안 팔렸을 경우에 재고 처리가
And there's this inventory management issues because of the characteristics of the micro product.
어느 제품이 진짜 효과가 있고 내가 적당한지를 선택하기가 어렵습니다.
And the user, as for the users, they have difficulty in choosing and using micro products.
안정된 품질로 현지에서 생산할 수 있게 해주자.
So stable quality and local production were the key components that we identified when we developed this business model.
그들에게 공급할 때 종균.
Our business platform model is to provide microbial total solution.
그들이
We provide
비전문가라도 저희 세탁기
both hardware and software.
밥할 수 있는 것처럼 원하는
So it's like a washing machine.
양을 키우겠다는 것만 누르면
You just need to know which button does what.
공급을 하는 거고요.
When you learn how to use that machine, you can do whatever you want with that machine. So it's basically what our business platform model does.
그런 부분에 대해서 고객의 현장에 맞게 저희가 이제 커스터마이즈하는 것, 그다음에
We also customize the process and provide consulting services to our customers to continuously communicate and get their feedback.
프린터 팔고 잉크를 계속 팔듯이 저희 시스템을 도입한 고객.
So our business model features number one, repeated purchases. It's like printer. You just sell the printer, and there is continuous influx of sales from ink. And second, we also have the Coca-Cola model. You sell the raw materials and the bottling companies do the local production. And third, we also have the stable quality control. It's like the global coffee chain like Starbucks.
그래서 이제 지금 저희 사업 모델 그 비즈니스 플랫폼
So that's the business platform model that we have.
기업 그다음에 B2C 대형 농장
We do B2G government, B2B, and B2C businesses.
까지 다 할 수 있는 그런 체계를 갖췄고요. 그래서 저희 플랫폼을 이용하게 되면 이제 고객들은 미생물에 대해서
Our users
잘 사용할 수
have easy access
저희랑 지속 거래를
to micro products
저희에 대한 충성도가
and have a communication channel.
수시로 고객이 바뀝니다. 어느 게 좀 더 싸.
So as for the finished products, the clients or the customers change all the time, but we have programs, not products.
할 수가 있습니다. 그래서
And we make sure that we communicate with the customers directly and continuously.
창출해낼 수 있는 장점이 있습니다.
That's how
기존의
we established our business model, and
유통하고 판매하는 모델 대비해서 저희는
comparison of the existing model of selling the products and our model selling the program.
대양 세트를 가지고
So we sell
사용할 수 있고 재고에 대한 부분에
the culture kit,
그리고
which means lower cost for the customers. And I also talked about the price increase after various distribution steps. When you use our culture set or culture kit,
300원에서 500원이면 이제 생산할 수 있을 정도로
the
경쟁력이
price goes down to
그리고 이제 아까 제가 앞서
a third of
말씀드린
it.
것처럼 그 미생물의 활력이 저희 시스템을 해서 배양해서 사용하실 때는
And the effectiveness is also very strong compared to the existing solutions because you produce your own
그리고 이제 저희하고 상시 소통이 되고 저희
product
시스템에는 지금 와이파이나
based on your needs.
그 상태 관리를 저희가 할 수가 있습니다. 그래서 계속 소통이 가능하고요.
And then we also communicate with the customers to give our feedback and get their feedback too.
35종의 기능성 미생물을 확보를 하고
We have various functional microbes, 35 species of them, in various areas such as agriculture, livestock, aquaculture, and environment. We are continuing to do the research on these areas.
그래서 이제 저희 시스템을 적용하게 되면 단순히 필요에 따라
When
완제품
you have
사는 게 아니라
our program, you are not just buying a product.
토양을 개선한다거나 비료 사용량을 줄여준다거나
Soil,
이제
seed,
종자 처리, 작물의 성장 촉진,
fertilizer,
이제 제일 큰 부분이 이제 농약의 대체입니다.
harvest,
세균병, 곰팡이병, 각종
and
축에 의한 병들에
replacing or
대해서
removing
어떤 병이냐
pesticides
나왔을 때 저희는 그 대응하는 미생물들을
can be covered by our program.
가이드라인을 드리고 있고요.
We give those guidelines
출산 부분에는 이제
in various areas within just one area of agriculture. The same goes for aquaculture, livestock, and so on. So as for livestock, your livestock will live longer with higher quality. As for aquaculture,
시어가 이제 살 조건을 처음에 이제 플랑크톤을 먹고 살기 때문에
you will have a better environment for your aquaculture
어류나
livestock.
성장하고 면역력이 있게 하는 뭐 비브리오병
The immune system will be stronger.
그다음에 이제
Diseases will be prevented. The water quality will be better managed.
소양식 같은 경우는 바닥에 퇴적물이 쌓이는 부분이 굉장히 나중에 피해를 주는데 그 부분을 정화하는 미생물이 또 있고요.
You can also purify the water, especially for the shrimp farming.
필요한 미생물들을 이 종균과 배지 형태로 배양을 해서 이제 사용할 수 있도록 체계가 되어 있습니다.
We provide seeds and medium
다음은 저희 베트남을
as a package.
저희 타겟 시장으로 해서
Focusing more specifically on Vietnam, been working on Vietnam for 4 years. Why Vietnam, if you ask?
위치를 하고 있습니다.
It's at the center of ASEAN area.
설정을 했을 때 주변 국가 아세안으로 확장하기가 굉장히 유리합니다.
So when you have Vietnam, it is easier to expand to surrounding countries. Vietnam economy is growing really fast.
건강한 먹거리, 유기농
And they have this customer need for healthy food.
베트남이 이제 새우나 쌀, 뭐 다양한 농산물들을 해외로 수출을 하는데
And they are also a big exporter of shrimp, rice,
농약이나 항생제 잔류 허용 취약
and
부재
other
때문에 많이
products.
문제가 됩니다. 약을 사용할 경우에. 그래서
So they have this
농민들이나
needs
수산
related
양식 하시는
to
분들이 이제 그 대체제를 찾고 있습니다.
food
그게 이제 첫
safety
번째는 미생물
alternatives.
방지고요. 그래서 이제 저희가 베트남을 이제 선정을 하게 됐고,
So we selected Vietnam as our
베트남에
target
보면은
market.
이제 제일 큰 부분이 이제 농업하는 농장,
One of the
그다음에 이제
key industry of
키우양식이나
Vietnam
그다음에
is
배육업을 하고,
agriculture and
그다음에 이제 출산이
aquaculture
그렇게 구성이 되어 있고요.
and livestock.
유기농 재배 면적은 점점 해마다 이제 늘어나고 있습니다. 그래서
The
저희가
area
실제
of organic farming is growing each
파트너,
year.
실제 파트너들을 만났을 때
When we
미생물이
met with the potential partners last year, there were some high demand and
어떻게 보면
need
이제 베트남
related to
시장을
this.
전략에서 저희가 어떤 컨셉을 잡았냐면 뭐 다른
Entry strategy, there were three
바로
steps.
써보고 바로 이제 오케이가 나지만 이 미생물을
But for cosmetics or food, you just try them and know if it is good or not right away.
저희 같은 경우
What we have, what we sell,
이제 저희가 이제 미리 샘플을 드려서 확인을 하고 이제
cannot give us immediate response or
신뢰를
feedback.
얻는 게 제일 중요했고요.
And we also provide or sell
쫓아다서
fermentator, which is machine. So we need trust of the users and the customers.
춘천시나
When the early stages,
정부에서 하는 이제 수출
we participated in export conferences held by the government or city government.
사업 설명회를 하고
Also did business briefing sessions
정부에서
in
해외
Vietnam.
진출하고자 하는 곳에 테스트베드 운영을 해주셨어요. 베트남 정부와.
And thankfully, the Korean government selected us as the testbed company for entering the Vietnam market.
저희가 그쪽에 이제 건터 대학이나 달랏 대학, 농남대 등하고 이제
So we had the opportunity
구성이 됐습니다.
to work with
현재는
professors at Kanto and Dalat universities.
진행을 하고 있고요. 그다음에 지속적으로 저희가 이제 저희 사업 설명회 그다음에
After that, we continue to have business briefing sessions and seminars.
오전 오후로 해서 이제 웨비나를 통해서
We also had a webinar
사례를 가졌고
just yesterday.
또 하나 저희가 중요하게 생각하는 전략은 이 쇼룸입니다. 뒤에 뭐 사진도 있겠지만
And another important part of it is
그분들이 배양기를 한
showroom,
번도 본 적 없이 배양기를 사기는 어려운 얘기고 그래서
because it's quite difficult to buy a fermentator if you haven't seen any.
배양기를 통해서 미생물을
So you have to see the machine and test them yourself.
호치민하고 건터하고 하노이에 세 곳에 지금 운영을 하고 있습니다.
That's why we run showrooms in Ho Chi Minh, Kanto, and Hanoi.
B2B 미팅도 하고 그다음에 테스트를 하고 이렇게 진행이 되는데 저희가
In
이쪽에 있으면서
step 3, we did B2B meetings, B2G meetings, and so on.
또 저희 일을 대신해 줄 수 있는
That's why we hired a local coordinator
할 수 있도록 지금 그렇게 운영을 하고
for
있습니다.
faster
그래서 이제 내년부터
action.
저희가 그동안에 테스트하고 한 부분들이 이제 현재 계약을 맺고 있고 실적으로 다가올 것 같고요. 또 이제 이 부분을 강화하기 위해서 한국과 베트남의
We are going to enhance our efforts
전문가들과 지금 그 기술 교류회라는 거를 정부에다가 지금
by
승인하고 있습니다.
working with experts
교류를 하면서
both in Korea and Vietnam, and we're going to make requests, make a formal request to the Korean government to sponsor it.
공유하는 자리를 이제 가질 거고요. 그다음에 아까 말씀드린 대로 베트남을 중심으로 해서 이제
And like I said earlier, Vietnam is just a starting point. We are going to expand beyond Vietnam.
ODA 모델이 될 수 있습니다. 그래서 그 부분도 저희가
And I do believe this, what we do can be an ODA project.
저희가 이제 그동안
So let me show you some photos. So these are the B2B meeting photos, export conferences and business briefings, where we identify the needs of the local potential customers. And then we also did government-run export conferences to gain trust.
여기에 말씀드렸던 이제 건터대학교 내에다가
This one is the microbiology lab that we established in Kwanto University, where we did the research and tested some projects and ideas. This is the testbed photos.
사용 전후 해서 실험
Before
결과들이
after
나왔고요.
photos.
이를 통해서 저희가 제품 등록, 그다음에 그 기관의 추천서.
And this one shows the test results
세워
and
양식 하는 데서 가져 써보고 또 저희한테 테스트
recommendation letters
이걸 마케팅 자료로 좀 활용하고 있습니다.
that we are using as a marketing
현재
material.
그 세워 양장 큰 곳하고 테스트를 하기 위해서 지금 이제 플랜을 짠 거고요.
This is the plan for our shrimp farm test with NMT, one of the big shrimp farms in Vietnam.
그리고 이제 저희가 아까 말씀드린 그 이제 한국과 베트남의 미생물 기술 교류회라는 걸 결성을 해서
And this is the Korea-Vietnam Microbial Technology Exchange Forum that we held
이제 달랏에서 저희 기술 세미나 사업
early this year, and Dalat business seminar photos
그런 사례입니다.
and media coverage.
이제 그 기관하고 이제 MOU, 그 경제인 단체하고 또 이제 MOU.
We signed MOUs with Vietnamese counterparts.
appendix는 자료를 참조해 주시고
We have more slides in appendix that you can refer to if you have any questions.
감사합니다.
Thank you.
조정님, 베트남에서의 그 미생물 관련 여러 가지 솔루션.
Thank you very much for sharing your experience in establishing business solutions and entering the Vietnamese market. If do we have any questions from the floor? You from CBF.
예, 대표님 발표 아주 잘 들었습니다.
Thank you very much for the presentation.
결국은 이제 시장이 굉장히 중요할 건데요.
So the market is very important. We focused on Vietnam. And your slide showed that agriculture is bigger market than aquaculture.
나라마다 다르겠지만 아마 제 생각에는 베트남도 균충초 중에서 아마 제초제 시장이 좀 클 걸로 생각하는데 세계적으로는
I assume that pesticides market is very big in Vietnam.
제초제 쪽으로 많이 사용될 수 있는 그런 미생물입니까?
I would like to ask if the microbes can be used for pesticides. We have one species that is related to pesticides, just one. So as for pesticides, according to the recent research results, you have the technology of AI robots shooting laser to kill the pest. Technology-wise, we would like to replace and remove pesticides. Of course, like you said, the current pesticide market is very big in terms of value and market share.
그러니까 이제 그 균충초 중에서 균하고 충 시장도 상당히 큰데.
So, like you said, the pesticide market share is big. In terms of the global market share, pesticide market is the largest. And what I wanted to ask was the potential application of microbes in the area of pesticide development. To access that big chunk of market share. So I think that's one of the areas that we need to do more research on. When you focus on micro market, the market size about 15 trillion Korean won. So we have Han-seok Kim who asked a question on YouTube chat box. Who are your key customers or partners in Vietnam?
지금
especially
제가
the
이제 아까
universities.
사업 모델에서 구분을 하는 거는 이제 B2G하고 B2B를 말씀을 드렸습니다. 그래서 B2G 같은 경우는
I talked about B2G and B2B businesses that we have. And as for the B2G,
맺고 있고요.
we work
그다음에 농업
with
정책에 지금 한국에서 진행되는
Vietnamese
농업
research
기술센터
institute.
모델. 이게 뭐냐면 그 농가의 토양 시료를
We work with the
토양 분석을 통해서
Agricultural Technology Center.
비료가 얼마나 필요하다라는 분석을 해줍니다. 근데
We do some analysis on how much fertilizer they need in the farm
비료를 줬을 때
for them.
화학 결합을 해버리기 때문에 하나 둘밖에 식물이 이용을 못합니다. 그러면 농민들은 무조건 열을 매년 줘야 됩니다. 그러다 보니까 그 비료가 축적이 돼서 토양 산성화가 일어나요.
Farmers need to use a certain amount of fertilizers, and once they use that, they need to continue to do that.
그 비료 사용량 자체가 줄어드는 거고요. 또 일부 이제 공기 중에
And there's a way to provide solution to that and to reduce the amount of fertilizers
그런
used.
각 용도별로 이제 알려주고 또 배양 시설을 갖추고 농민들한테 써보게 하는 공급 사업을 합니다. 국내 농업기술센터에서.
We also work with them on the fermenter provision project.
바꾸고 이제 그걸 직접 사서 쓰거나 이제 필요한
So part of it is to change the mindset of the farmers
그다음에 이제 B2B
in
대상의
the local agricultural scene in Vietnam.
그 비료 회사가 있습니다. 근데
And Vietnam also has
미생물을 찾는데
fertilizer companies and animal feed companies.
저희가 미팅을 할 때
Some of the customers, they require some
내가 놓으면 그런 미생물을
non-commercialized solutions.
저희가 그거 공급해 드리고 그분이 생산을
We actually had
해서 팔 수 있게 해드립니다.
one of the clients who requested that kind of solution, which is exactly what we provide.
많은 부분이 비료 사료입니다.
A lot of B2B customers are fertilizer users. I'm gonna ask him the last question. I'll be brief.
주로 이제 그 응용 대상이 양식이나 뭐 농장이 될 텐데요. 베트남에 진출할 경우 그쪽
When you enter the Vietnamese market,
종류는 베트남 현지에서
you said you were selling seeds too.
지금 현재는
Do you procure seeds from Vietnam?
균주고요. 제가 이제 아까
So the seeds that I talked about were the ones that we have patents. And we also work with the research institute in Vietnam,
그 부분을 상용화하는 부분을 해본 적이
where they have great technology for ideas,
거래를 하다 보면 일단 균 내놔.
but they had some troubles commercializing them. So if they use our business model, they can actualize their technologies beyond the labs.
베트남 실정에 맞는 환경에 맞는 그런 종교를 또 개발해서 공급하는 거로 이해하겠습니다. 네, 알겠습니다.
So you're developing seeds
감사합니다.
that are tailored to the conditions of Vietnamese market. Okay, thank you. Thank you very much.
자, 이것으로 세 번째
Thank you. I believe that concludes the third session of today's symposium. Thank you very much for staying us until the end.
다시 한번 한림대학교 강일준 산학협력.
Once again, let's give another round of applause for the chair.
네, 감사합니다.
Thank you again.
그린바이오 산업화 국제협력연구
This was a rich time. We had some rich sessions with many questions and answers in the 2021 Gangwon Green Bio International Symposium. I believe it was a time of robust interaction that reached over the limitations posed by the pandemic. It was rather different to have a smaller group in person compared to other years. Once again, thank you very much for all the speakers who presented today, and ladies and gentlemen participating for joining this symposium. This concludes the 2021 Gangwon Green Bio International Symposium, and we promised to come back
서로
with
인사하면서 그 심포지엄이
even
진행되기를
better
간절히 희망해 보겠습니다.
contents, and we look
네,
forward to
감사합니다.
meet
이것을
you again.
마치겠습니다.
Thank you very much. Farewell.